This is a complete JavaScript course taught by the founder of Scrimba.com. It is a great place to start your JavaScript journey.
Hi there, free code campers, and welcome to this fun and practical introduction to JavaScript. In this course, you are going to solve over 100 different coding challenges. You can do that in two ways, either by cloning the GitHub repository and then solving it locally on your computer, or you can head over to Scrimba.com where there's an interactive version of this course so that you can solve the challenges directly in your browser. Up to you what you want to do. Links are of course provided below. Now, there's no JavaScript prerequisites for this course, but I do assume that you know a little bit of HTML and CSS as we're going to build a few projects that needs some HTML and CSS. But if you don't care about that, you can skip those challenges if you want. No worries. However, the reason is that this course is actually a part of a larger front-end developer career path, which we have at Scrimba, which takes people from zero to hireable as front-end developers. And of course, then HTML and CSS are also part of that. Now, if you have feedback for me, feel free to reach out to me on Twitter at Pierre Borgen. And if you like this video, please give it a like. I'd really appreciate that. And with that, good luck. Hey, good old buddy, old pal, and welcome to Learn JavaScript, a practical introduction. I am so excited about teaching you this course. And who am I? Well, my name is Pierre. I'm the CEO of Scrimba, and I'm also a front-end developer who's taught a bunch of courses, and over 100,000 students have enrolled in these courses. When I'm not coding, my hobby is to take photographies of myself posing in front of fast cars. But more about that later. What do I mean by this being a practical introduction? Well, it means that you will write the code. I'm not going to write the code for you. I'm just going to show you how to do it after you've given it a shot first. Because the only way to learn how to code is to write a lot of code. A clever man once said that. However, there are many ways to write code. There's the old, boring, theoretical, I'm at school way of learning to code. And then there's the much more fun way of learning to code where you actually build stuff from the get-go. And that's what you're going to do. We are going to start by building a subway passenger counter so that you can count people on the subway in case that's one of your interests. For me, it actually was for a period, or it was my full-time job when I was 19. So back in the days, I would actually need such an app. Then we are going to move on with a game, namely a Blackjack game. Oh, I just love gambling, so this is going to be so much fun. And then at the end, we're going to be a bit more serious and build a tool for salespeople, namely a so-called lead tracker. And what's so insane about this lead tracker is that it will be a Chrome extension that will deploy to Chrome so that you can use it out in the wild or send it off to a salesperson who might need such a tool because it solves one of the biggest problems salespeople have, which is to browse the web and collect and gather leads that they later can reach out to. So when you have completed these three apps, you will have the ultimate superpower in today's world, which is the power of knowing JavaScript. It is a very low percentage of people in today's world who know JavaScript, so you will no longer be like everyone else at that point. Oh, I am so ready to start this course. I hope you are too. So let's just jump into it. Your very first exposure to JavaScript will come through building a passenger counter app. Now you might ask yourself, why on earth should we build a passenger counter app? What's the point of that? Well, you'd be surprised. Because when I was 19, right around this time, my full-time job was to count people who entered the subway. So every day I would stand outside in the cold and be like, oh, so there's 1, 2, 3, 4, 5, 6 people entering the subway this morning. How interesting. And then I would bring up my pen and paper and note down the number 6, which at times was really cold. So it would have been so much better if I had a little people counter app on my Nokia phone so that I could just tap these buttons while having the phone in my pocket. But this was long before I learned to code. So instead, we are going to build this passenger counter app together so that you will learn the basics of JavaScript and so that you are prepared in case you, one time in the future, have to stand outside in the cold counting people who enter the subway. Welcome to this lesson where we are going to take a look at the setup for our people counter app. Here you can see we have a basic HTML structure, which probably looks familiar to you. You can see we have the HTML tag, the head tag, and inside of the body, we only have two elements, the h1 and an h2. That is the title up here and our counter element. We also have some styling in our index.css. You can check it out here. This is just very basic styling that we're not going to go through because you want to get into the JavaScript as soon as possible. So the first thing we're going to do actually is to simply, inside of our body tag, create a so-called script tag. Like that. Looks just like any other HTML tag. It just says script. And inside of here, we can actually write JavaScript. So inside of this tag, I'm going to write a pretty long JavaScript expression that you probably find a little bit frightening. But don't worry about that. You're not meant to really understand it in this lesson. I just want to demonstrate that this works. So I'm going to start by writing document. That refers to the HTML document itself. And then I'll do dot and get element by ID, and then open and close parentheses. And then inside of the parentheses, I'm going to copy the ID of our h2 element. So here we're saying, hey, HTML document, I want to get an element, and I want to get it by its ID. And the ID is this CountEl. So what do you think we get as a reply? Well, we grab a hold of this element right here. And then we can do dot innerText. Set that equal to, for example, 5. If I now run this code, you'll see that, boom, we have changed the text on the inside of the h2 element, this one right here, from 0 to 5 using JavaScript. And that opens up a whole world of opportunities. It essentially gives us the power to breathe life into our application and turn it into a real world product that solves problems for people. That's why this is so cool to learn. However, we are not going to write our JavaScript this way here. It's kind of an amateurish way to do it. What we rather want to do is create an index.js file. Like that. Here is our index.js file. It's currently empty. But what I'm going to do is copy this line here, then paste it into the index.js file. And now I'll add an attribute to my script tag called src, which is short for source. And then inside of here, I'm just going to write index.js. We are in the HTML file and the JavaScript file is in the same folder, so I don't need to navigate into any folder or type in a complicated path here. Just write the name of the file. If we now run this code again, you can see that, yes, it still works. So now we have a proper setup for our app and we are ready to get started building our people counter. Let's move on. So today is actually a really important day in your life because you're going to write your first lines of JavaScript. And that is just such a powerful thing to do because you take the first step into a world of opportunities and it might even change your life. So in a year, you might want to celebrate this day as the anniversary, the day you met JavaScript and changed your life for the better. Anyway, the line you're going to write is not this long one right here. It's a little bit too difficult at the moment. I'm actually going to add a double slash in front of it, like that. And you can see that grayed it out. That means that JavaScript will ignore this, since this is now a code comment, not real code. So if we run the code here in the browser, you can see that now we are not modifying the h2 tag anymore. So we are ready here down at line 3 to write our first lines of code. Now, let's think a little bit. What do we need actually to build this subway passenger counter app? Well, the first thing we need is some way to store the count. And that's a natural job for JavaScript because it's kind of like the data we need to store. And when you need to store data, you need to create so-called variables to store the data in. And I'm now going to create a variable called count. And the way we do that is we write let count equal 0. So now we have a variable called count, and it holds a tiny piece of data, namely the number 0. The way you can read this in English is actually let count be 0. So really natural. And let's actually try and verify that actually our count variable does indeed equal 0. Well, we can do that by using a tool that every single developer uses every single day. It's called console.log, and then open and close parentheses. And inside of these parentheses, you can put almost whatever you want. And in our case, we are going to put this count variable here. If we now run the code, you can see that down in the console at the bottom, we printed out the number 0. And the console is something that the browser provides us with. It's there mainly for debugging purposes, for checking our code like we are doing here, verifying that actually, I want to take a look at count. I want to print it out to the console and see with my own eyes that it is what I think it is. And indeed it was. And this console you see here is Grimbus implementation of the console. If you want to check out the real world console in the Chrome browser, you can, for example, head over to google.com or any page basically, and then right click and choose the inspect option. When you click that, it'll open up this so-called developer tools, which shows you a bunch of HTML. As for now, we're not going to worry about that. Instead, just click on the console option. And that'll open up a blank console where you actually, in addition to printing out stuff, which we did down here in the Scrimba console, you can write JavaScript as well. So if you want to write let count equals 5 and then hit enter, and then write console log and then pass in count in the parentheses, and then hit enter, you'll see that it'll log out 5 as well. So the console is available to you in all browsers and is a tool that developers use every single day. So I'm really happy that you've learned about it this early on. Now I actually have a challenge for you. I want you to do two things. First, you're going to create a variable called myAge and then set its value to your age, and then log the myAge variable to the console. So go ahead and do this right now, and then I will show you how to do it as well when you come back. Okay, hopefully that went well. Let's do it together. I'll do let myAge. I happen to be 35 at the moment. Then to console log out myAge, I'll do console.log, open and close parentheses, myAge. If we run this code, you see now we are printing out both the count and also myAge. So we have verified that our variables indeed work as expected. Before we move on, there's one thing I want to show you. And that is to take this line, console logging of myAge, and place it above the myAge variable declaration. So now we try to console log myAge before we define it, since JavaScript starts reading at the top and works its way downwards. So what do you think then will happen if I now remove these other console logs and only keep the myAge console log? Just take a guess. Well, what happens is that we get a reference error. Cannot access myAge before initialization. So JavaScript actually understands what we're trying to do, that we're actually referencing a value before it has been initialized. And that simply doesn't work. So now that you are aware of that, let's move on. Okay, so let's return back to our count variable and learn some more advanced concepts, which is that you can actually use JavaScript kind of as a calculator. So instead of just writing let count equals 5, you can do let count equals 5 plus 7, for example. And when you run that code, you'll see 12 in the console. You can do minus, of course. That'll result in minus 2 in the console. Or you can even divide. That'll be 0.71, bunch of numbers after that. And of course, multiply gives us 35. So there's a lot of mathematical operations built into JavaScript, and you're not going to learn about all of them now. Because now, instead of just hard coding raw numbers, let's try to use variables here instead. Because oftentimes, you won't see this kind of operation. You'll normally see numbers represented as variables in real-world code bases. So removing this right here, for example, do let first batch equals 5. So this was the batch of people that first entered the subway wagon. And instead of hard coding 5 here yet again, I'm just going to do count equals first batch. Well, what do you think will be logged out here then? Quite correctly, it's 5. Because first batch is 5, and count is set to the same as 5. And perhaps there was another batch as well. Let second batch, a group of people that entered just before the doors closed. Maybe that was 7 people. Well, then we can do count equals first batch plus second batch. Yes, this works as well. So this is a much more common thing to see in JavaScript, that a variable is set to the value of, for example, 2 other variables added together. Now, I want to comment out this like that. If you wondered how I did that magic of commenting out multiple lines at once, I did simply command plus K plus C, or replacing this with control if you're on a Windows machine. Because what I want to do now, I want to gather this code up here, and then I want to give you a 3-part challenge where you are going to convert your age into dog years. So first create 2 variables, myAge and human dog ratio. That is the ratio between human years and dog years. And for the sake of simplicity, we're going to say that 1 human year is about 7 dog years. Now, the calculation is actually a little bit more complicated than that, but that's not that important. The important thing here is the learning. So set then the human-dog ratio to 7, and then multiply the two variables together, and then store the result in myDogAge. Finally, log myDogAge to the console. This is great practice. It's important to build up your muscle memory. So go ahead and do this right now, and then return back to the screencast when you want to see how I solve it as well. Okay, hopefully that went well. Now let's do it together. Remove the console so we can get some more space here. And we'll start with my age, which still is 35. And we'll do human dog ratio. That should be 7. Finally, the my dog age should be my age multiplied with human dog ratio. Let's verify that this works by logging out my dog age. Running the code, and yes, we can see in the console we get 245. My God, I would be an old dog if I was a dog. I'm really glad I'm a human, actually. So let's move on. Okay, so let's return back to our count example. Now, you've learned how to initialize a variable and even how to do mathematical operations on it, both with hard-coded numbers and with other variables if we need that. And that's all great. However, up until now, we've just been working on the initialization or the so-called assignment of the variable. What if you want to reassign it? Or in plain English, you want to change the variable? Well, then you can do that, for example, down here on line 5, and just do count equals 3. And if we now run the code, you can see that we log out 3 as opposed to 5, because JavaScript starts from the top and runs down and uses the latest value it can find for any variable defined with the let keyword. Now, there are other types of variables that you can't reassign like this, but we'll get to that later. As for now, we're just going to work with the let. And you can do this as many times as you want. If I want to change it even further down to 1, you can see now that JavaScript is only taking into account the line 7 reassignment of the count variable. So this is all good, but it doesn't really help us if we want to increment our people entered count with 1 every time we, for example, click a button. What we then want to do is something like count plus 1, because we want to take the current count, keep track of how many we've counted up until now, and then just increment with 1. The way to do that is actually by simply doing like this. Now, this might look a little bit weird since we have count on both sides of the equal mark, and probably you've learned at school that the left and right hand side of the equal mark should be completely equal in mathematics. However, that's not how it works in JavaScript. Here we are assigning this variable to take on this value. So first you want to calculate the value, and the value is this point 5 plus 1. Well, then count now will be equal to 6. Let's run this code and see that it works. Yes. And let's say we wanted to increment it by 2. Then we do 2, and now it's 7 because 5 plus 2 is 7. Do the same thing again. This time we can increment it with 10. Now we're up at 17. And minus that with 2 again. And then we're down at 15. I think you get the point. Now I have a challenge for you. Okay, so you are to create a variable, bonus points. So this could, for example, be a game where your bonus points goes up and down. And I want you to initialize it as 50, and then increase it to 100, decrease it down to 25, and then finally increase it up to 70 again. And you are to use the same technique that we used here with the count, where you reassign the variable to the old value of the variable, and then adding or subtracting a value. And I want you to console log the value after each step. So go ahead and do this right now, and then I will show you the solution as well. Okay, hopefully this went well. Let's do this together. We'll start with let bonus points be 50. Console logging it out. And then we're going to do bonus points equals bonus points plus 50 because we want to get to 100. Again, console logging it. Next up, bonus points equals bonus points minus 75 because we want to get down to 25. Logging it out again. Finally, bonus points equals bonus points Now we need to increase it with 45. Get to 70. Let's comment out this code up here and run the code, bring up the console, and yes, 50, 100, 25, 70. Great job. Let's move on. Okay, now you know enough JavaScript for us to move on to the HTML and build the interface for our app. And it's not a lot of interface. It's, to begin with, just a button. And later down the line, we're going to create another button. But it has to be written. And you are going to do that. So I want you to follow these instructions. You are to create an increment button. That is the text of the button. With the ID of increment-btn. So go ahead and do this right now. Okay. Hopefully that went well. Now let's do it together. Button, then I'll create the closing tag. Inside of here, I'll write increment. Could have written count here, but I think increment is more of a technically descriptive word. So let's use that. And ID, increment-btn, like that. If we run this code, you'll see, yes, we indeed have this button and it is already styled. How convenient. Let's check out the CSS for that. We have a general styling for buttons, which are reused across both of our buttons, since they're using the button selector. And then our increment button and our save button has a specific background, each of them. They're dark red and dark green. Great job doing this. Now the question is, how do we make this button interactive? Because right now, nothing happens if I click it. Well, in the next lecture, we'll go through exactly how to do that. Okay, so now we're going to put the different pieces in this puzzle together and also add a whole new piece. And in order to free up some space in our JavaScript file here, let's just remove this previous exercise and actually write out in pseudocode the procedures that we need to do in order to make this work. So first, we know that we need to store the count somewhere, and we know that we want to initialize it as 0. And then, as I said in the previous lesson, we need to kind of listen for clicks on this button here. When it's clicked, we need to increment our count. And then finally, which we aren't going to do just yet, but I just want to write that procedure out as well so that you know what to expect. We need to change the countel, this paragraph right here, in the HTML to reflect the new count. So we know how to initialize the count as 0, and we know how to increment a count variable. So to achieve these first three, we need to do this task, that is listening for clicks on the increment button. And that can be done in a multitude of ways. The easiest one is simply in the HTML defining an onclick event listener. You simply write onclick equals and then something in between quotes. So this is an attribute in the HTML, just like the ID is an attribute as well. And inside of here, you write the function that you want to be triggered when the button is clicked. So I'm going to write increment and open and close parentheses here. Now, that probably looks really weird for you. And that's totally okay if you're confused by what's going on here, because we've seen nothing of the word increment in our JavaScript yet. So rightfully so, we need to create that function. I'll do that down here, and I'll use the keyword function, then the name, increment, open and close parentheses, and then open and closed square brackets. So pretty funky syntax right there. And the first time you type them, it feels weird, but over time it becomes second nature. What you write inside of these curly brackets is the so-called body of the function. And that piece of code that is in the body will be executed every time this function is called or invoked. That's the same thing. So just to see it in action, I'm going to write console log button was clicked. Like that. If we run the code and I click the button, you can see that in the console we see the button was clicked. If I do it again and again and again and again, so every single time the button is clicked, this piece of code runs. And it runs because we in the HTMLs are saying, hey JavaScript, when this button is clicked on the onclick event, then I want you to run a function called increment. And that's what's happening here. And then JavaScript is like, yeah, for sure. It sits ready and listens for that specific click event. And JavaScript can do that. It pays attention to what the user does on the screen. And when it sees someone clicking on this button, it fires off this piece of code. This was probably a lot of information to parse in one go. So before we move on and continue on turning our pseudocode into real JavaScript, let's take a closer look at functions over the next few casts so that you get to write some functions as well and build up your understanding and muscle memory. Okay, so let's pretend that we are building a race car game. So here I have some comments, which are meant as pseudocode for the functionalities of the game. And the only real functional part of it is these 5 console logs, which are counting down from 5 to 1. So we start the game by setting up the race, and then we do 5, 4, 3, 2, 1. If I run the code, you can see that is logged to the console. That means that it's go, players are to start racing, and they would be running the race, and then the race is finished, and a winner is declared. And then, of course, we are getting ready for a new race. However, with the current knowledge we have about JavaScript, the way we would count down for a new race would have to be to copy all of these lines and paste them in down here, so that now when we run it, we get 5, 4, 3, 2, 1 printed 2 times to the console. However, this isn't good. Anytime you see this kinds of repetitions in your code, you should try to think, is there any way we can extract this into a function? And that is exactly what we are going to do. We are going to refactor this so that it instead uses a function. Another word for function could be command. So we are asking JavaScript to kind of remember a command so that we can use it later on as well. And that command can be as comprehensive as you want. In our case, it's going to be to count down from 5 to 1. So let's just do this to see it in action. To create a function, as I talked about in the previous cast, we use the function keyword. And then the name of the function, I'm going to call this function countdown. Then open and close parentheses. And then open and close curly brackets. And all of the action happens inside of the curly brackets. So I'm going to break that into a new line. And I'm going to copy all of these console logs and then paste them inside here, like that. And here I'm tabbing it out just to highlight that this code is inside of that function. And this is not something JavaScript cares about. It's to make our code easy to read for humans. So now I have declared our function. However, if we remove this down here and now try to run the code, nothing happens because it has only been declared. It hasn't been what we called invoked or also called, as this code inside of here will only run if we call the function. So if JavaScript was a dog and we've taught our dog to roll around, then in order to get our dog to actually roll around, we have to say roll around. Same thing here. We have taught JavaScript to count down, but in order for it to actually do the counting, we have to say countdown. And we do that like this, simply writing countdown with open and close parentheses. So now you can see when I run the code, it indeed does the counting, but if I comment this out, it does nothing. So what I'm going to do now is I'm going to take this countdown and I'm going to put it all the way here at the top, and then I'm going to call it when we are ready to start the first race, and then also call it when we are ready to start the second race. Now if I run the code, you can see that we indeed count down 2 times before the first race and before the second race. And this is much better than typing out all 5 console logs, both here on line 11 and on line 19. So we have compressed our code a lot. So with this knowledge fresh in mind, let's move on to the next cast where you are to write your first function. Okay, now it's your turn. You are going to create a function that logs out the number 42 to the console. And you can decide the name of the function. And when you've done that, make sure you call or invoke the function as well. So go ahead and do this right now. Okay, let's do this. I'm going to call it myLogger. Open and close brackets. And then inside of the body, do console.log 42. Now we need to call it myLogger, like that. We run the code. And yes, you can see we are logging 42 to the console. Great job. Okay, time for a new challenge. So in our race car game, we have certain laps, and of course we track how much time our players use to race through the laps. And here we have 3 lap times in the variable lap1, lap2, and lap3. And the thing is, if you create a function down here on line 6, it will be able to access these 3 variables from within the function. So what I want you to do now is create a function that simply logs out the sum of all the 3 laps. So that'll be the total racing time for a player. So you decide what name you want to give it. Just write that function that logs out the total lap time and then run the function as well. Okay, hopefully that went well. Let's do this. The function, I'm going to call this function log lap time, open and close parentheses. And here I can either first create a variable, let total time, for example, do lap1 plus lap2 plus lap3, and then console log out total lap time like that, and then log lap time, invoke the function down here on line 11. If we now run the code, you can see, yes, we are logging out 103. This is one way of doing it. Alternatively, I could have skipped creating this variable in here and simply added the variables inside of the console log. It will give me, as you can see, the exact same result. Now, the reason I wanted to create this variable here, though, is to just show you one thing, which is that while this function could access these variables from the so-called global scope, the outer scope, which is not on the inside of the function, but on the outside of it, this doesn't work the other way around. So if I now just try to console log total time from the outer scope, if we run this, you can say total time is not defined. That is because when you define a let variable inside of this scope, it only exists inside of this block of code. This is the scope in which the function lives. And that's why we call let variables block scoped. So that might be a little bit confusing, in that the lap could go from the outside of the function and to the inside of the function, but total time couldn't go from the inside of the function to the outside of the function. But don't worry too much about this. JavaScript will tell you when something isn't defined, and you can be sure that you will misstep at times, but that's just a part of the process. Let's now move on to the next challenge. Okay, so now you have to combine some of the things you've learned up until now in order to build this lap counter feature. Because in our racing game, we want to keep track of how many laps a player has completed. So I've created this variable called laps completed and initialized it to 0. So what I want you to do now is create a function that increments the laps completed variable with 1 every time you run the function. Then I want you to run or call or invoke or whatever you want to call it, this function 3 times. So that on line 9 here, the value that's logged out will be 3. Now, if you're wondering how to increment a variable in JavaScript, just look back a few casts because we did that previously. So now you have to combine that knowledge with your freshly acquired knowledge about writing functions. So go ahead and give this your best try right now. Okay, hopefully that went well. If not, no worries. Let's do this together so that you get to see how we do it. Do function, and I'm going to call this function increment lap like that. Open and close parentheses, and then open and close curly brackets. And here we have to increment this variable just as we did a few casts ago by doing laps completed equals the old value of laps completed plus 1, like that. If I now run increment lap 1 time, you'll see that we're logging out 1. Good stuff. Let's invoke it 3 times. And there we can see we are logging out 3 to the console. So, great job doing this. If you didn't manage it, just go back and try again now that you've seen my solution. Because it's really important that you actually write the code here so that you build up that important muscle memory. Okay, we're back at the Subway Counter app. And as you can see, I've deleted the increment function because I want you to write it instead. It's much better than me writing everything. And you are to do it as a part of turning these first 3 lines of pseudocode into real code. So you're going to initialize the count as 0, You're going to listen for clicks on the increment button, and thus you have to create that function that's triggered when the increment button is clicked, and then you are going to increment the count. And add a final little challenge here, and that is to log it out after the count variable has been incremented. So go ahead and do this right now, and then afterwards I'll of course show you the solution as well. Okay, hopefully that went well. Let's do this together. We'll do function, increment, open and close parentheses, open and close curly brackets. We have the button. Let's verify that it works. A good thing to do after every single step so that you know if you at some point get a bug, you will have a better understanding of where it happened since you know which steps you were able to get to without triggering any bugs. So I'll do clicked, I'll run the code, click the button. Yes, that works. Okay, now we need to increment the count. So we're going to do that inside here. And of course, then we need the count initialized to begin with. So count equals 0. Here, as you remember, it's just as we're simply going to do what we did up at line 4. We'll do count equals count plus 1. Now finally, console log count. I'm going to remove this and run the code, hit increment. Yes, we see 1 and 2 and 3 and 4. Nice. So then we have done these 3 parts. And remove this helper code right here. We have the final part left, and we can finally start understanding what this weird piece of code here up on line 1 that we worked with in the very beginning of the course actually means. Let's do that in the next lecture. Okay, so we are ready to add the final piece of the puzzle, which is to change the countel. That is the h2 right here, which currently has 0. So that it reflects the new count. And the new count is down here, which we are logging out. So we have to do something down here at line 9. And what we're going to do is take this line right here, which has just been lying here in the background all along. Now, in order to properly understand this expression, I think we should break it into 2. Take the first part, where we're actually asking for the HTML element, and the second part, where we're actually modifying the HTML element. So starting with the first part, I'm going to store this in a variable called countel, like that, and do document get element by ID, open and close parentheses, and passing in countel, this exact string right here. Notice that we're using a different naming convention here in the JavaScript. This is called camel case, like that, where you capitalize the first letter of the second word, but not the first letter of the first word. This is how you want to write JavaScript variables. It's a very normal convention. And also, if we were to try to use the same convention as we've been using in our HTML and CSS, JavaScript would actually tell us, you can't do that. As you can see, we are getting a red line under this character, which is JavaScript's way of complaining to us, because it's not a valid variable name when you use dash. So we got to remove it, like that. Now, as always, what do you think we should do now that we've taken one step into the unknown? Well, of course, we're going to use our good old friend console log, because we have to verify at every single step that we're actually on track. We haven't introduced any bugs. So I'll do console.log and logging out countel. And if we bring up the console, we can see actually we're getting what looks like an HTML element in the console. That's pretty interesting. Now, it's actually not a real HTML element. It's more of a representation. It's a model of an HTML element. And it gives us a lot of other opportunities to change it using JavaScript as well. But for now, it's perfectly fine to think of this as just, that is the element that we are seeing right here. It's JavaScript's representation of that element. Because remember, we said, hey, HTML document, why don't you get me the element that has the ID of countel? And the HTML was like, yeah, sure, just take it. And then you store that in the countel variable. And now you as a JavaScript developer have control over this element and you can manipulate it, which is exactly what we're going to do down here at line 14. Because now we're going to move on to the second part of this big expression, which is modifying the element itself. .innerText equals 5. Or in our case, how would we write this? Well, we've turned this big thing here into this variable. So we'll use this variable and do innerText. That is innerText like that, equals. And we're not going to set it to 5 because that wouldn't make any sense. What are we going to set it to? Think a second about that. Indeed, it is the count, because we know from console logging earlier on that the count does indeed increment correctly. And now we're just saying that we want the inner text, that is the text on the inside of the tags, we want it to be the count. We'll run the code, hit the increment button, and yes, it works. Now we are incrementing, we are counting people. Really good job reaching this point. Your JavaScript skills are starting to become dangerous, as you now know how to create interactive apps. Now, before we move on, there's one thing I want to mention, which is that this getElementById here and this .log, both are functions in the same way our increment function is a function. Now, they are hooked onto the document object and the console object, but that's just a nuance. They're still functions, or methods as we call functions that are hooked onto so-called objects. If that sounds confusing, it's because it should be at this point, because you haven't learned about objects yet and methods on objects. But don't worry about that. Just think of them as functions. And actually, the thing we've been doing here of adding something in between the parentheses of the function when we are calling it is called to pass in arguments, which means that we are giving the function some data to work with. Like here, we're specifying the ID of the element we want to grab. Otherwise, if we didn't do that, this function would just be running in the wild and not know what to look for. Likewise, in this .log here, we're passing in which variable we want to log to the console. If we didn't do this, the log function wouldn't know what to log. So speaking in analogies, if the function is a chef that are to cook a meal for you, then the arguments you pass in are the ingredients the chef uses to cook that meal. So hopefully that made everything a bit more clear. Let's clean up this code and move on. Now, before we move on, I want to talk a little bit about what we're doing here, where we're saying document.getElementById. Because you'll often hear developers refer to this technique as working with the DOM. And that's one of those 3-letter acronyms in web development that sounds super complicated. And I was really confused about this when I was learning to code. And I want you to avoid that confusion. So let's just unpack this expression. It's short for document object model. That sounds really fancy. However, it's actually just how you use JavaScript to modify a website. It's just that the people naming this wanted to give it a really abstract name. But if we look at each of the words separately, the name actually does make sense. So let's do that, starting with a document. Why that? Well, that's because what you are interacting with is an HTML document. Object? Well, that's because the document keyword in JavaScript is of the data type object. Meaning they've taken the HTML document and shoved it into a JavaScript object. Of course, that's a little bit of a simplification, but that's the essence. So this word document is of the data type object. Now, you haven't learned about objects yet, though you're going to do that a little bit later. Finally, there's model. Model is basically a representation or a modelation. Kind of like, there's the real Saturn V rocket that NASA built, and then there's the Lego model. And that's how it is here as well. There's the real HTML element, which you've written in your .html file. And then there's the JavaScript model, the representation you have of this element in JavaScript. So don't be frightened when people talk about the DOM. Just in your head, translate it to how to use JavaScript to modify websites. And with that out of the way, let's move on with the coding. Or actually, before we move on, I have to admit that I fooled you a little bit. Because the problem with the previous lecture was that I wrote the code, and that's just wrong. You are going to write the code. That's how you learn. So I have removed the 2 lines of code that I wrote, namely grabbing the countel element and storing it in a countel variable, and also setting the countel's inner text to the count. So just do that, and if you struggle, just go back and look at my solution. There's no need for me to type this out for you yet again. Just go ahead and give it your best shot and refer to that if you need help. And I will see you in the next lecture. Okay, it's time for you to build some muscle memory because you are going to create a save button and a save function. You're going to start with a function. Here is the instructions. Create a function. called save, which logs out the count when it's called. We're going to modify this to do some other stuff afterwards, but as for now, I wanted to just log out the count. Secondly, in the HTML, you are going to create the save button. You are to set the ID as saveBTN and have it call the save function when it is clicked. So go ahead and do this right now and then return back to the screencast when you want to see my solution. Okay, hopefully that went well. Let's do this. We'll do function save, open and close parentheses. Then the body of the function will console log the count. If we want to check that this actually works now, we can call the save function, run the code, and we can see, yes, that the count is indeed logged out as a consequence of us calling the function here on line 15. Okay, let's remove that. Going over to the HTML, we're going to create the save button, and we do open button tag. Then I'll just close it right away. I'll write save in between the tags and give it the ID of save.btn. Now we can actually run it to see that it renders. Yes, it indeed does, but nothing happens when we click it, and that's because we have to do onclick. We want to run the save function. Here we have to invoke it with the open and close parentheses, otherwise it won't call the function. So rerunning the code, hitting save, yes, there we are logging out 0 because of this line. Now we can increment a couple of times and see, ooh, now we're logging out 6. Pretty nice. Now we're starting to get somewhere. It's only a matter of saving the count to the website as well and rendering it out under the buttons. But before that, there's some new concepts you need to learn, so I'll see you in the next cast. Okay, so now it's time for us to build this little functionality here, which allows us to save the number of people who have entered into the subway at each of the departures. However, this requires you to work with this full paragraph, which actually includes both numbers, which you can see, but also like regular text, previous entries, and some symbols as well. And once you move away from just straight out numbers in JavaScript, you're moving into the land of so-called strings. And strings is a data type in JavaScript. And in case you wondered, yes, numbers is also a data type. And if you think the word string is a little bit weird, well, you can also think of this as just text. The strings you work with in JavaScript are normally meant to be text that the user reads on the page. Now, we have been working with text here before. We've hard-coded in some text here and there in the HTML. And actually, as far as HTML knows, everything is strings. It doesn't even know about numbers. HTML can't do calculations for you. So when I'm talking about strings and numbers, I'm talking about it in the context of JavaScript. And even though you're probably not even aware of it, you've actually written a string already up here on line 1. You've wrapped the count-l inside of 2 quotes. And that is how you create a string in JavaScript. But you've had far from enough practice to start working with strings in our people counter app. So in the next lesson, we're going to go over the basics of it. And then you're going to solve some challenges so that we build up that muscle memory and make you capable of using strings in our app. So I'll see you there. So strings are used all over the place in software. Let's say that you, for example, are building an app where people can authenticate. Well, then most likely you'd have to store some kind of username for your users. That would most likely be stored as a string. For example, pair, wrapped in double quotes. Then this string, just like we did with numbers, will be stored in a variable. So let username equals pair. Now we can console log out username, and we get pair logged to the console. Now, one thing I want to mention is that I'm using double quotes here to create this string. I could use single quotes instead if I want to. You can see that works. However, I cannot start with a single quote and end with a double quote. As you can see, now our editor tells us that this syntax is off. And if we try to run the code, we are getting a syntax error. So you got to stick with one or the other. And I usually use double quotes, but that's just a matter of preference. If you prefer single quotes, go ahead. Now I want to give you a challenge. Right here, you are to create a variable message that stores the string. You have 3 new notifications. Go ahead and do that right now. Okay, hopefully that went well. Let's do this. Message equals this string right here. Now what we want to do here is combine this string with this string, because this string right here is probably the result of us checking in the database and seeing that, oh, there's 3 new notifications that Pear hasn't seen. So render out this string right here. And then, of course, we need to combine it with the name. So what we want to do is message plus username, like that. When we add a plus here, we so-called concatenate the 2 strings together. So let's have a look at what happens when we run the code. It becomes this slightly ugly string. You have 3 new notifications pair with no space in between the strings. So it kind of becomes like this. This isn't really what we wanted. What we then also can do is add a 3rd string in between here, which includes a comma and a space. Now, if we run it, you have 3 new notifications pair. And maybe we even want to add a exclamation mark at the end, like that. As you can see, when we use the plus for strings, it simply concatenates the characters together. Okay, now I have a new challenge for you. You are to create a variable message to user that contains the message we have logged. By that, I mean the entire message in here. This should be a new variable. And then afterwards, I would log it out just to make sure that you have configured the message to user in the correct way. Go ahead and do this right now. Okay, to do this, you do let message to user equals message plus comma space plus username plus exclamation mark. Now we can replace all of this with message to user. And running the code again, we get the exact same string, which is just what we wanted. Great job. Okay, time for another challenge. You are to create 2 variables, name and greeting. And the name variable should store your name, and the greeting should store, for example, hi, my name is. Then you are to create a 3rd variable, myGreeting, that concatenates the 2 strings, and finally log the myGreeting variable to the console. So this is just to give you some muscle memory. Go ahead and do this right now. Okay, let's do this. I'll do let name equals pair Harold Borgen, and then let greeting, hi, my name is, and then a space at the end. And then finally, let my greeting equals greeting plus name. Then to see how this went, we do console log my greeting. Running the code, yes, we get hi, my name is Per Harold Borgen. Now, notice that here, I added the space inside of one of the strings as opposed to doing something like that. However, doing that would work the exact same way. So, great job solving this challenge. Let's move on. Okay, now let's mix it up a little bit. Let's say that my name isn't Per Harold Borgen, it's actually 42. A strange name, but anyway, what do you think will happen when we have 1 number and 1 string? What will the result be? Let's do it. It's actually, hi, my name is 42. So the 42 here has actually been turned into a string that has been added into like this. And that's kind of what happens. In a wrestling game between a string and a number, the string always wins. Now, this was a little bit of a weird example, so let's take one that's a bit more interesting. Let's try let points equals 4, and then let's say bonus points. This is some kind of game. That is 10. Let total points equals points plus bonus points, total points. Now, what do you think we'll log out here? I'm going to comment out this one right here. Take 2 seconds to think about what the result will be. Okay, let's run this. The result is 410. That is weird, because perhaps you expected 14? No, as I said, the string always wins. So when we say 4 plus 10, which is the values of these variables, the 4 will be turned into a string, And the result when you concatenate two strings is just pretty easy to see by just removing this fluff in between them, 410. If the numbers won the wrestling game, it would be like this, and it would indeed log out 14. But it didn't. So I'm going to give you a couple of challenges here. What do you think these 4 console logs will log out? Take a minute to think about that. Potentially write your solutions in a code comment, either above or perhaps even after each of the lines, and then return back to the screencast, and then we'll have a look at it together. Okay, here we have a number and a number, so this will end up as a number as well. 4 plus 5 is 9, as far as I can remember. Here, a string plus a string, even though they are number characters inside of the strings, that doesn't matter. JavaScript still sees this as a string, and the result will be a string of 24. Here, a wrestling match between a string and a number. Sadly, the number always loses, so this will be 51. And finally, again, wrestling match between a number and a string. The result is always that the string wins, so this will be 100, 100, like that. Let's run the code. Yes! As you also can see from the console, the way the Scrimba console highlights the difference between numbers and strings is with the color. The strings are white, whereas the numbers are blue. So, great job, let's move on. Okay, it's time for a challenge. This time you are going to create a feature that we already have on Scrimba. Because on the dashboard, we welcome our users by saying, "Welcome back, Per Harold Borgen." That's a normal thing a lot of apps do, so it makes sense to try to implement it. And the way you want to do it is through grabbing a hold of this paragraph here, which I've given an ID of welcome-L. That is the first part of the challenge. You're going to store that paragraph in a variable called welcome-L using this camel case convention. And then you are to create 2 variables, name and greeting, that contains your name and the greeting we want to render on the page. In our case, that is welcome back. Finally, you are going to render the entire welcome message using welcome.L.innerText. So go ahead and give this one a shot, and then I will show you the solution when you return back to this cast. Okay, let's do this. We'll start by grabbing the welcome.L paragraph. Do let welcome.L equals document.getElement by ID, passing in the ID we have here, like that. Now we need to create the 2 variables. Let name, my name is Per Harold Borgen. Let greeting, I'll do welcome back. And finally, rendering it out. That is done by doing welcome.L.innerText equals greeting plus name. Now, if we run this, we can see we are rendering out welcome back Per Harold Borgen, but there's no space between welcome back and my name. That can easily be solved by just adding a space after welcome back. Or we could, of course, hard-code it in between these 2 variables when we concatenated the string as well, but that doesn't really matter that much in this case. So let's just stick with this and move on to the next lesson. Okay, now there's one more thing you want to do, because personally I think this welcome message could be a little bit more lively and fun, and what would help there is to add an emoji. For example, this emoji right here. That will look pretty nice. So I want you to add that to the welcome element innerText. However, there's a catch. You are not allowed to modify the code over line 9. You have to write it below. So the question is, how can you add this emoji to the end here in the browser by simply writing more code, not by modifying any of the existing code? And to give you a hint, you need to remember back what you did when you incremented numbers. This technique here. You can do the same thing with welcome.L.innerText. So go ahead and give this a shot. Okay, hopefully that went well. If not, no worries, we'll do this together. What we're simply going to do here is, instead of using count, we're going to use welcome.L.innerText. And instead of the 1, we're going to use an emoji. So here we'll do welcome.L.innerText equals the old welcome else innerText plus this new emoji right here. And an emoji is just a string like all other characters. It's just rendered out a little bit fancy. So if we run this, you can see, yes, we indeed get the emoji at the end. Now, before we leave, I want to teach you a little trick, because this line here is pretty clunky, writing the welcomeL.innerText twice. It's not something you'll see out in the wild, because there's a shorter version of writing this, and that is simply using the plus equal operator. What it does, it takes the current value you have and then adds this one after it. So it's the exact same thing that you were doing here. Seems a bit weird to do this plus equal sign here. Just try and remember that it simply takes what you have here and adds this to it. So that after this line, welcome.innerText consists of the entire thing here. Okay, with that in mind, let's go back to our passenger counter app. Okay, just a minor thing before we start using strings in our app. I want you to use the plus equals technique instead of this slightly longer count equals count plus one technique. So go ahead and do that. Okay, hopefully that went well by simply doing like this. Count plus equals 1. Run the code. Yes, it works. Let's move on. Okay, so now you are going to solve a super cool challenge. You're going to take everything you've learned about JavaScript up until now and use it to create this save feature. You can see it says previous entries and then 4, 5, 11 with dashes that separate them. And these are of course added every time you hit the save button. Now there's a dash after the 3 numbers as well. Don't worry about that. It might look a little bit weird, but it's the easiest way to do this. And we want to do it the easiest way now that you're building stuff like this first time around. We don't want to worry about details. Make it work first, then make it better. That's my philosophy. So we're just going to make this work. Okay, so your 3 challenges are listed as comments here in the JavaScript. And in the HTML, I'm going to write the paragraph for you so that you have something to work with. So this is a p tag, and it should say previous entries like that. And I'm going to give it an ID equals save-l for save element. Then you are going to grab the save element paragraph and store it in a variable called save-l. And then in the save function, which is triggered when the save button is clicked on, you are going to create a variable that contains both the count, that is the number, and the dash separator. So it'll look something like this, like 12 space dash space. And then you are to render this newly created variable into the save element using innerText. However, you must make sure that you don't delete the existing content from the save-l paragraph, because you want to concatenate the string, not wipe it out entirely and replace the paragraph with the latest entry. So you got to remember your plus equal. But luckily, you know how to use plus equals, and that might be helpful in this situation. Finally, one thing I want to mention is that you might struggle a little bit with the spaces here, and it might end up slightly different than what you can see here. And that is perfectly okay. Don't worry about that. In the next cast, actually, we are going to do some searching online to figure out if there's some alternative methods we can do this on, which will help us keep these spaces. That's a critical part of web development, searching for solutions online. So I've left a little gotcha for you here so that we get a nice little problem to solve using Google and some online docs in the next cast. So don't worry about that. Just go ahead and give this your best shot. And if you need help, just revert to this screencast and I will show you the solution as well. Okay, hopefully this went well. If not, no worries. Let's do it together. First, we are going to do let save L. That'll be document.getElementById, and we are going to get the save-l like that. As always, I like to console log just to see that I have the correct element fetched. Let's run this code, and yes, bringing up the console, we see that we have grabbed the correct element. Then we can move on. First, create a variable that contains both the count and the dash separator. So what are we going to call this variable? I intentionally didn't give you a name for it because I wanted you to think what could be a suitable name for this string. And there's no right or wrong answer, but one thing you could call it would be count string or count str, like that. So it is the count, but we've turned it into a string, so a count string kind of makes sense. And the value of it will be count plus, and then the string. I'll add a space, a dash, and a space. All right. 3, render the variable using innerText. Okay, let's do it down here. we'll do save L dot innerText, and then you might have been tempted to do equal count R, but that won't work. Let's just try it. Run the code, we increment, and we hit save. Boom! Then we suddenly remove the previous entries text. We cleared it out, of course, because we set all of the inner text to be just this count string. That doesn't work. We have to take into account what was there previously as well. So we add plus equals like that. Increment, increment, increment. Save. Yes, that works. All right, so it works really well, actually. However, this dash at the end here is gone, as is our space here in the paragraph. And that is a bit weird, because we want to keep those spaces. However, it's also a great opportunity to do some searching online in order to solve this problem, which is a critical skill for any developers, namely finding answers online. So we'll do that in the next cast. Okay, so we have this little problem here, which is that our spaces aren't working in the way we want them to work. Basically, this space here gets lost on the way somewhere. I don't know where, but it happens. How do we go about figuring out what's wrong? Well, looking at these two lines, which is where we deal with this save element paragraph, you can think what would be a suspect? Which tool that we're using would be a good suspect? And I'm going to point to this one right here, because I happen to know that that is actually the guilty one, the inner text. And let's say you'd guess that as well. How do you go about finding another tool that doesn't work this way? Well, one thing you can do is you can write inner text alternative and then MDN. Put that into Google and see what it returns. And MDN is short for Mozilla Developer Networks, and it's a great resource. So if we do that, type that into Google, you can see the very first result is node text content. Okay, that's interesting. Let's click into that. There we land on an interface you're going to get very familiar with, the MDN web docs. And it says node.textContent. Don't worry about this node here. It's kind of a fancy way of saying HTML element. Sort of, not entirely, but just translate it to HTML element right now, and you'll be good. And then you can read the text content property of the HTML element represents the text content of the element. Okay, seems pretty useful to me. And then we can scroll a little bit down. And then you see they've actually listed up differences between inner text and text content. And here, if we scan through this, you can see that inner text only shows human readable elements. And yet again, inner text is aware of styling and won't return the text of hidden elements. Okay, so it seems to be that the inner text somehow struggles a little bit to return things that are hidden or not human readable. And space is certainly not that human readable as a character. So maybe we can just change it then to .text content instead. Let's try that. Text content, code, increment, 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 save. Oh, yes, indeed. Now we get the spaces. And one thing I want to highlight here is that while the Mozilla Web Docs is a great resource, it's very comprehensive, the language you'll see in these kinds of documentation sites is often very technical. That's why I kind of skimmed through and found some hints of human readable and hidden, and I kind of didn't worry too much about going into depth. And I think you as well should think, when you see a page like this, don't feel that you need to understand everything. And for the love of God, don't try to learn the code by just reading documentation. Some people say that's a good idea. I think it's a terrible idea. You want to slowly learn how to get comfortable reading documentation, but you also want to ignore all of the complex stuff that it's very often wrapped within. And there are other sites as well that explain things in various degrees of difficulty. For example, there's also something called W3 Schools, which is very good. There's Stack Overflow and many more, and you're going to see more of this as you progress in the course, as we're going to come back to this debugging concept later on as well. But as for now, you've just had a little sneak peek on the Mozilla Developer Network. And actually, it's kind of trash talking the .innerText here and saying that it's also computationally expensive. So to me, I've gotten enough hints that I actually want to use .text content instead of inner text. I'm going to change this up here as well. Like that. It still works. Great. Now our app is almost complete. There's only one more thing we need to do, and we'll do that in the next cast. Okay, so now we are going to put the final pieces in our puzzle. because we need to fix the fact that if I increment this and then hit save, and then the subway leaves the station and I'm going to count a new group of people, then with the current solution, I will be counting further on from 6, like 7, 8, 9, and that's not what we want. We want this one to be set back to 0 every time we hit save. And to do this, you need to write 2 lines of code. And at this point, I want to just throw you into the deep end of the pool and see how you swim. So I'm not going to give you any hints or write any pseudocode or tell you where you're going to write these 2 lines. Now you really have to think for yourself, what do you need to do here in order to make this work? And feel free to hack a little bit on it, try a solution, run the code, see how it works, console log out the values, and just hack away at it and give it your best shot. And if you don't manage to do it, no worries at all, because I will show you how to do it again, of course, when you return back to the screencast. So then you can just try to do it again after you've seen my solution. Anyway, enough talk, jump into the code here and give this a shot. Okay, now let's solve this together. So what we need to do is write a couple of lines in this save function, because this is where the magic should happen, because it's when we hit the save button that we want this value to be set back to 0. And how do we set this element to be 0? Well, it is the count element, which we've worked with previously. And setting it to 0, we know how to do that. We can do countel dot text content and set that equal to 0, like that. If I rerun the code, increment, hit save, and yes, it's now 0. But if I now try to hit the increment again, you'll see, oh, 5. That's weird. Why is that? Well, that's because we have indeed set the text content of the count element to 0. So this h2 right here. But in the JavaScript, we're still keeping track of the count, and that count has been incremented at this point 5 times. So what we needed to do here, when we set the text content to 0, is to also set the count back to 0 as well. Because JavaScript remembers what we've done previously, unless we refresh the entire browser. So even though JavaScript can see that, yeah, you are setting the text content of this element here to 0, it still keeps track of the count here. And JavaScript can't deduct that since you want to set this here to 0, you also want this to 0. No, you gotta give JavaScript very specific instructions. So you need to do here, count equals 0 as well. Now if we run the code, bam, 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 save, it's set to 0, and yes, we indeed start at 0 again. So, great job reaching this far. So, you have built your very first JavaScript app from scratch. Congratulations. That is a huge accomplishment. So give yourself a pat on the back. You have really learned a lot in this section. And to prove that to you, we're actually going to do a little recap so that you get to see in front of you all of the new concepts you've shoved into your brain at this point. So we started out with the script tag. If you remember, we had it here in the index.html file, and we wrote our JavaScript internally in this file. However, we realized that that wasn't the way we wanted to go, so we instead pointed this script tag to a source, namely the index.js file, so that we could write our JavaScript there instead. Then we moved on quickly and learned about variables, namely the let variable, and we set its value to a number, which brings us to your very first data type, numbers. You learned how to work with numbers, do mathematical operations, and even increment numbers here on line 6, and also reassign the count variable to 0 here on line 14. So a lot of work with numbers in this app. But you also learned about strings, which was your second data type. Here you added a string to build the save feature, and also you console logged out a few strings along the way with code that we've deleted now. So I added this console log here to remind you about it. Because that is a truly important concept in developing, and you will use it throughout your entire career. Also, another thing you will use constantly as a developer is functions. You learned how to create functions like this increment and save function, and also how to call them, aka invoke them, from the HTML file here on the button clicks. And that brings us to the next concept which you learned a ton about, which is the DOM, or the Document Object Model, or what I like to call it, how to use JavaScript to change the website. So we interacted with the DOM at several places, for example up here where we did document.getElementById. That's one you are going to get very familiar with throughout this module. We passed in the ID as a string so that the JavaScript was able to head into the HTML and fetch out the content you told it to look for. And another way we interacted with the DOM was through the innerText property. We used that here instead of text content. But then we Googled our way to the Mozilla Developer Network and realized that actually text content is a better solution. So we learned about that. And oh my god, this is a lot of concepts to learn. I can totally understand if you're a little bit overwhelmed, and if you feel that you are on thin ice on a few of these concepts, that's totally okay. We are going to repeat all of these things over and over again throughout the module, so don't worry about that. Actually, we are going to jump directly into a section where you are going to get assignments that test you for these skills, just to give you that repetition and muscle memory you need in order to make these concepts become second nature. So let's go ahead and get some repetition. And then once we've done with that, we'll move on to our next big project, the Blackjack app, which is going to be so much fun to build. So I can't wait to see you there. But for now, let's jump into a few quick fire challenges. Okay, in this challenge, you are going to repeat variables. So first, you are going to create two variables, first name and last name. And obviously, I want you to set their values to your first name and your last name, and then concatenate the two variables into a third variable called full name, so that you have your full name. Finally, log full name out to the console. Go ahead and give this a shot right now, and then I will show you my solution when you return back to this screencast. Okay, let's do this. I'll do first name equals pair, and then I'll do let last name equals Borgen, like that. Then we need to concatenate the two together. Let full name equals first name plus last name, like that. Finally, I want to log it to the console. Console.log full name. Now I can run the code, and as you can see, we're logging Pierre Borgen to the console, but there's no space in between the two names. So I could achieve this in a multitude of ways, either by adding a space here, now it's better, or adding a space before Borgen, still good. However, neither of these are optimal, since I want the first name and last name to be the name and the name only, not an extra space. So what I'll do instead is in between here, I'll add an extra space, like that. Running the code, there we go. Now first name and last name contain only the characters of my name, but we still get the space by adding this third string here when we create full name. So no matter how you did it, great job. Let's move on. In this challenge, you are going to create a function that logs out "Hi there, Linda" when called. And you have to use the name and the greeting variable inside of the body of your function. And also, there's a comma and an exclamation mark you also have to include so that you get this exact string logged to the console. So go ahead and solve this one, and then I will show you the solution afterwards as well. Okay, let's do this. Create a function. I'll call it greet Linda, like that. Here we are going to console log first the greeting, then we have to plus the comma and the space, and then plus again, then the name, and then plus again, and then the exclamation mark, like that. Final step, to check our code, we need to run it. Greet Linda, like that, running the code, and there we see this exact string in the console. Great job. In this challenge, you are going to practice your incrementing and decrementing skills. So let's say that you are building a game and the player is collecting points, which currently are at 3, and you need to create two functions, one which is called add 3 points, and one which is called remove 1 point, and of course then have these add and remove their given points from or to the myPoints variable. So remove 1 point should decrease myPoints with 1. Add 3 points should add 3 points to the myPoints variable. And your job is to create those two functions and then call them however many times you need to call them in order for this line down here to log out the number 10. So you are going to write your code in between here. You can add as many lines as you want, but when you eventually run the code, my points should be 10, and you should only have changed my points via calling these two functions a number of times. So go ahead and give this one your best shot, and then I, of course, will show you the solution afterwards as well. Okay, hopefully that went well. Let's do it together. We'll do function, add 3 points. What that'll do is take my points and plus equal 3. Function remove 1 point, and that should do my points minus equal 1, like that. Okay, now we have them, which means that we just need to call them a couple of times. We are at 3, and we need to get it up to 10. What I will do then is I'll first do add 3 points, call that 3 times, because then we'll go up to 12. My calculation is correct. Let's run this. Yes, we are indeed logging 12. That means that we can remove 1 point 2 times. That should get us to 10. Yes, we are logging out 10, so we have solved the challenge. Great job. Okay, it's time for some strings and numbers repetition. You are going to add a bunch of strings and numbers together and try to predict what the result is. So here, after each one of these lines, I've added 2 slashes. That means that you can write your prediction. Try to go through all of these and then run the code and see how you did it. And then I will give it a shot afterwards as well. Good luck. Okay, starting on the number 2. That is a string plus a number. We know that JavaScript then turns both of these into strings, so it becomes 22. Here, 11 plus 7, that's just 2 numbers. We get 18, and as a number this time, and not as a string. 6 plus 5, you might be fooled to think that JavaScript would treat this as a number calculation since the number is first, but no, actually, the string wins, and it becomes 65. Likewise with this one, here it's very natural to think that what you want to do is add these 2 points together so that it's my points is 14, but no, since you have a string here, everything will be turned into a string and the result will be my points, colon 59. 2 plus 2, that's 4, just a number. And finally, 2 strings, of course, becomes a string, 1114, like that. Let's run this. And indeed, all of my predictions were correct. Phew, that was good. Otherwise, I would lose all my integrity. So I'm really happy about that. Let's move on. Okay, let's imagine that you are working on an e-commerce website. And this website sells shoes. So here you can see a Nike shoe with a purchase button. The HTML is located here, of course, with an image tag, the paragraph for the Nike shoe, the button. But then there's also an empty error paragraph. And this is pretty common because in case there's an error happening, for example, the purchase didn't go through or some kind of bug caused the operation to fail or whatever it is, we want to render something inside of this paragraph. So that is your job in this challenge. You are going to set up the JavaScript so that when the user clicks on the purchase button, you are to render out something went wrong, please try again, in the paragraph that has the ID of error. That's, of course, this one. And the button they will click is, of course, that one. You can see there is some CSS here, but you're not going to worry about that because this challenge is all about the JavaScript and, of course, also hooking up the onclick event listener on this button. You should know how to do that by now. And you should also know how to render text inside of a paragraph. So go ahead and give this one a shot. And then, of course, I will show you the solution afterwards as well. So there are 2 parts to this challenge. First, there's registering that the user clicks on the button, and then there is rendering out the text in the DOM. So let's take first things first, the button. So I'll head over to the button and do an onclick event listener, and here we need to specify which function we want to run. We haven't written any function yet, so let's do that. We'll do function. I'll call it purchase, because that's what the user is trying to do. Open and close curly brackets. Now I can take this function and specify that when the user clicks the button, we want to call this function. Good stuff. Let's just console log out button clicked. Run this code, try to click the button, and yes, we are rendering out button clicked. Good. The next step is to grab a hold of the paragraph that we are going to render text inside of. So we'll do let error paragraph and do document.getElement by ID, passing in error like that. Yet again, we can do console log just to verify that we have grabbed a hold of the right paragraph. We run the code and bring up the console, and yes, we can see that we have the paragraph. Then inside of the purchase function, this is where we want to trigger the rendering of the error text. I'll do error paragraph dot text content equals this string right here. Now, if we rerun the code, click the purchase button, yes, something went wrong, please try again. And as you can see, it's rendered out in red text, which is very common because we want to grab the user's attention and tell them that something wrong has happened. And that's, of course, something we have specified in the CSS, but this challenge is not about CSS, it was about JavaScript. So great job solving this. Let's move on. Okay, in this challenge, you are going to create a very basic calculator. As you can see in the mini browser here, I've set up the UI for you. Here we have 2 buttons. Here we have the numbers, 8 and 2. And then there's 4 buttons, add, subtract, divide, and multiply. If I try to click one of these now, nothing happens. But what you then, of course, want to happen is that, for example, if you hit subtract, you are to take 8 minus 2, which is 6, and then render that out in the sum here, so that it'll say sum colon 6. Taking a look at the HTML, we can see that the numbers at the top, num1l and num2l, that's the 8 and 2, are simply spans. However, they are empty. So how come we have content in them when they are rendered? Well, that is because I'm doing that in the JavaScript, first defining 2 let variables, num1 and num2, and setting them to 8 and 2, and then doing document, getElement by ID, fetching out num1l and num2l, and setting each of their text contents to num1 and num2. And that's why we're rendering out these numbers. Moving on to the buttons, you can see that they are very simple. Only the tag and the text. I have not created the event listeners because that's your job. And then finally, the span with the ID of SumL is where you are going to render out the result of the calculation. So summing this up, you are to create 4 functions here in the JavaScript file: add, subtract, divide, and multiply. And then you need to call the correct function when the user clicks on one of the buttons. So obviously, when the user clicks the add button, you are to call the add function, and vice versa with all the others. Then inside of the functions, you are to perform the given calculation. So in add, you need to add num1 and num2 together. And subtract, you will take num1 minus num2 and divide, and so on. Finally, render the result of the calculation in the paragraph that has the ID of SumL. So go ahead and give this one a shot, and then of course return back to the screencast when you want to see my solution. Okay, let's do this. I'm going to start by creating here an onclick event handler and call this function add, because when the user clicks the add button, we want to invoke a function which are to be named add. And then we need to create the function add. Here, what do we want to do? First, we just want to check that it works. Run the code, add. Yes, we are logging it out. Now, then we need to grab a hold of the sum paragraph. So I'll do let SumL equals document getElement by ID. And the ID is sum-l, like that. Here, I'm just going to see if it works by doing SumL.text content equals num1 plus num2. Rerunning the code. And yes, there we can see we're rendering out 10. However, we wanted to render out sum colon equals 10. So let's try adding that. Sum colon plus num1 plus num2. Rerunning the code, hitting add. And now we have come into a situation where actually JavaScript is turning all of our 3 values into strings. As you remember, when you add strings and numbers together, they're all turned into strings. What we need to do here is first perform the calculation and then concatenate that with the string. So we'll do let result equals num1 plus num2, because here we're only adding numbers together, and JavaScript will treat them as numbers and thus perform a mathematical calculation and not a string concatenation. So then we can replace this expression here with result. Rerunning the code, clicking add, and yes, there we go. Great stuff. Now, I'm a little bit lazy, so I'm just going to copy this, paste it in, and do subtract, and simply replace this with a minus. Add the onclick equals subtract, like that. Running the code, clicking subtract. Oh, sum is 6. Brilliant. Now, we'll just copy paste again. Divide should get this, use the division symbol, and multiply should use the multiplication symbol. Now we only need to add the last two event handlers. Divide is the name of that function. Space here, and multiply is the name of the final function. Running the code, trying add gives 10, brilliant. Subtract gives 6, that's correct. Divide rightfully gives 4, and multiply 16. We have made a calculator. Good job. You have all reason to be proud of yourself now. And if you didn't manage to do this one, if you found it a bit too hard, now that you've seen the solution, just go back and try it again. That's great practice and gives you the muscle memory you need. And when you're ready, I'll see you in the next cast. Hey, and welcome to Building Blackjack. I'm so excited about this one because you are going to learn JavaScript while building one of the most iconic casino games ever. Here is a sneak peek of the app we are going to build. And while it's not a full-blown Blackjack app, of course, it does share a lot of the functionalities with Blackjack apps you can play on online casinos. And speaking of that, that's actually a huge market. People spend over $20 billion per year gambling on online casinos. And personally, I love playing poker and blackjack. I think my life actually peaked when I won €100 on a casino in Prague in 2016. That made me feel like such a gangster. I spent the rest of the weekend squatting in front of fast cars, like this Mercedes, this Hummer, this BMW, and this Bentley. So my goal with this section, of course, is to make you feel as cool as I did in 2016. And with that out of the way, let's just get started. Okay, so we're going to kick this off with a challenge. You are going to create two variables, the first card and the second card. Then you're going to set their values to a random number between 2 and 11, as that's the values you can draw from the deck of cards in Blackjack. Secondly, you are going to create a variable sum and set it to the sum of the two cards. So go ahead and do this right now. Okay, let's do this. Start with the first card. I'm going to set it to 6. And the second card up to 9. Then the sum, of course, equals first card plus second card, like that. Let console log out the sum, run the code, and yes, indeed, we get 15. Great job. Let's move on. Okay, so we are ready to build the logic of our Blackjack game. Now, let's have a look at how Blackjack works before we try to formulate this in JavaScript. So the point with Blackjack is to get a hand that sums up to exactly 21. And if you don't get 21, at least you want to get as close to 21 as possible, but never above 21, because if so, you're out of the game. So here are 3 scenarios. One where you have 2 cards on your hand, that's your starting hand, and they amount to 15. So you're still in the game. No big reason to either cry or celebrate. And then there's the other case where you have a king and an ace. And since the ace here equals 11 and the king equals 10, you've got Blackjack. So, woohoo! And the third scenario, you started out with a 10 and a 6, and then you asked for a new card, but damn, you ended up at 22. So you're over 21 and sadly, you've lost your money. So now the question is, how do we translate these things into JavaScript? Sadly, JavaScript isn't as smart as you are who can understand this by just hearing me talk about it. JavaScript is kind of stupid, and it needs you to describe the logic 100% correct. So let's just do that so you get to see it in action. We start out with writing if, and then open and close parentheses, and then it's the sum of our cards that we're going to check. So we say if sum is less than 21, just like we were doing here. So this crocodile mouth is something you might recognize from your maths class at school. And it kind of makes sense because here on the right-hand side, you can see that's where the gap between the teeth of the alligator is the largest. Whereas at the left-hand side here, the gap between the teeth is the smallest. So small value here, large value here. If this condition is true, meaning that sum is less than 21, well then we add two curly brackets and tell JavaScript that we want to execute the piece of code inside of those curly brackets. So we'll do console log. Do you want to draw a new card? Since that's what you can do in this scenario, you are still in the game and you can draw another card if you want to. But there are cases where this isn't true and we need to account for those as well. We do that by writing else if and open and close parentheses. And here we write sum equal 21. This is else if sum equals 21. Then we want this code to be executed. And this triple equal operator is different from this one right here. Here we are saying that we want the sum to become firstCard plus secondCard. But here we're asking, is the sum strictly equal to 21? And you say strictly equal when you see 3 equal marks. And don't worry about why it's 3 and not necessarily 2. We're going to get back to that later. For now on, just use 3 equal marks when you write else if statements where you are checking if a variable is exactly some kind of value. So if the sum is 21, what is the case then? Well, woohoo! The player has blackjack. So we'll do console log. Woohoo! You've got blackjack, like that. And then the third scenario, we'll do else if yet again, sum. And what do you think we'll use here? Of course, we'll use this one right here. Because if the sum is larger than 21, then the user has lost. Sum is greater than 21. Open and closed curly brackets. Console log. You're out of the game. Like that. Actually, let's add these emojis as well. There we go. Now, one little thing I want you to notice here is that here I have to use double quotes to wrap this, as I'm using single quotes to create this you've and your words. Because if I was using single quotes here, it would be completely off because JavaScript would have thought that I was intending to close off this string right here when I'm not intending that. I was just writing you've instead of you have. So just a little digression there. Now let's run this code and see how it works. We'll hit run and yes. Do you want to draw a new card? We triggered this, which seems correct since 9 plus 6 is 15 and that is indeed less than 21. Let's try to do 10 and 11. So this is blackjack. Yes! JavaScript triggered line 8, which is what we wanted. And finally, let's say that we got 17 on the first 2 cards and we really wanted a new card. We wanted to take the chance, but we bummed out by getting 6. If so, our sum would be 23. And what do you think will happen? Yes, this line of code should be run. I'm going to run the code and boom, you're out of the game. Now, a final thing I want to tell you about before we move on is that we could actually skip all of this code if we wanted to and do like that. Because if sum is not less than 21 and it's not exactly 21 either, meaning we've jumped to the third clause in our if-else clause, then it must be over 21. I mean, there's no other alternative in the entire universe. So there's no point specifying that sum here should be over 21 for this block of code to be executed. Meaning we can just skip it. So that we have if sum is less than 21, execute this. If sum is exactly 21, execute that. And in all other cases, execute this. This will work, as you see, by running the code in the exact same way. Okay, now that you know that, let's move on. Now it is your turn to write an if-else statement. You are to check if a person is old enough to enter the nightclub, which has a lower age limit at 21. And then you are to log a suitable message to the console in both cases. And by that I mean if the user is less than 21 or if the user is 21 or older. So I've defined the age variable here and also written pseudocode. If less than 21, then a suitable message would be, for example, you cannot enter the club. Else, meaning all other cases, because if they're not less than 21, well, they have to be 21 or above, then you are to log something like welcome. Go ahead and give this a shot. And if you have forgotten how to write an if-else statement, just go back and rewatch the previous lesson. And notice here that I don't have an else-if statement in between here. I only have the first if and the final else, not the else-if which we had in the previous lesson. And that is because I want you to think for yourself and try to figure out, well, how do you write this with only an if and an else, and not the if-else in between? Just give it a shot, and I will show you the solution as well when you return back to this screencast. Okay, hopefully that went well. Let's do this. If less than 21, we have to do age is less. Remember this alligator mouth here. And 21, like that. This means the person is maximum 20 years old. Then we are to do following, well, console.log. You cannot enter the club. And then we simply do else, and then the open and close curly brackets. And here we can console log welcome. Running the code, we get welcome, that's correct. Trying to lower the age to 20, we get you cannot enter the club. Now, a final thing I want to point out is that you could also solve this by using another comparison operator, which is the less than or equal to. That means a slightly different thing though, because it checks that this value is less than or equal to 21. So if we take this back to 21 and run it, you can see we get you cannot enter the club, which obviously is wrong. They should be able to enter the club at this point. So if we're using the smaller than or equal to operator, we have to use 20, because then we include 20. That is an upper range that is inclusive of that number. So now it works. Whether you prefer using less than or equal to or just the less than is up to you. You just need to keep in mind how that changes the entire expression. With that, let's move on. Let's practice if-else statements a bit more, because in Norway, we have this super cool tradition where when you reach 100 years old, you get a personal birthday card from the king. This is the king, King Harald V of Norway, and in this challenge, we are going to code the logic for this. So here it is in pseudocode. If less than 100, and here I'm talking about the age variable, of course, then you are to log something like not eligible to the console. Else if the age variable is exactly 100, you are to log something like, here is your birthday card from the king. And else, in all other cases, meaning they're over 100 years old, you get not eligible. You have already gotten one, because if they're 105 years old, they got their birthday card from the king 5 years ago. Okay, go ahead and give this one a shot, and then I will show you the solution afterwards as well. Okay, let's do this. If age is less than 100, we'll console log not eligible, and then we have to do the else if and specify the condition. Age is exactly 100, then we console log here is your birthday card from the king. And else, in all other cases, the person is over 100 years old, they have already gotten their card in a previous birthday, so not eligible. Let's run the code. Yes, 100, you are getting the card. At 45, you are not eligible. At 145, you are not eligible either. Finally, before you leave, let's take a closer look at this triple equals here, because it might seem like a little bit of an overkill to have 3 equal signs after each other. And that is a valid point. You could use 2. If we run the code, it still works with 145, and actually with 100 as well, it would still work. You are getting your birthday card. However, the thing with 2 equals, so-called double equals, is that it's a little less strict. So let's say that you by mistake passed in a string here as well, which has the same value of 100, but it's a string and not a number. If we run the code, you can see it still works. However, with the triple equals, running the code, then it doesn't work. Now it says not illegible, even though 100 is here as a number and 100 is here as a string. So double equals ignores the fact that this is a string and this is a number. Basically converts this into a number if it's a number on the left-hand side as well, so that this entire thing would be true. However, that's not what we want. We actually want to be strict in our code, which is why I would recommend you to only use triple equals. Ignore double equals. This forces you as a developer to be a bit more mindful about how you are checking your conditionals. You need to make sure that if you're starting out with a number up here, you're also comparing it with a number down in the conditional. But that's just good practice, being thoughtful as to what kind of data type you are using in your code. Just stick with triple equals and you'll be just fine. With that, let's move on. Okay, so now we're back at our Blackjack game, and you might have noticed that we've lost the code that we previously had. Well, that's the point of Scrimba. You are going to write the code, not me. So I want you to rewrite the conditional that I created previously, but with a slightly different take. You have to follow the logic that I lay out in the pseudocode here. So you have to use in the first if clause the less than or equal to operator. So you have to set it to less than or equal to 20. And then in the else if clause, you can use the strictly equal to check if the sum is exactly 21. And finally, you are going to use the else clause and not an else if on the third conditional, which I did previously. So go ahead and do this. And if you can't do it or want to see my solution, just return back to the screencast and I will show you how to do it as well. Good luck. Okay, let's do this. First, there's the if sum is less than or equal to 20, then we are console logging out this string right here. And then we do else if, the same as we did last time, sum triple equals 21. That's the Blackjack case. And here I'm lazy, so I'll just copy paste this one and then this one in here. And then finally, not doing else if and checking for the condition, but just doing the else. So all other cases. And then pasting in this you are out of the game string like that. Good stuff. Let's run the code. And yes, we have 17 here and we rightfully so logged out. Do you want to draw a new card? Good stuff. If we try to hit one more time with another 10, we are out of the game. Good stuff. And how about a 4? Blackjack. Woohoo! Great job. Let's move on. Okay, so our game is coming along really nicely here. However, there's a big problem. And that is, let's say that you are playing this game and you get Blackjack. So you get a 10 and an ace. And boom, you've got Blackjack. And down here at line 13, you of course want to cash out your money. You're going to get the pot on the table. However, at this point, down on line 13, JavaScript has no way of knowing which console log it logged out. It doesn't remember that. So what we need to do then is introduce a new variable that keeps track of this state, you can call it, the state of the game. Like, has the user gotten Blackjack? Or maybe has the user lost? Or whatever it is. So what we then want to do is, for this scenario, have a variable that reflects whether or not the player has Blackjack. And when I say whether or not, yes or no, is there a data type in JavaScript that you think might be suitable for describing such a state? If you guessed a boolean, a true or false, that is correct. So what we'll do is we'll do let has Blackjack like that and set that initial value, of course, to false because by default you don't have Blackjack. And then here inside of the else if clause that describes the Blackjack case, we're simply going to reassign the has Blackjack value to true instead. Now, down at line 16, if we log this out, the has Blackjack value, and then run this code, boom, you can see that we're both logging out on line 9, and we have persisted the state so that line 16, for example, can start writing the code for taking the cash that's on the table that now is rightfully yours, and then deposit it into your account. So now we have an app that keeps track of the data, of the state, in a much more sensible way. Now, I want you, of course, to write this kind of logic yourself. So in the next cast, I'm going to give you another challenge so that we can keep track of even more of the state of this game. I'll see you there. Okay, so now it's your turn, and you are going to make the state of our game a little bit more robust. Because at this point, we're only tracking if the player actually gets blackjack. If the player busts out and gets 22 or more, we're not tracking it. And obviously, we have to do that. So I want you to create a variable called isAlive and start by assigning it to true. And then you're going to flip that value to false inside of the appropriate code block. So there's 3 code blocks, the if block, the else if block, and the else block. And you, of course, then have to pick the correct code block and then write that line of code that flips the value to false. And finally, log it out to check that you're doing everything correctly. So good luck, go ahead and do this, and then I will show you the solution afterwards as well. Okay, let's do this. Starting up here, we're going to create a let variable called isAlive and assign that to true, because when you're starting out, the player is still alive, and at which point is the player no longer alive, meaning out of the game? Well, that's obviously here in the else block, because that's the case if the sum is 22 or more. So here we'll do isAlive equals false. And then finally, we'll console log isAlive, like that. We got true because actually we had blackjack, and rightfully so, the player is not dead. How about if we pretend that we add a third card here? It's a really stupid idea. Pick a third card after you've gotten blackjack, but let's just pretend that. We'll run the code and boom, false, no longer alive. Great job solving this challenge. Let's keep up the pace and move on. Now that you've learned about booleans, let's take a look back at the conditional you wrote. Because one thing you probably didn't think too much about when you wrote your conditionals is that the expressions inside of the parentheses would be translated by JavaScript eventually into a boolean. So it would be either true or false. That's always the case with expressions passed into conditionals. Because here we are comparing 2 numbers, and one of them are either larger than the other or they are 2 equal numbers. So the claim you come with has to be either true or false. Let's try to play this out using an example. For example, when you've gotten 2 cards, a 10 and an 11, meaning you have blackjack, in that case, sum will be 21. And the claim you come with inside of the first if statement, obviously that is a lie, meaning it gets evaluated to false. In the second condition, though, you're saying that sum is equal to 21, and we know we are going to translate sum into 21 because that's what it is. So here you're saying 21 triple equals 21. Well, yes, that is a true statement, so that becomes the true boolean. And here you can read through it. If false, well, then we're going to skip the body of this statement. Else, if true, yes, we like true, then we are going to execute that piece of code. So this is essentially what happens when you run the code with specific values for these variables. Rewinding it back, what I want to do now is stress test your comparison and Boolean skills. So I'm going to paste in a bunch of console logs here and then comment out our blackjack game. Now your job is to look at each of these expressions and predict whether true or false is logged to the console. So write either true or false after these 2 slashes on each of the lines from 1 to 7. And then, of course, when you've given it a shot, run the code and see how it went. And then I will do the same thing afterwards as well. Go ahead and do this right now. Okay, let's do this. First, 4 triple equals 3. Obviously, that's wrong. It's going to log out false. 5 is greater than 2. That is true. And 12 is greater than 12. No, 12 is not greater than 12. It's exactly the same. So this will be a false statement. 3 is less than 0. Again, that's also false. 3 is larger than or equal to 3. Yes, that will be a true statement because it's not larger than, but it is equal to. So true. 11 is less or equal to 11. Again, it's not less than 11, but it is equal to 11, so it's true. And 3 is less or equal to 2. No, 3 is actually larger than 2, meaning that this is going to be false. So this is my prediction. Let's run the code, bring up the console, and yes, phew, I was right. Very good. Let's move on. Welcome back, my friend. I hope you are ready for a new challenge, because that is exactly what I have in store for you now. Actually, it's a 3-part challenge, because you are going to make our program a little bit more robust in the sense that it might be that these console logs here that we're just throwing out into the void, logging to the console and forgetting all about, can be used later on down the line, or that we, of some reason, want to keep track of them. Maybe we want to render it out at multiple locations in the app. Maybe there's a notification, and there's text, there's a log of messages you've gotten. Maybe we want to repeat it. I don't know. There's tons of reasons for keeping this data and very few reasons for just logging it out. We want to keep it in a variable, just like we've done here with the hasBlackJack and isAlive. So your 3-part challenge is to first declare a variable called message, and then assign its value to an empty string, and then you are going to reassign the message variable to the string we're logging out. Notice here that I'm using some fancy words, like I'm saying declare instead of create a variable. I'm saying assign instead of set its value. That's because I think you now are ready to hear some of these fancy JavaScript words, because there are subtle differences between these words. Like here we are actually declaring the variable, and then we are assigning it when we set the value to true. This is, after all, called the assignment operator in JavaScript. And then, naturally so, when we change a variable or assign it yet again, we reassign it. So I just want to use the correct terminology here. But I think it's important that you don't get put off by all of these words and think that you have to remember them all. You do not. It's perfectly fine to talk about this using your own words. Create, change, set the value, whatever. I just want you to also be exposed to these technically correct ways of expressing it. Anyway, enough talk. As I said, step 2, you are going to reassign the message variable to the string that we're logging out. So I don't want any more console logs inside of these 3 code blocks, because the only code block is the one you're going to create in part 3 of the challenge when you are going to log out the message variable. So go ahead and give this your best shot, and then return back to this screencast when you want to see my solution. Okay, hopefully that went well. If not, no worries. Let's do this together. First, we'll start by declaring this let variable. We'll call it message, and we'll set it to an empty string. Then on line 11, 13, and 16, we need to replace the console log with a message equals like that, and also remove this close parentheses. We'll do the same thing here. Remove this one and the close parentheses, and then write message equals. Finally, here as well. And then we are ready to log it out down here at line 21. So I'll log out the message, run the code, and as you can see, we're logging you are out of the game. That is correct, because we had this really stupid move where we got Blackjack, but we asked for a new card. So let's remove this, run the code. Yes, you have Blackjack. But again, with, for example, 14, and yes, I can now draw a new card. So, great job reaching this far. Let's move on. Okay, now it's time to fix our biggest flaw in our Blackjack game, which is that it has no user interface. If we want this to be a hugely successful online Blackjack game, it has to use HTML and CSS so that users can play it via a browser. And I've actually set up the basics for you here. You can see an HTML file with a head and a body, and then inside of the body we have an H1 with the text Blackjack, and also we are linking to the JavaScript file here on line 8. And as you can see, if we bring up the mini browser, this just renders out the H1 tag. So your job now is to link this HTML file to the CSS file. You can see I've created just one CSS rule in this file, and it will be applied, changing the color of the title when you manage to add a link to the CSS file here on line 5. So I almost every single time have to search on Google for how to link to CSS from HTML. I end up at something like this. So I want you to do the same thing. And one tip would be to find this W3 schools site here, as they often pop up on Google and contain the necessary information. So go ahead and figure this out on your own, and then I will show you the solution afterwards as well. Okay, hopefully you nailed that one. If not, no worries. Let's first check out Google. And then if we click into the W3 schools site, you'll see the following. And it tells us that there are 3 ways to insert CSS: external, internal, and inline. And we are using an external CSS file, so we want to scroll down to external CSS. If we do that, we see the code here, and the line we're looking for is this one: link rel equals stylesheet, href equals mystyle.css. Okay, good. So let's do link rel, and that is short for relation. So what is the relation between this HTML file and the current file you're going to point to now? Well, it is that the file you are pointing to is a style sheet. Because as you remember, CSS is short for cascading style sheets. And then it is the href, which in our case is index.css. We are in the same directory, so we don't need to navigate into a folder or anything like that. We'll just write index.css. And the href attribute is something you should be familiar with by now, as that's also what we use when we are creating links. Now, let's run this code. Boom! You can see the color has changed, meaning we are indeed importing this style sheet. Great. Okay, now it's time for you to style this app. Because as you can see, it looks kind of bad. I've added a few more paragraphs here, as you can see. One which says want to play around and has an ID of message shell, and then just 2 other paragraphs that will display the cards and the sum eventually. And your job now is to take this HTML and make it look like this. If we head into the index.css file, you can see it says complete the CSS styling according to the provided design. And here I've created 2 new selectors for you, the body and the message shell. And the thing is, you can create this entire design by only using these 2 selectors. So that's why I have them here for you. I've also added a table.png inside of an images folder. That is for the casino background that we are using here. And you've learned all about how to do this styling in previous modules of the career path. So if you struggle, you can go back and rewatch some of those lectures if you want. Now, before you start solving this challenge, I'm going to add the font family for you because we're using the Trebuchet font here. You haven't really learned how to do that, so I'm going to do it for you. We do font family up in the body, and there I specify Trebuchet. And as you noticed, what happened now was that the editor gave me a bunch of other fonts as well. And this is called a font stack. And the reason we use font stacks is because if your operating system doesn't have Trebuchet MS installed, well, then your browser can't show that font, unless you've also imported it from Google Fonts, for example, or included it in your project, neither of which we have done right now. So if your operating system can't show Trebuchet MS, then we're telling it to look for Lucia Sans Unicode then. And if you don't have that either, well, look for Lucia Grande, and so on and so on. So it kind of ensures that at least we'll find a somewhat similar font. As it moves downwards in the stack, it'll at least find a sans serif font here, which is our final choice. But let's stop with fonts there. I don't want to get deeper into it. Now we have the Trebuchet font visible, and hopefully it's visible on your end as well, because Trebuchet is one of those fonts that are so-called web safe, meaning that almost all operating systems have them installed. So it's safe to use. Now I want you to take a look at this design and add whatever CSS you need to the body and the message shell so that you turn this boring page into what looks much more like a real blackjack game. So go ahead and do this right now. Okay, hopefully that went well. I'm going to start with the background image. So I'm going to write background image, and then fetch this table.png here. I can do URL, open and close parentheses, then navigate into the images folder and grab a hold of the table.png, like that. Now you can see we have the nice background. However, if I drag this wide, you can see that at some point we reach the end of the image and CSS adds the image yet again after that. And we get this ugly looking line, which we don't want. We instead want to use the background size property and set that to cover. Now, no matter how wide we make it, the image still covers the full width. Okay, next step is to center this text and make it white. So we can do text align center to center everything, and color white, like that. So with this, we are turning everything into white, except for the H1, which you can see here we have specifically specified that the H1 should be color goldenrod, and that overwrites the color white on the body element. Next up, you can see here the text is a bit bolder, so we want to do that as well. We want to do font weight bold, like that. Starting to look good. There's just one final thing, which is that you can see the message element, which is the message for the user, is in italic. Here it's still just normal. So in the message L, we'll do font style and set that to italic, like that. And there we have a neat looking Blackjack game. So with that, let's move on. Okay, so now we need to enable our user to click a button to play the game. And you are going to do this through a challenge, of course. And I'm really excited about this one because it includes both HTML, CSS, and JavaScript. So this is the first time where you'll use all three languages to solve a problem. And the reason that this is so cool is because this is how it works in real life. When you get a job as a professional developer, you'll juggle between HTML, CSS, and JavaScript all the time. And this is an opportunity to start practicing exactly that. So it's a three-part challenge, starting here in the HTML, where you are going to create a button that says Start Game. And it should call a Start Game function when it's clicked. So obviously, then you also need to create that Start Game function. You'll do that in the index.js. Here we are to create the Start Game function and move the conditional below, line 11 to 20, that's these lines, into the body of the function, so that this code is run when the button is clicked. And then finally, you have to make the button look good for the user. You are going to style it according to the provided design. And that is exactly here. You can see the start button. So just click to open this slide whenever you need to take another look at it. And doing this, translating a design into CSS, is something the front-end developers do every single day. So it's great practice. I've given you three values for properties here. There's the color of the text. That should have this hex value. The width should be 150 pixels. And the background should be goldenrod. Same as the text color on the H1. This is a big one, so I can totally understand if you'll struggle a bit going through this one. But give it your best shot and then return to this screencast when you want to see my solution. Good luck. Okay, hopefully that went well. Now, let's do this. Here, we'll do button, like that, opening tag, and then I'll do the closing tag as well. And inside, we'll write start game, like that. Let's run the code, and it looks not particularly good, but it's at least there, and it's actually centered. The reason for that is because here on the body, we are centering all of our text, and that also centers the button. Next up, we need to call the start game function when it's clicked, and if you remember how that was, then you'd write onclick equals, and then the start game with open and close parentheses inside of a string right here. So when the button is clicked, we're going to call or invoke the start game function. Then we need to create that function, and if you remember how to do that, it is through the function keyword, function, and start game, open and close parentheses, and then curly brackets for the body of the function. Inside of here, we are going to take this code, copy it, paste it in. I'm going to give it a tab so that it looks better, like that, and remove the empty lines. Now we have this. Let's rerun the code and see if it works. Yes! Previously, we got this console log just by refreshing the page, but that doesn't happen now. I have to actually click the start game, then we run this, then we console log out the message. Great job. Now let's move on to the CSS. Okay, this is how we want it to look. Let's take the first three provided design hints and see how close we get just by implementing them. Text color, that is the color property. Like that. You can hardly see it since the text is so thin, but that's okay for now. Let's just set the width with 150 pixels, like that. Okay, looks a little bit better. And the background, that should be goldenrod. Okay, so looking a little bit better, but not quite this design here. As you can see, it has some space above and below the text, whereas this one is much more crammed. So let's add that. And if you remember from the CSS section, you could add that space by using the padding. That's padding top and padding bottom. I'm going to set 5 pixels. Looks about right. Padding bottom and do 5 pixels there as well. Yeah, not too bad. However, as I mentioned, this text is really thin. And here it's much thicker. So let's actually do font weight bold. Yes, that looks much better. Now, the next thing I want to fix is the border around the button, because you can see it's totally clean here. It has no border, but the default styling that our browser provides has this little border. So we want to do border none. Okay, now it's actually pretty similar. They're almost identical, but only one thing separates them. And that is that you can see the edges are sharp on this one, whereas the edges are a bit rounder on our provided design. So that is the border radius, and pretty subtle. So I'm going to try 2 pixels. And yes, that looks, as far as I can see, identical. So this was a huge challenge, and you had to context switch between HTML, CSS, and JavaScript. So be really proud of yourself for reaching this far. If you struggled and didn't really manage to get to the finish line on your own, I think you should just go back and try it again now that you've seen my solution. That's a great thing to do to reinforce what you've just learned. Whatever you do, I will see you in the next lesson. Okay, so now our player can click the Start Game button like this. However, we're only logging out the message. Obviously, we don't want to do that. We want to display that info on the page, along with, of course, information about the cards and the sum. But starting with the message, I want you to solve a 2-part challenge. First, you are going to store the message.el paragraph, that is this one right here, in a variable called message.el using the camel case naming convention. And then you're going to display the message using message.el.textContent. Then, of course, you can remove the console log right here since we don't need it anymore, as the message will pop up here in our app instead. So go ahead and give this a shot and return back to me when you want to see my solution. Okay, so the way to do this is, if you remember, first by creating a variable with let message.el, and then using the document keyword dot get element by ID, passing in the ID, which we can see from the HTML, and just copy from there actually, and paste then in here. As always, console logging to see that we are on the right track, running this code, and yes, there we can see we are logging out that element. Now it's just a matter of deleting this line, doing message.el dot text content, and what do we want to set the text content to? We want to set it to message, like that. If we now run the code, hit the Start Game button, yes, there we got, do you want to draw a new card? Great job. Now, there's one thing I want to do before we round off, and that is actually to remove these emojis, because when they are italicized, they don't look that good. And while that isn't the most complicated thing to fix, it's not something I think you should learn right now. I want to keep up the pace. And also, when we see this text here rendered on the page, it's kind of our dealer speaking to us in italic text, and I don't think our dealer should show that much emotion. So it makes sense to remove these emojis like this. And also maybe make it a bit more neutral. The dealer will just tell us that we have blackjack. It won't shout out, woohoo! So makes more sense. Draw a new card. Yeah, looks good. If we get blackjack, yeah, I think that looks good. So with that, let's move on. Okay, so let's make our game a little bit more useful, because now you can click the Start Game button, and indeed we get the message from the dealer, but we have no idea what our sum and our cards are. So we obviously need to render that out. And we're going to start with the sum. So it's a 3-part challenge where you first have to head into the HTML and there give the sum paragraph, that is this one, an ID of sum-l. Then you are to store the sum paragraph in a variable called sum-l, like this in camel case. Finally, render the sum out. So here I'm talking about the actual numeric sum on the page using this format. So sum, colon, and then the given sum you have up here. So here you have to keep this text, which is already in the DOM, intact. But we have done that before, so hopefully you'll manage it. If not, no worries. You can just revert back to this screencast and I will show you how to do it as well. But go ahead and give this your best shot right now. Okay, let's do this. First, we'll give this an ID of sum-L. Moving over to the JavaScript, we'll do let sum-L with the camel case this time, and do document.getElement by ID, open and close parentheses, and the quotes, passing in the ID that we just added to the HTML element, sum-L. Now, just to be certain, let's just console log the sum-L from the code. Yes, indeed, we are grabbing the element. And then we need to render out the string of sum, and then the actual sum, which in this case is 14, from this variable up here into the element itself. And the way I'll do that is I'll use sum-L and then text content, which you should have seen a few times by now, and set that equal to not only the sum, because if we do that, let's rerun the code and start the game, then we simply just clear out the existing text, whereas we want to keep the sum there, and we can do that in multiple ways. But the way I'll do it is simply just write sum, colon, a space, and then plus here, so that we just reconstruct the default text as well in addition to the sum. I think this is a nice way of doing it. So if we run the code, start the game, yes, there we go. Now, before we move on, I want to teach you about another way of grabbing elements from the DOM. Because we've used getElementById a few times now, so I'm assuming you're comfortable with this technique and are ready to learn another one. And that is something called the query selector. And to learn that, let's comment out this one and copy it to a new line where we can change it. And here, instead of getElementById, we'll do query selector, like that. Since this is a more dynamic method, we have to be a bit more specific in the value we pass into it. So here we actually have to pass in a hashtag in front of the sum-L to tell the query selector that it's actually the element with the ID of sum-L that we're looking for. Because unlike the getElementById, we're not specifying that it's an ID in the method name. It's just called query selector, which is kind of a broader expression. So query, that's another word for question, and selector, that refers to CSS selectors. So we're kind of asking for an element by its selector, and then we specify the given selector inside of the parentheses. So here, if we run this, start game, the exact same thing happens. Now, if you've forgotten what a CSS selector is, we can head over to the CSS, and it's these guys right here. The body, that's just selecting the body element, this one. And then there's the ID selector right here. You can see we are using the hashtag to grab the message L, because this paragraph has an ID of message-L. Likewise, sum has an ID as well. So we're using the hashtag to tell query selector that this sum-L comes in the form of an ID. Now, this means that we could change this to a class instead. However, then we also have to change this hashtag and replace it with a dot. Hopefully you remember that the way to select CSS classes is by using the dot. If we run this, it still works. And actually, we could even pass in just the element name as well. So we could do body right here. However, it would break our app since we're now, just clearing out the entire body when we are running this piece of code down here on line 11, because now sum-L actually refers to this entire body. So as you probably understand, query selector is very powerful, and you will see it used in a lot of tutorials here on Scrimba. But as for right now, I just wanted to show it to you so that you are prepared once you see it in other tutorials and out in the wild. In the near future, I am going to stick with the document.getElementById. as that does the job for us, and it's also a very simple method to understand. So I'd like to avoid the added complexity of jumping between getElementById and querySelector if we can. With that, let's just move on. Okay, let's continue building that muscle memory of yours. You are going to do almost the exact same thing as you did with the sum, but this time with the cards. Because obviously, when you start the game, you can see your sum now, but you can't see your cards. That has to be fixed. So it's the same 3-part challenge, starting in the HTML, where you are to give the cards paragraph an ID of card cell. Then in the JavaScript, you are to store the cards paragraph in a variable called card cell with camel case, and then finally render it out in this format right here. So go ahead and do this right now, and then I will show you how I would do it when you revert back to the screencast as well. Okay, let's do this. First, giving this an ID of card cell, then storing the card paragraph in a variable called also card cell. Let cards L in camel case this time, document.getElement by ID, passing in cards-L like that. Now I'm just going to jump straight to this line here and do cards_L.textContent equals, constructing the entire content of the paragraph this time. So we're clearing out the text that's already there and replacing it with a new cards colon. This will be actually cleared out and replaced using JavaScript. And then plus the first card, and then I have to add a space between the first card and the second card, and then the second card like that. If I run this code, start the game, and there we go. We have both of the cards rendered out. Great job. Let's move on. So our game really starts taking shape now. We hit the start game button, and we get the message, the cards, and the sum. However, the critical part of Blackjack is the ability to draw a new card from the deck. So we need to start building that feature, and we are going to first begin with creating the new card button that you can see on the slide here. So in this 3-part challenge, you are going to first head into the HTML and create that new card button, and then make it run a new card function when it's clicked. And then in the JavaScript, you have to create that new card function. And for now, it should just log out drawing a new card from the deck. Then in the CSS, you need to make sure that when these two buttons are rendered out vertically like this, so above each other, you'll need to make sure that this small space between them is added, because it won't be added by default. Now, if you enlarge in this browser and make it wider, they will render out besides each other. But you are not to worry about that layout. So make sure that you keep this browser window a little bit narrow so that they are rendered out under each other. And then make sure that you get this little gap here. So this is again a very holistic challenge. You are to write JavaScript, HTML, and CSS just like it is out in the real world. So go ahead and give this your best shot right now. Okay, hopefully that went well. If not, no worries, let's do this together. In the HTML, we are starting with the button, open and closing tag, new card, like that. I'll just render it out. Ooh, there we got it actually. Got them beside each other. We want them vertically like this. So there we can already see that we are missing the gap that we wanted. But that's the CSS part of the challenge. Let's continue on with the HTML and get that wrapped up. We'll do onclick equals, and then run this new card function, which we haven't created yet, which we are going to create right now, down here. Function, new card, open and close parentheses, and then the curly brackets for the body of the function. Inside here, logging out this string we got provided in the comment, like that. I'll run this code, hit new card, and indeed we are logging it out. Now, final step is to add this gap right here. We need to head into the CSS, and there are multiple ways to do this. One way is to just say that we want any button to have a little bit of margin below them. So this is about 4 pixels. So we could do margin bottom, 4 pixels. Like that. There we see that our button works. Alternatively, let's say that we in some case end up with a situation where something comes too close to the button on the top side of it. Well, maybe we need some margin on top of it as well. But if I now add margin bottom and margin top of 4 pixels here, margin top 4 pixels, what you'll see is that the gap here became twice as wide because it has the top margin that pushes it down and also the start game button that uses its margin bottom to get the gap even larger. So what we then instead can do is take 2 pixels on each. Now we have something that looks very much like this. And we have created our buttons so that they always have some space below and above themselves. And I think that makes a lot of sense, as buttons usually want a little bit of space around them. With that, let's move on. Okay, let's make our newCard function a bit more useful, because now it's just rendering out this string. What we wanted to do is to actually draw a new card and then add that new card to the sum and then rerun the code that is inside of the startGame function so that the sum is added to the page. And actually, later down the line, we also want to show the new card, of course, but as for now, we're just going to worry about the sum. So this is a 3-part challenge where you are to first create a card variable, and we're still just working with hard-coded card variables. You're just going to code it to a number between 2 and 11. Then you are going to add this new card to the sum variable. And the sum variable is the one up here, of course, which currently is the first card plus the second card. And in this case, it'll be plus the third card as well. So you need to plus equal the sum variable. And then finally, you are going to just call the startGame function. Because what does the startGame function actually do? Well, first, it renders out the 2 cards. In our case now, we'll have added the third card, so this will still be wrong. But line 13 will render out actually the new sum, because at this point, sum will have changed, since we'll have modified it down here. And then it'll show the message based upon the new updated sum. So actually, it seems that we can use this startGame function even after we've drawn a new card. And thus, we're going to rename it a bit later, but as for now, let's just keep it how it is, and your job is just to call the startGame function here on line 33. So, go ahead and give this challenge your best shot, and then I will show you the solution as well afterwards. Okay, let's do this. So, we'll do let card here. We'll set that to a random number between 2 and 11. I'll do 7. And then we're going to add the new card to the sum variable. If you remember how we add numbers to an existing variable, it's via the plus equal operator. So we'll do sum plus equal card. And then we'll call startGame. So startGame like that. Let's rerun the code. First, do startGame. Okay, do you want to draw a new card? I happen to want to do that, so I'll hit new card. And boom, I drew the 7 card, which then made the sum reach 21, which then again made our dealer tell us that we got Blackjack. So that is exactly what we want. Now, let's see what happens if we, instead of a 7, got an 8. If I now rerun the entire code, start game, and then hit new card, bam! Then we're out of the game since we have sum equals 22. And if we got a 6 instead, I'll rerun the code, start game, new card, then we still get the do you want to draw a new card text since we're still below 21. Now I can actually hit the new card yet again, and then we are out of the game. Now we're at 26. So this works for multiple cards. Of course, it's only the sum that's reflected right now, not the cards, so we'll have to fix that in a bit. But for now, let's just move on and first fix this little problem that the startGame function name doesn't really make sense anymore, since we're calling startGame here at a point where the game has already started, so semantically it doesn't really add up. So let's move on to the next cast. So the problem now is that the startGame function is triggered both when we hit the startGame button, which makes a lot of sense, but also when we click the new card button, because even though the new card button triggers the new card function, which is this one right here, that function itself calls startGame as well. And while this makes sense because we want to run this code, the fact that startGame still is called startGame doesn't really make sense. Because if another developer comes in here and looks at that code, he'll be like, why are we starting the game all over again when clicking a new card? That doesn't semantically add up. So what we want to do here is actually just change the name of the startGame function, for example, to renderGame, because that's essentially what we're doing. We're rendering out the current state of the game. So we can do renderGame, just rename this one and this one to that. So far, so good. But then the problem becomes that we're actually calling startGame here. And we could do renderGame like this, but actually I want to keep this startGame function intact, because down the line there might be some other things we want to do in this game initialization function. So I want you now to create a function that uses the name startGame and then just calls or invokes renderGame. That's all it should do, so that this startGame button will work. Because now you can see it doesn't work when I click it. We're actually getting a reference error saying that startGame is not defined, because we're trying to call a function that no longer exists. So go ahead and create the startGame function here on line 12 and make it just call this renderGame function right here. Go ahead and do this right now. Okay, hopefully that went well. The way to do it is through function and then startGame, open and close parentheses, open and close curly brackets, and inside here just call renderGame like that. Let's rerun the project. Hit start game, and yes, now it works again. Great job. Okay, so now we need to fix up the rendering of the cards, because if I hit start game and I get the 2 cards out and then hit new card, indeed our sum increases, but our cards paragraph are displaying only 2 of the 3 cards we've pulled from the deck, because we have a 10 and a 4 and a 6, whereas we're only showing the 10 and the 4 in the browser, because that is hard-coded here to only do that. No matter how many cards we pulled from the deck, this line 16 will always just render out the first card and the second card. So this line here in pseudocode says render out first card and second card. But what we instead need is something that says render out all the cards we have, regardless of how many cards. If we have 5 cards, it should render out 5 cards. If we have 2 cards, it should render out 2 cards. But that's not possible with the current implementation. And what we need is a central way of storing all of our cards. We need to store all of our cards in one variable, regardless of how many cards it is. And the way to do this is actually to use what's called an array, which is essentially a list of items. And I'm going to create an array here, and it's totally okay if you now feel confused. I just want to give you a little sneak peek at it before we take a deep dive and give you some practice on it. I'm going to do let cards equals, and then open and closed square brackets. That's the notation for creating arrays. And inside of these square brackets, I'm going to paste the first card, then a comma, and then the second card. So this is now a cards array that includes both cards, ordered by the first card first and the second card second. You can call this an ordered list of items. Now, we down at what's line 18 now, and replace the first card by referring to the array instead and doing open and close square bracket and 0. Don't worry about that. You'll understand that in a minute. Let's just now do the same things for the second card. Then we'll do cards, open and closed square brackets, and 1. So this is referring to this one right here, and 1 is referring to this item right here. And that is because arrays are so-called zero indexed. They start at 0 and 1, and if we add a third card here, that would be index number 2. But we don't have a third card, so let's remove that. Now, even though you might feel a little bit confused now, let's just run the code, hit the start game, and see, yes, that it still works. So this way of doing it was the exact same as what we had previously when you just hard-coded in first card and second card like this. Now this opens the possibility later down the line to render out all of our cards in a dynamic way inside of the cards element, regardless of how many cards we have inside of our cards array. So that was a lot of information. Now we're going to take a step back, work with arrays, get your hands dirty. So don't worry if you didn't quite understand this, as you will surely do that after the next few lessons. Okay, so arrays are ordered lists of items. However, that's a little bit abstract. So let's instead look at a real-world product and see if we can recognize any components that most likely use arrays as a data structure. So here we have a LinkedIn profile. This is Justin. He's a previous Scrimba student. And looking at this, there's immediately multiple components that most likely use arrays to render stuff out. You can see here on the right-hand side, there's some promotions, actually 3 of them, and that's basically a list of items. And while their order might be a little bit random, they still have a specific order. Likewise with the people also viewed here. That's a list of 4 people. Let's also scroll a bit down. Here we can see even in the main section, there's this component that says featured. That's his featured posts. And that's basically just a list of items. So LinkedIn probably uses an array to describe this data in JavaScript. So actually, let's just create that array. Do let featured posts like that, and then equals open and closed square brackets. The first one is actually Justin sharing the Netflix clone he built through a course here on Scrimba, and he actually deployed it as well. So he's going above and beyond. So check out my Netflix clone like that. The second one is actually a link Justin has shared to source code he's pushed to GitHub, which is also a great thing to do if you want to attract employers. So here's code for my project. I'm simplifying, of course, the data here because there are multiple parts of this. There's an image, there's text, there's comments, and so forth. But as for now, we're just simplifying it into strings. The third item here is actually Justin sharing the portfolio he has built through a Scrimba course as well. So I've relaunched my portfolio like that. There we have an array with 3 items. Now this line is pretty long, so sometimes you'll see an array formatted like this, as it makes it easier to see that it is indeed 3 items. And a key thing to observe here is that we add commas after the items, but not after the final item. So only between items, basically. So going back to LinkedIn, there are tons of components here that's probably utilized as arrays. For example, the work experience, that's a list of previous jobs, or licenses and certifications, that's a list of licenses. You can see the front-end path right here. And skills and endorsements. So a ton of examples. And now what I want you to do is to create an array that lists your experience or education or licenses or skills or something similar. You are to choose what you want this array to contain. But try to think, how can you best describe your either experience, education, skills, or whatever in a way that would make your LinkedIn profile look tempting for recruiters? As that's a smart thing to think a little bit about already, even though you're very early in your coding journey. So go ahead and do that, and remember that the items should just be strings, just as I've done up here. Go ahead and do this right now. Okay, hopefully that went well. Now I'm going to do it as well. So I'll do let and then experience. That's what I want to create my array about, my work experience. And I'm currently the CEO at Scrimba. Before that, I was a front-end developer at Soneta. That's a Oslo-based company for sea freight analytics. And also, as you probably remember from our subway counter app, I worked as a people counter out in the cold for a company called Norstat. So that is my experience. Now, before you move on to the next cast, I want to highlight the importance of actually being able to describe your background and your skills in a good way on LinkedIn. Justin here, the person behind the LinkedIn profile we looked at, he actually lost his job in the petroleum industry due to the coronavirus pandemic. And less than 1 year later, he now works as a professional software developer. And as I said, he did that mostly through Scrimba and was a super engaged student at our Discord channel. And what's so cool about how he did it is that he sent out over 100 job applications without getting much luck, but then went into optimizing his LinkedIn, and then suddenly he got 2 job offers. And the job he got actually came through a recruiter that found his LinkedIn profile as a result of keyword searches. Actually, he ended up tweaking his LinkedIn profile so that he attracted the right recruiter who got him an amazing job as a developer. So I wanted to share this with you. And if you click on this image, you'll be taken to the page for the podcast interview we did with Justin. so that you can listen to his story if you want to. For example, when you're riding the bus or out walking or cleaning or whatever. I don't want you to interrupt the course and listen to this instead of coding. It's more important that you code. But you can keep it in mind for the next time that you have half an hour or something, because I think you'll learn a ton about Justin, who at the age of 33 did his career shift. So with that little plug out of the way, let's... An important thing to know about arrays is that they are so-called zero-indexed. And that means that you want to grab the first item of the array. You do it through using the zero index, not the first index. And let me show you what that means in practice. Featured posts, that's our array. And I want to grab the first item, the check out my Netflix clone. I'll do that through open and close square brackets and then passing in the number 0. If I now console log this and we run the code, you can see, yes, that we are indeed logging out that string. So this isn't entirely intuitive, since we as humans normally start counting at 1, but in arrays you start counting at 0. So if this is the 0th index, which index does this item have? Take a guess. Well, it has the index of 2, even though it is the third item. If I run the code, you can now see that passing in 2 logs out I've just relaunched my portfolio. So here is the 0 index. This is the first, and here is the second. Now, with this in mind, I want you to practice this. So you are to take my experience array here and log out the following to the console, and in this order. So you are to start with the front-end developer in Soneta, then the people counter, and then CEO at Scrimba. So first this one, then this one, and then the first one. So you have to write 3 console logs and place them in order here, starting from line 18, so that I'm sure that you actually understand the concept of arrays being zero indexed. I'm going to comment out this one right here so it doesn't disturb you. Now go ahead and solve this challenge. Okay, hopefully that went well. Let's do this together. We're going to do console log. I want the front-end developer at Soneta. That is not the first, but the second item. And in terms of indexes, it's the 0th and then the first index. So then I need to do experience 1. Okay, I'm going to copy this one, paste it in again. Now I'm going to log out the third item, which is the second index. So that is experience 2. And finally, I'm going to log out this item right here. That has the index of 0. If I run this code, you can see in the console that we are indeed logging out the items in this order. Now, before we move on, I'm going to confuse you a little bit, because let's actually delete all of this, remove the console, and just go back to this featured posts. If I now do featured posts dot length, and then console.log this out, which number do you think we'll see printed to the console? Take a guess. Well, the answer is 3. And that might be a little bit confusing because I've just taught you that arrays are zero indexed. So the first is 0, the second is 1, the third is 2. So it would be natural to believe that the dot length property of this featured post is 2 because the final index is 2. But whereas indexes are zero indexed, the length is not zero indexed. We count the length of an array in just the same way you would count anything in life, which is starting at the number 1. So that also means that the length property of an array is always 1 larger than the final index. So this is one of those things that are a little bit unintuitive and confusing when learning JavaScript, and you probably will mix it up a couple of times. That's not a problem. Just trust me when I say that eventually this will become second nature for you. So let's move on. Okay, up until now, our arrays have either included only strings or only numbers. However, they're not limited to that. You can actually put any data type you want into an array, and you can mix as much as you want. So you can think of an array as kind of a composition of multiple data types and their values. So this is why arrays are what we call a composite data type. You can say it's composed by its items if you need it to make semantically sense. And you'll often hear this also referred to as complex data types. That is arrays and also, for example, objects, which you are going to learn about later. They stand in contrast to the primitive data types you have worked with up until now. The three primitives you have learned are strings, numbers, and booleans, because they are more primitive than arrays. They are not composed of many other data types, which arrays often are. So one analogy you can use is that the primitive data types are the Lego blocks, whereas the array, the composite data types, is kind of like the full Lego model, for example, after you've built a little house with your Lego blocks. But anyway, you shouldn't worry too much about this if you find it a little bit abstract and complex. As a developer, you don't go around thinking about, oh, is this a primitive data type or a complex data type? It just becomes second nature and you don't even think about it. So you shouldn't be put off by this, even though it's a little bit theoretical. Instead, I think you should just practice. Now I want you to create an array that describes yourself and use all the three primitive data types that you've learned so far. So it should contain your name, which is a string, your age, which is a number, and whether or not you like pizza, which should be a boolean. So go ahead and do this right now. Okay, hopefully that went well. Now let's do it together. I'm going to create an array called pair. And my name is Per Harold Borgen. I am 35 years old, and I do happen to like pizza. And I especially like pizza with pineapple. It's the best. Though I know that a lot of you don't agree with me, so let's not get into a discussion about that. Let's just move on with the course. One of the most common operations you'll perform on arrays is adding items to the end of it. That's, for example, what you want to do in our Blackjack game, where you start with 2 cards and then you want to draw a new card. That'll naturally then be put at the end of the array, for example, 6. However, the way to do that is not through actually changing it directly, which I did now. You use a method, which is called push, which allows you to, well, push things into the array. So you do cards, dot, push, and then open and close parentheses. And inside of these parentheses, you place whatever you want to push. So for example, 6. If we now console log the cards underneath our push operation, you can see we have added 6 to the array. So this here is actually called a method, which is just a fancy way of saying a function on an object. And you haven't really learned about objects yet, so don't worry about if you think this sounds a little bit abstract. But this operation here is pretty similar as the console.log, then passing in, for example, hello. Don't you think? We have the first object, cards or console. Then we have the methods, which is either log or push. Then we have whatever we pass into these methods when we call them. So this here, cards push, is conceptually very similar to what you've been doing all along. Let's now make sure that you build muscle memory on this by solving a challenge. So I want you to imagine that you are building a chat application. For example, the one I showed you here on LinkedIn, and the data structure we'll use is of course arrays, and we'll pretend that each of these messages is an item in the array. So when someone types in a new message and sends it, well, you want to push that new message to the array. So here you are to push the new message variable, that's this one down here, into the messages array. That's this one here. And then you are to log out the array to just verify that you actually succeeded in pushing the item. Go ahead and do that right now, and then I will show you the solution afterwards as well. Okay, hopefully that went well. Now let's do this. We'll do messages dot push, and inside of the parentheses we'll pass in new message like that, referring to the variable and not the hard-coded value, which we did up here when we passed in 6. So a little bit different, but still the same concept. Now let's console.log messages and then run this code. If we bring up the console, we have pushed the new message to the array because we're logging out the array with same here at the end. Now, a little mini challenge before you leave. Let's say that you wanted to regret sending this message, same here. and you wanted to remove it from the messages array. How can you do that? You haven't learned this yet, but this is a golden opportunity for you to Google it out and try to figure out how can you remove the last item in an array. So just see if you can find the answer on Google and then try to remove the last item of the messages array here on line 18. Go ahead and do that right now. Okay, maybe that worked, maybe not. If not, no worries at all. This is just a bonus. What you do is do messages dot pop and then open and close parentheses. Now, if we log the messages again and then run the code, open up the console, you can see we are logging two versions of this array. One from line 15, where the same here string is included as the last item, and once again from line 19, where the array is back to how it originally was, like this. So pop is kind of the opposite of push and not as commonly used, but I just wanted to give you a sneak peek at it, as you might come across it here and there in your development journey. With that, let's move on. Okay, now it's time for some repetition. You are going to do the exact same thing as I did before we had our little arrays deep dive. So you're first going to create a new array, cards, that contain the first card and the second card. And then in the render game, you are going to change line 18 so that it refers to the cards array when rendering them out. So not referring to first card and second card this way, but doing it via our freshly created cards array. So go ahead and do this right now. Okay, let's do this together. First, we'll do let cards equals open and closed square brackets, and then we'll set the first card as the first item in the array and the second card as the second item. And as you hopefully remember, we can now refer to these values by doing cards 0 and cards 1, like that. We'll run the code, hit start game, and yes, indeed, it works. Great job. Let's move on. Now that we have the first card and the second card in the cards array, we also have to, of course, add the new card to the cards array. So, quick little challenge. After this card has been created and it has been added to the sum, we also need to push the card to the cards array. So, go ahead and do this right now. All right, the way to do this is by writing cards dot push open and close parentheses, and then pass in the newly created card, like that. And in order to verify that this actually works, we can, on the next line, console log out the cards array, like that. Let's run this again, start game, hit new card, and there we can see in the console, now the cards array has been logged out with all the three cards, 10, 4, and 6. So we still aren't rendering out the third card though. And to achieve that, you have to learn how to count in JavaScript. Or strictly speaking, you have to learn how to write for loops. So over the next few casts, we are going to take a deep dive into for loops and then later return back to the Blackjack game so that we can fix it up. Let's move on. Okay, so now you're going to learn how to count with JavaScript. That might sound really silly. I mean, counting is so easy. If you ask a human to count, for example, if you say, "Pair, count to 10, I would go, "Yeah, sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, JavaScript is like that annoying person who then replies and said, "Well, where exactly do you want me to start counting? And by counting to 10, do you mean including 10, or should I stop before 10? And also, should I count every single number, or do you want me to, for example, only count the odd numbers or the even numbers or whatever?" So JavaScript is really like that annoying person that takes everything you say 100% literal. So when you ask JavaScript to count, you have to be super specific. We need to specify where we start counting, where the finish line is, and what the step size is. Here, I've already written the code for you, so let's just dissect it. We start with the for keyword. That's because this is a so-called for loop. But don't worry about that. Let's now look at the things that are inside of the parentheses here. Here you can see our starting condition, let count equals 1. So we're going to start our count at 1. Then we have a semicolon, and then we specify our finish condition, where it says count is less than 11. So we want count to always be less than 11. So maximum 10, in other words. We're never going to count over this number. And finally, the step size is that for each counting, you're going to increment with 1. So count plus equals 1. Now, these three conditions together describe to JavaScript how many times we want to run the code inside of the curly brackets, and what the value of count will be at every single iteration. So here we are going to run this code 10 times, and the variable count will change its value in every single iteration, starting at 1 and going up to 10, jumping one number at a time. So we will count to 10. Let's run this code. And there you can see in the console, we get the numbers from 1 and up to 10. If we now change this here to 2, what do you think will happen? Well, then we get 1, 3, 5, 7, 9. Because we still start at 1, we're going to end before 11, so maximum 10, and we're going to jump with 2. So in the first iteration, count equals to 1. It's what we said we wanted to start with. But then in the second iteration, we've told JavaScript that we want to increase by 2 every single time. So then it's 3, and then it's 5, and then it's 7, and then it's 9. And then at the last iteration, it's like, okay, now I'm going to be 11. But that doesn't work. That violates our finish condition here. So JavaScript stops the loop before that happens, and then continues on with whatever it has to do underneath the loop. So let's take this back to 1. Can you modify this one so that it counts from 1 to 20? How would you do that? Hopefully you identified that what you want to change is the finish condition and set that to less than 21. We run this. You can see in the console that we're logging out 1 to 20. Now, how would we change this if we want to count from 10 to 20? Go ahead and try that right now. Okay, hopefully you figured out that it is the starting condition you want to modify. You want to write 10 here so that it starts at 10, ends before 21, and counts 1 at a time. If we run the code, you can see we get from 10 to 20 logged out to the console. So hopefully you've gained a little bit of intuition on this now. Let's move on to the next cast. Okay, let's first walk through how to create a loop from scratch. And then I want you to create your own loop, or at least try, according to the specifications here on line 3 and 4. But to begin with, we'll create a loop that counts from 0 to 5. So to do that, we'll do for, open and close parentheses, and then inside of the parentheses, we have to define our starting point, our finish line, and how big our steps will be. This is done through a counter variable, so we could do let count equals 0, and then semicolon to end the starting statement, because 0 is where we want to start. However, whereas count is a very semantically good word for this variable, a common convention in JavaScript is to use the letter I instead. We could have named it whatever we want, and you can use count if you think that's easier, but I'm going to use I from now on. Then there's the finish line, which we also need to define. We want to count to 5, so I should be less than 6, and then semicolon again. So this defines that I should always be less than 6, and obviously then the last point where it will stop when counting upwards is 5. And then finally we have to define how big our steps should be. And I'm going to do I plus equals 1. Here we don't have to use a semicolon to end because this is the last condition. Actually, I can space it out a little bit. We follow the same structure for all of our conditions. And then the open and closed square brackets for the body of our for loop. Then inside of here, we'll do console.log I from the code. And we can see 0, 1, 2, 3, 4, 5. Good. Okay, now that you've seen this, I want you to try to create a for loop that counts from 10 up to 100 in steps of 10. So it should count 10, 20, 30, 40, 50, and so on, including 100. And I want you to use console log, as I am doing here, to log out the count at each step of the iteration. So go ahead and do this right now. Okay, hopefully that went well. If not, no worries. Let's do this together. We'll do for let, and here you might wonder if, well, we've already used the I variable. Can we reuse it down here? And the answer is yes. I is only defined inside of the curly brackets of the for loop when you do it like this. So outside of it, for example, down here at line 8, JavaScript won't remember this I variable. So whatever you've configured it to mean up here inside of the curly brackets doesn't affect whatever you set I to down here. So we can do let I again equals 10. That's where we want to start. I should be this time less than not 100, because then it'll stop at 99. It needs to be less than 101. And finally, I should not be plus equals 1. Well, it should be plus equals 10, because at each step in the iteration, you want to increase I with 10. Console log I. I'm going to comment this one out, run the code, and there we see 10, 20, 30, 40, 50, and so on, all the way up to 100. So, great job. Okay, now you're going to experience how powerful for loops are when combining them with arrays. Because let's say that we are building a chat application, like the one that LinkedIn has, which I showed you earlier. And these messages might just well be items in arrays. Let's just pretend that each of these messages are exactly that, and ignore all the metadata around the messages, like the time and the profile picture and name and stuff like that, and just pretend that we have the data structure which contains a bunch of messages inside of an array. Basically, just what we have here, the exact same array we've worked with earlier as well. Now, pretend that this is a console-based array, so everything basically need to do is log out these messages to the console. But in order to do that, we can't just console log out messages, because then we'll just get a long array, and that's not what we want. We want each of the messages on its own line and not with the square bracket and stuff like that around. So the hard way to do this is by doing like this. Messages 1, messages 2, messages 3. Like to take the index from 0 to 3 and log all of them out. There we go. Now we have what looks like a chat in the console. But this is a really bad way of doing it. We are repeating ourselves again and again, and that's a general anti-pattern. There's something called DRY for don't repeat yourself. So don't write more code than you need to, and especially not if you're just repeating the same code. And also, this doesn't scale, because if I add now at the end of the array and run the code, I'm not logging out the last one. I have to manually update my code. So what we instead want to do is combine this array with a for loop. Now let's comment out this and write for let I equals 0, semicolon. And then we want I to stop before it reaches 5. And then we want I to increment by 1 at every single iteration. Now inside of this for loop, we log the value of I. See in the console that we get from 0 to 4. And that actually resembles quite a lot what we did here. However, we've even added the index of the latest item as well. So how about we, instead of just logging out I, simply do messages, open square brackets, close square brackets, use the I as the index, and then run the code, and boom, there we go. We have all of the items logged out in order, one after another. Brilliant. However, there's still a little problem here, that if I add yet another message here, maybe an emoji, and I run the code, the emoji isn't logged to the console. Then I have to change this to 6 again. So it's still not fully like dynamic. However, I have a trick, because how can I get a hold of the number 6 in a dynamic way? Well, you might remember that arrays has a property which is called length. And that will refer to the actual length of the array. If we use that, we can be sure that our loop counts up to the final index, all the way up to the end of the array. If we now run the code, yes, there we have all of our messages, regardless of how long the messages array is. So this was a lot of typing from my end though. So let's move on to a challenge so that you get to practice this as well. Okay, so now let's return back to the example of having cards in an array, like we have in our Blackjack game. So here I've created an array that has 3 cards of the values 7, 3, and 9. And I want you to create a for loop that logs out all of these cards to the console. However, not by hard coding where the loop should stop counting, but using the cards.length property. So go ahead and do this right now, and then I will of course show you the solution as well afterwards. Okay, hopefully this went well. Let's do it. We'll do for, open and close parentheses, and then let I equal 0, because we're going to start at the 0th index. I should be less than cards dot, and I should be increased with 1 at every step in the iteration. Now, here, for this last condition, I actually want to show you another trick, because what you can do here is actually do I++. That'll do the exact same thing as this. It's just syntactical sugar that JavaScript provides us with to make our code a little bit neater. So I++ increment I with 1. So now we can do console log cards, then passing in the I, run the code, and there we can see 7, 3, and 9 printed to the console. Great job. Okay, this is so cool because now you are going to combine what you've learned about arrays and for loops with what you know about manipulating the DOM. So we're going to pull the strings together and have you render out this sentence inside of this greeting-L. So you can see we have in our HTML just an empty paragraph which has the ID of greeting-L. We have fetched that element from the HTML and stored it in this greeting-L variable. And your job is to render the sentence, that is the array here. So you are to render all of these items inside of the array in the greeting-L paragraph. And the way to do that is to use a for loop to loop through it and render each of them into the greeting-L using .text content. So a lot of stuff you have to keep track of here, but give it your best shot, and then I of course will show you the solution when you return back to this screencast. Okay, hopefully that went well. Now let's do this. We'll do for let I equals 0 because we want to start at the 0th index in our array. We'll do I is less than sentence.length. And then we do I++ because we want to increment 1 time. Here we need to grab a hold of the greeting-L and then do text content. And here you might have been tempted to do equal sentence, open and close square brackets, and passing in the index. That will just end up with rendering pair because first it renders hello, and then it clears out all of the text content and renders the second word, but then for every single time in this loop, it clears out all the text content, and we end up with just the result after the last iteration. And that was the last word in the array. So what we have to do, we have to keep the previous content intact inside of the paragraph. And as you might remember, we do that with plus equals. So running the code again, yes, now it works. Now though, I have a bonus challenge for you, which is the following. How do you keep the spaces between the words if I remove these spaces from the array? That is, if I do like this, like this, like this, and like this, and we render it out, you can say, we have no more spaces. It looks like one long weird word. How can we, on this line 7, modify it so that we get spaces between the words? Go ahead and try that. Okay, what we will do is we'll simply, at the end here, add a plus and concatenate our given item in the array with a space. So now we add a space after each of the words. If we render this, you can see, yes, we get now the sentence exactly how we want it. Great job. Let's move on. Okay, back at our Blackjack game, it's time for you to create a for loop that renders out all the cards in the cards array instead of just the two first ones, which we are doing up here. So you are going to start your for loop down here at line 19. And I'm going to help you out a little bit because we are going to keep this first setting of the text content here so that we have the default text inside of the paragraph. And then you are going to render out the cards after this text inside of the paragraph. Go ahead and create that for loop so that our Blackjack game supports any number of cards inside of the cards array and will render all of them out regardless of how many it is. So give it your best shot and return back to me when you want to see my solution. Okay, hopefully that went well. If not, no worries, we'll do it together. We'll start with for and then open and close parentheses, of course. Inside of the parentheses, we need to define that we want to start our incrementer at 0 and we want to stop it before it reaches the length of the cards array. How do we do that? Well, by I is less than cards.length. And then a semicolon. And we want to increment I at every iteration. The body of the for loop with curly brackets. Here we are going to plus equal onto this paragraph. So we'll do cards.l.text content plus equals. Let's start by just adding the cards and then passing in the current value of I, our iterator, which will start at 0 and to begin with end before 2. So it'll be 0, 1 and then run the code, start game, and yes, it works. However, it looks like it says 104 here because we haven't added a space between our numbers. So the way to do that is simply by concatenating a space after pin-card. Now if we run it, start game, yes, we've got it. And if we hit newCard, now we can see both the sum and the cards are now correct according to the state of our game. Great job. Let's move on. Okay, so our Blackjack game is actually turning out pretty good now. You can start the game, you can hit a new card, 20, I can even hit yet another card, boom, I'm out of the game. It's almost fun to play, though you'll get pretty tired of it as you play it multiple times since you every single time get the exact same cards. So not exactly an exciting Blackjack game. And of course that is because we have hard-coded the variables for our first card and second card here, and also hard-coded the value for our third and fourth and every preceding card here on line 40. So we'll always get 10, 4, 6, 6, 6, 6, 6, 6, and so forth. So what we need to do is instead create a function, getRandomCard, that returns a random number. So that we, instead of hard-coding the number 10 up here on line 1, we can do getRandomCard and call that function. This function will then return a random card that the first card variable will be set to. And we can do the same with the second card, and also down here in the newCard function, we can do getRandomCard there as well. This way, we'd get a functional Blackjack game. However, there's a few things you haven't learned yet, which you need to learn in order to create this getRandomCard function. So let's rewind a little bit here, get back to the hard-coded numbers, and over the next few casts, you're going to learn how to return values in functions and also how to generate random numbers inside of a function. So let's go ahead and do exactly that. Okay, let's return back to our racing game example in order to learn about returning values in functions. So here we have two players who've raced through the game, and player 1 got the time 102 and player 2 got the time 107. And our job is to create a function that returns the fastest race time. So in order to do that, we first have to do function. And I'm going to call this getFastestRaceTime. Quite a long word, but at least it's descriptive. And inside of the body of the function, we have to first check which of these times were fastest. So we'll do an if statement and say, if player 1 time is less than player 2 time, well then we are going to return player 1 time. Because if it's less than player 2, then it's the fastest race time, and we are going to return it. Now, this return keyword here might now seem a bit weird, and you probably don't understand yet what it means, but don't worry about that right now. It'll be clearer as we move on. And then we're going to do else if. The next condition is if player 2 was faster than player 1, that is player 2 time, is less than player 1 time. If so, we are going to return player 2 time, like that. Then an else if actually these two are equal, so none of these expressions evaluate to true. Well, then the fastest time is any player's time because they have the exact same time. Could either return player 1 time or player 2 time, it doesn't matter. I'm just going to return player 1 time. Okay, now what we can do is we can do let fastest race. I'm going to call this variable that. And now I'm going to define that, declare that variable as the result of invoking this function. So I'm going to do get fastest race time, like that. Now the value of fastest race time will be whatever this function has returned. And if we console log fastest race time, we can see we get 102. That's correct because this function compared player 1 and player 2 and rightfully recognized that player 1 was faster than player 2 and thus returned player 1 time. What you might think now is, well, we're just console logging out the value here. What's the point? Why couldn't we just, instead of these returns, just do console.log and do that directly inside of the function? Do that first and run it. You can see, yes, we are now indeed running this line 6 here. We're console logging out the value. But if we down here try to see what is the value of fastest race at this point and run the code, you can see that we're getting 102 first from this line, but then we're getting undefined from line 16 because now the fastest race variable simply isn't defined because this function didn't return anything. And it's actually quite valuable to have stored the fastest race time inside of this value as opposed to just having console logged it out up here. Because now we can use this variable for something else. So let's do it like this and return instead and move over and remove the parentheses as well. You're wondering how I got the cursor to be on multiple lines at the same time? It's a trick where you first select a word and then do Command D. Or if you're not on a Mac, Control plus D. Select the word, Command D 1, 2 times, and now I've selected all of the return keywords so that I can delete them or retype them. That was just a quick little tip. Now it's time for a challenge. So you are going to write a function that returns the total race time. Then you are going to call or invoke the function and then store the returned value in a new variable. You have to decide for yourself what you want to call that variable and what you're going to call this function. Then finally, you are going to log your variable out just to check that everything has worked. So go ahead and do this right now. Okay, hopefully this went well. Let's do this. I'll do function get total race time. And the way to do that is simply to return player 1 time plus player 2 time. Then we can create a new variable called let total time equals get total race time. And now we can console log total time, doing like that, running the code, and indeed we get 209 in the console, which sounds just about right. So great job, let's move on. Okay, it's time to take what you've learned about returning values and functions and implement that technique into our app. This is a 3-part challenge. First, you're going to create a function, getRandomCard, that always returns the number 5. And then you're going to use getRandomCard to set the values of the first card and the second card, and then use it to set the value of the card variable down here in the newCard function as well. So you are going to write your function, getRandomCard, here, starting on line 14. And now you might think, well, that doesn't make sense because we have previously learned that if you define a variable down here on line 14, we can't use it up on line 2 and 3. That's at least how it is with variables you define using the let keyword. And that is exactly right. But when you create functions in the way we do, there's an exception. So I want you to just try this and see if it works. And then I'm going to explain afterwards why it works. Go ahead and give this your best shot, and then I will show you the solution as well afterwards. Okay, hopefully that went well. Now let's do this. We'll do function getRandomCard like that. Then inside of the body of the function, we'll simply return 5. We need to use this up here at line 2, getRandomCard, and on line 3, getRandomCard. So what's happening here is that we're calling this function. It will return 5, and thus secondCard and firstCard will be initialized with the value 5. As will our card down here. If we do getRandomCard and call it, these two really important, otherwise it won't work. But with them, card will now have the value 5. So let's run our Blackjack game. Start the game. Ooh, we got 2 5s. Ah, yet another 5. What's the chance? Obviously, it is 100% at the moment, but that doesn't matter because we now have the setup for inside of this function, writing the logic for getting an actual random card back. So that's great. Finally, I promised to talk a little bit about the fact that we're creating the function down here on line 14 and then using it up on line 2. That seems to go against what we learned about variables early on. However, when you write functions like this, which is called function declarations, the function gets so-called hoisted to the top, meaning that it's accessible even at line 1, regardless of how far down you define the function. We could have written this function on line 10,000. It would still be accessible on line 1. Now, there are other ways of creating functions that don't give the function this extra benefit, but as for now, we're only going to write functions in this way, so don't worry about that. Because now you have another thing to worry about, and that is how do we actually modify this getRandom function so that it actually returns a random card? So from the next lesson on, we are going to dive into exactly how to do that. I'll see you there. So I remember when I was learning this slightly clunky way of generating random numbers in JavaScript and thinking, well, why do I really need to generate random numbers? Is that really such a common thing to do for developers? And actually, it is. Of course, there's our use case where we're building a card game. Obviously, we need to have some kind of randomness in which card you get. Otherwise, it would be meaningless. But also, imagine all games that use dices. A dice is basically a physical randomness function that gives you a random number between 1 and 6. But randomness isn't only important in these kind of casino-ish games. I would say in all computer games, randomness plays some kind of role. For example, in this popular iPhone game Crossy Road, where you are to cross a road as a duck without getting hit by a car. Surely there's some randomness underneath here, which decides which cars appear on the road and also when they appear. But it doesn't stop there with games. Actually, in cybersecurity, random numbers is a key component in order to authenticate yourself and generate keys, as within cryptocurrencies. So for example, Bitcoin uses random numbers as well. So random numbers plays a role in the crypto economy as well. And most importantly, we used random numbers in order to generate the suggested tweet text in our JavaScriptmas advent calendar. So, as you can understand, random numbers are everywhere, and you need to learn the most basic way of generating that in JavaScript. And that is through something that we call the math object. That's something that's already provided to you in JavaScript, or by the browser to be specific. And you can type math wherever you want with a capital M, and then do .random, and then open and close parentheses so that you call this function or method. And don't worry if you don't quite understand what's going on under the hood here. You're not meant to do that right now. All you're meant to know is that that will return a number to you, which I've now stored in a variable called random number, and then I'm logging out this random number. What I want you to do now is pause this screencast and run this code a few times so that you get to see a few of the values that our random number variable can take, and then try to, as succinctly and specifically as possible, write your answer at what you think Math.random does. So what does it return? Try to formulate that and write it down, and then return back to the screencast when you think you have the answer. So the way I would write this is that it generates a random number between 0 and 1, and then parentheses, not inclusive of 1. So it generates a random number, including 0 and 1, but not including 1. So from 0.000000 to 0.9999999 and a bunch of 9s after that. So if we were to visualize this slightly, say that Math.random gives you a number from 0.000 and a bunch of zeros after that. I just couldn't bother writing all of them, to 0.9999999, basically a bunch of 9s as well. That is the range you are given when you give JavaScript this command. So if we run this, we can see we get 0.68 and a bunch of numbers, 0.95 and a bunch of numbers, 0.88, 0.001. Yeah, as you can see, we've already been almost from very close to 0 to very close to 1. Now, before we go, there's one thing I need to point out, which is that the randomness here, while it looks completely random for us humans, it's not truly random. There is some deterministic variables going on under the hood here. And it's actually a really hard problem in computer science to generate truly random numbers. But for our use cases, we're not going to worry about that. As far as we care, these numbers that we generate with Math.random are more than random enough for our use case. This is not a PhD in cybersecurity, but rather getting you started with web development. So with that, let's move on. Okay, so now we know how to create a random number between 0 and up to, but not including 1. However, it's not entirely clear how we utilize Math.random in order to create something useful, like for example, a dice function. So let's take this one step at a time towards creating such a function. And the first step we're going to take is simply by multiplying Math.random with 6. Now I want you to do the same thing that you did previously, which is to pause the screencast, run this code a few times and see what we log to the console, and then answer the following question. In which range will our random number be now? So from which number to which other number? It used to be from 0 to 0.99999. Now it's something else, and you have to figure that out. So go ahead and do that right now. Okay, the answer is that it still starts at 0, but now goes all the way up to 5.99999 and a bunch of 9s. I'm not going to type all of them. So if Math.random gave us a number from 0 to 0.999, Math.random times 6 will give us a number from 0, because 0 times 6 is still 0, to 5.999, because 0 point a bunch of 9s times 6 is not entirely 6, but it's almost 6. So it's 5 point a bunch of 9s. So now we have kind of expanded our range, roughly speaking, from being between 0 and 1 to being between 0 and 6. We did that by multiplying it with 6. Let's move on to the next step. Okay, so now we need to learn another method on the math object, and that is Math.floor. What floor does is it takes some input, a number, and then does something with that number and returns it so that you can store that in a new variable. For example, like floored number right here. That is the floored version of this number. So I want you to pause the screencast, run this code a few times, and answer the question, what does Math.floor do to positive numbers? And the reason I'm saying positive numbers is I don't want you to add negative numbers in here, because the mental model is slightly easier if you only think about positive numbers, and it's a bit easier to write a concise answer to it, in my opinion. And finally, I've never used Math.floor on negative numbers anyway. It's usually used on positive numbers. So try this. Feel free to add a few different numbers in here and run the code. And once you're ready, just type out your personal explanation of what you think Math.floor does. Go ahead and do this right now. Now, the way I think of Math.floor is that it simply removes the decimals. Because if we run this, you can see it returns 3. If we have 12.4, 12. Even 12.9999999, still 12. Okay, so great job. With that knowledge in mind, let's move on to the next lesson. Okay, so just as a quick recap, Math.random gave us a number between 0 and almost 1, and Math.random times 6 then gave us a number between 0 and almost 6. And now we are going to combine this with Math.floor, which you learned in the previous lesson. So I'm going to add it here. I'm going to write Math.floor and then wrap our entire previous expression inside the parentheses of Math.floor. Now, what I want you to do is run this code a few times and then write down possible values that random number now can hold. So there's a limited number of them, and your job is to figure out exactly which ones. So go ahead and do this right now. Okay, hopefully that went well. Now let's run this together. You can see we got 4, 4, 0, 1, 4, 0, 2, 5. Okay. So it seems we are getting the numbers between 0 and 5. That actually makes a lot of sense, because if we take this range here between 0 and almost 6 and shove it into the Math.floor function, then it will basically remove all of the decimals. And if we remove the decimals from this entire range, which numbers are we then left with? That's just the whole numbers from 0 all the way up to 5. So the right answer was 0, 1, 2, 3, 4, 5, like that. Okay, hopefully you're still hanging on. Let's move on to the final step of our dice function. Okay, now we are going to complete our dice feature, because we know that with this expression, we currently get a whole number from 0 up to 5. So the question then remains, how do we turn this range into rather a range between 1 and 6, which is essentially the same as a dice. And I want you to try this for yourself. Try to modify the expression so that we get a range from 1 to 6 instead of 0 to 5. Go ahead and give that a shot right now. Okay, hopefully that went well. To understand what we need to do, we can compare each of the numbers here. You can see that the first number here is 1 and the first number there is 0. And how do we go from 0 to 1? Well, we add 1. And the same goes for all of the numbers here. How do we go from 1 to 2? Well, we add 1. And from 5 to 6, we add 1. So basically, what we can do is just do plus 1 at the very end. Then if we run the code, you see we get 2, we get 6, 3, 5, 6, 2, 1. Yes, we indeed get the entire range of a dice. So, really good job reaching this far. Now I only have one last challenge for you, and that is to create a function called rollDice that returns a random number between 1 and 6. So basically, you're going to take what we've done here and wrap it into a function and then return the result. Go ahead and do that. Okay, to do this, I'll do function rollDice, open and close parentheses, open and close brackets, and inside of here, I'm just going to copy this line, paste it in, and then return random number, like that. Now I have to remove it from up here, because out here on line 2, random number isn't even defined, so we can't log it out. Random number is now only defined inside of the rollDice function, and the value of it gets returned. So if we console.log, and inside of the parentheses we call the rollDice function like that, to get, yes, a random number between 1 and 6. Really good job reaching this far. This was complicated stuff, so if you feel a little bit shaky with this, that's totally okay. You can go back and rewatch it and retry all of the challenges if you want to. And then when you feel ready, we'll move on and use this knowledge to make our Blackjack game much better. Okay, we're back at our Blackjack game, and we are going to fix up this getRandomCard function. But we'll do it step by step. So to begin with, I want you to make it return a random number between 1 and 13. So here you can pretend that we are working with the regular values that a deck of cards usually has. So with the ace being the 1, the numbers from 2 to 10 of course being their respective numbers, and then the jack being 11, queen being 12, and king being 13. So from 1 to 13, like this. Go ahead and give this your best shot, and then of course I will show you how to do it afterwards as well. Okay, now let's do this. We know that if we do Math.random, we are going to generate a number between 0.000 and a bunch of decimals after that, up until 0.999 and a bunch of 9s after that as well. So the first thing we need to do in order to get this range to look more like this one is to multiply this entire thing with 13. 0.000 times 13 is still 0.000 is still 0, and 0.999 times 13 is actually just 12.999, or we have a bunch of 9s after that as well, so we're getting to something remotely similar. It's just a matter of how many 9s we have after the dot. But this is roughly the range we're working with this expression right here. So we want to remove the decimals. And how do we do that? Well, if you remember from previously, we can use the Math.floor function and wrap the entire thing inside of the parentheses of Math.floor. So now we take this expression here, this one, and we then floor it, which gives you like that and like that. So 0 to 12, that's what we're returning here. Now the question remains, how do we go from 0 to 12 to 1 to 13? Well, that's only a matter of adding a 1 to any given number. Just do like that. And that should return a number between 1 and 13. Let's try to start this game and pull a bunch of cards to see if we actually get the entire range. 7, 4, looking good so far. 10, okay. 13, yes. 5, a bunch of other numbers. Getting way too many numbers here. Let's get that 1. Yes, there we got it. A 1. So we have the entire range from 13 to 1 and just about everything in between. This was not a normal blackjack round, but at least proved the point that this generates random number between 1 and 13. So, great job reaching this far, but of course we have to modify it because in Blackjack we're not following the usual value sequence for cards. So we need to modify our function a little bit, but we'll do that in the next cast. Now we need to change our getRandomCard function because in Blackjack, the Jack, Queen, and King are all worth 10 and the Ace is worth 11. Or strictly speaking, the Ace can be worth both 1 and 11. You get to choose as a player what suits you best is the value you use. However, for the sake of simplicity, we are just going to treat the Ace as 11 in our case, as having a dual value for this card would add a lot of complexity to our game, and it's not something I want to focus on. It's rather something you can, for example, do as a stretch goal later if you want to modify the game at the end of this course. So for now, we're going to treat our Ace as 11. So this means we need to modify our getRandomCard function. If the number it returns is 1, then we should change it to 11. And likewise, if the number it returns is either 11, 12, or 13, we should rather return 10. So go ahead and modify this function so that these exceptions are followed. You're going to have to define a variable that this random number is stored in and also have some kind of conditional that checks for these conditions and returns the appropriate value. So go ahead and give this a shot, and then I will of course show you the solution afterwards as well. Okay, hopefully that went well. If not, no worries, we'll do it together. First, I'm going to, instead of returning this directly, turn it into our random number. Like that. Then we need to write our conditional to account for these special cases. I'm going to start from the very top and check if random number is more than 10, meaning that card is either the Jack, Queen, or the King. So if random number is more than 10, what are we going to return then? Well, then we are going to return 10, because that is the value of the Jack, Queen, and King. Then I'm going to do else if, and now I'm going to count for the Ace itself, and for that I'm going to use the triple equals. So I'll do random number triple equals 1, and I'm going to return 11. And then in all other cases, you can just do else like that. In all other cases, it must mean that we have drawn either a 2, 3, 4, 5, 6, 7, 8, 9, or 10. And if so, we're just going to return that value. So then we're just going to return the random number directly like that. Let's run the code. Start game. Okay, 5, 5. I'm going to just hit a bunch of cards to see that we get the entire range, and indeed it seems that we does. We have a 2 here, we have an 11 here, and we have almost every single word in between. I'm 100% sure that if we continue hitting the newCard, in the long run, we'll just get random numbers across our entire defined range. So, great job. We're almost reaching the end of our Blackjack game. You should really be proud of yourselves for reaching this far. This is starting to get advanced. There's even more to learn, so let's just keep up the pace and move on. Okay, there's one really weird thing with our Blackjack game, and that's easily exposed if we console log out the cards here at line 12, and then refresh the page. There you can see I got 2 and 7, and the reason that's weird is because I haven't even clicked the start game button. I kind of just entered the casino, and the casino has already decided what cards I am to be dealt. That's fishy. We don't want that. I want the cards to be generated as I click on the start game button. So the first card and the second card should be generated inside of the start game function. And thus, the cards and the sum also needs to be reassigned inside of the start game function. And also, the isAlive shouldn't be set to true by default. Before I've even clicked the start game button, I'm not alive. I'm not even playing the game. I'm going to use that as an example. Set it to false first. Then inside of the start game function, I'm going to do isAlive equals true. So now we have the correct starting state before I've entered the game up here on line 6. And the correct value once I've started the game down on line 26. So what I want you to do is make it so that the same thing happens with cards array, because it should not be set here, and the first and second card shouldn't even be defined up here, and the sum should be 0 by default. So this is how the state of the game is before I've started playing the game. Now, what you need to do down here at line 23 and 24 is generate the 2 random numbers, then reassign the cards and the sum variables so that the game can start. So you might find this a bit tricky, but do your best. There's no shame in trying and failing, because I will of course also show you how to do it when you return back to this cast. Good luck. Okay, let's do this. We'll start by defining first card and second card, and they should be defined by running the getRandomCard function. That'll give them the getRandomCard function. Second card equals random card as well. Now we can set the cards array to first card and second card, and the sum to first card plus second card, like that. And also actually get this console log back in again and rerun the browser. You can see now it's empty. The casino hasn't decided which cards I am to get. Very good. So hit start game, and there I got my Blackjack. Oh my god, that's amazing. And with that, I have nothing more to say. I'll see you in the next cast. The next thing I want to fix is our new card button, because it's kind of broken. Let's see why. If I now start the game and I get 2 cards and I draw a third card and a fourth card, and I'm out of the game. At this point, I shouldn't be able to draw more cards, but actually I am. I can hit it, and I got another 10, so I'm at 34. Shouldn't be possible to get to that number in Blackjack. So we need to stop it when the game is over, and also, if we refresh the browser, I shouldn't be able to start with just 1 card either, but I actually can. So there's 2 conditions we need to check, both if I'm still in the game, basically if the isAlive is true, and also I can't have Blackjack either. Now this requires us to learn something called logical operators, which lets you combine multiple conditions inside of an if statement, so that a piece of code should only be run if multiple conditions are satisfied. So let's take a little detour and learn about logical operators in the next casts. Okay, let's learn about logical operators. Here we have a little bit of boilerplate code, namely 2 variables and a function, and the imagined scenario here is a course platform, much like Scrimba. And what we're trying to solve is to figure out whether or not user should get a certificate. That is, whether or not we should call this getCertificate function. Because the deal is, we only want to call this function if 2 conditions are true. And that is, has completed course. In other words, the user has completed 100% of the course. And secondly, gives certificate. That is, whether or not this is the type of course that makes the user eligible for a certificate. Because you can imagine that very short courses doesn't give you a certificate. The course has to be of a certain size to award you with a certificate. So what we need to do is figure out how we can check if both of these conditions are true, because then and only then do we want to call this generate certificate function. You could actually achieve this with the concepts you've learned so far by simply nesting if statements. For example, you could do if has completed course equals to true, and then add the body of the if statement, and then inside of the body you could nest another if statement. If gives certificate equals true, and then you get two ifs inside of each other, and then inside of the inner if you do generate certificate. Now if we run this code, you can see yes, we are indeed generating the certificate, and if we flip one of them to false, we are not generating the certificate, because here this condition was not fulfilled. So neither of the code lines inside of the body was run. JavaScript just jumped over the entire if statement. However, this is a very clunky way of doing it. Better way would be to actually remove the inner if statement. For now, let's just comment it out. And then inside of the parentheses here, we can add another condition by writing a double ampersand and then the next condition gives certificate equals true. We now move this line, and uncomment this one. Run this code. We see nothing happens because this condition here is false. And with the AND operator, both of the expressions before and after the operator need to evaluate to true for this entire expression to evaluate to true. So if we flip this to true, and run this, now it works. But it's much better to have it on one line. And a little extra thing we can do is actually omit these triple equals true, because now what does this and this evaluate to? Well, it's simply true and true. And true equals, well, true. But as for now, in order to be explicit about the condition we are checking for, I actually want to keep these triple equals here as well. So one way to read this in plain English is if this is true and this is true, then run this code. Hopefully that makes sense, because in the next cast I'm going to give you a challenge so that you get your hands dirty with this as well. Okay, let's continue on with our course platform example. So in this challenge, you are to imagine that you are writing the code that is to be run after the student has struggled with the challenge for a little while, or maybe the student has clicked a button and signaled to the platform that she is stuck. And we first want to check, has the student solved the challenge she's trying to solve? And has the student any hints left? Because if the student has any hints left, she can go and open those hints. But if she's used all of our hints and she hasn't solved the challenge yet, then we are to run this show solution function and just show her the solution. Obviously, it just logs out a string, but you can imagine that it would show the solution. So your job is to create an if statement that checks that both variables are false. I mean, these two variables. And then if so, run the show solution function. Go ahead and give this a shot, and then I will, of course, show you the solution when you return back to this screencast. Okay, the way to solve this is almost similar to what we did in the previous cast. We'll do if, and then open and close parentheses. And here we need to use a logical AND operator, because we're going to check if both has solved the challenge, triple equals false, and the double ampersand has hints left is also false. Then, if the user hasn't solved the challenge and has no hints left, it's time to give her some slack and show this solution. So then we'll trigger show solution like that. Let's run the code. And indeed, this triggers the code because both of them are false. If we try to flip one to true, then the code is not triggered. We're not logging anything to the console, meaning that our logical operator that governs our if statement actually works. Great job. So now that you've learned the AND operator, let's take a look at its close relative, the OR operator. What does that do? Well, it allows you to check if either this condition is true or this condition is true. And if so, the body of the if statement will be executed. So if you're in a situation where we only need one of two cases to be valid, well then you want to use the OR operator. As for this example, it doesn't really make sense. It will now run since actually both of these are true. But if the give certificate is false, it will also run. But that doesn't make any sense because if the course doesn't give any certificates at all, you're not supposed to generate any certificates regardless of the user having completed the course. So let's use another example instead. Imagine here that you're building Netflix and you've just launched this amazing new documentary, the Fire Festival. I don't know if you've seen this, but it's truly amazing, about a guy who creates a festival that aims to be the celebrity hotshot festival of the world, but just becomes a disaster. It's really good. After this has been launched, you probably want to recommend it to a ton of your users. And what you want to do is you want to check if the user likes documentaries or if the user likes startups. They don't have to like both, but if they like one of these themes, then most likely they will enjoy the Fire Festival documentary. So I want you now to try to use the OR statement, that is the two lines you can see here. You can copy them if you want, if you don't know how to get them from your keyboard. And you're going to use this to call recommend movie if either of the variables, that is the likes documentary or like startups, are true. I'm pushing you out on thin ice here. I haven't written a complete OR statement for you, but it works in just the same way as the AND statement, so I think you can do it if you just give it a shot. And if you don't, no worries, I will show you the solution afterwards as well. Okay, let's do this. We'll do let likes documentaries, set that to true, and we'll do let likes startups, set that to false, for example. And if likes documentaries, if that is true, or if likes startups is true, well, then we want to recommend this movie, like that. Running the code, we can see we are recommending the movie, even though this one is false. Flipping both of them to false. Now, if I run the code, nothing happens because at least one of them needs to be true, this or this. And if we make both true and run the code, then of course, if both are true, then one or the other is also true. So that would satisfy the condition. Great job doing this challenge. Let's keep up the pace and move on. Now you are going to take what you've learned about the logical AND operator and modify this newCard function so that you only allow the player to get a new card if she is alive and does not have Blackjack. So those are the two conditions that need to be filled for you to actually run this code. So give this a shot, and I will of course show you the solution afterwards as well. Okay, so the way to do this is if, open and close parentheses, and then I'm going to actually just open the body of the conditional and paste in this code. And when are we going to run this code? Well, she has to be alive. I'm going to do isAlive, and then if that equals to true, that's the first condition. And the second condition, which we also want to be true since we're using this logical AND operator, should be that the hasBlackJack should equal to false, like that. If isAlive is true and hasBlackJack is false, then the dealer should be willing to give the player a new card. So let's try this. We'll start the game. 15, new card. 25, you're out of the game. Let's try to ask the dealer if we can please get one more card. Oh, nothing happens. It works. Brilliant. Really good job doing this challenge. Okay, so our blackjack game is almost complete. There's just a tiny little feature I would like to add as well. Because if you've ever played online blackjack or poker, what you normally see is your own name and your credits or your chips somewhere on the screen. So what I mean by that is something along the lines of this. Like that. So you see your name and how many credits you have, or chips, or whatever. And this is nice because then it's possible to later implement the concept of winning, of increasing your chips, and of losing as you are betting or playing rounds. These are critical components of any blackjack game. However, I wouldn't want to hard-code it in the HTML like this. We of course want to represent this data in our JavaScript, as that gives us the ability to change it. Now I'm going to just show you how we could do this to begin with, by first giving this an ID of player-L and removing the contents of it. And then in the JavaScript, we could do let player name equals pair and let player chips equals 145, for example. And then we could grab the element player L equals document.get element by ID, passing in the ID we just created. And then do the playerl.text content, which you know by now. Your name, colon, and a space, and then a $sign, and then plus the player chips, like that. If we now run this, you can see, yes, that we render it in the exact same way. However, now we've come into a situation where two values that are inherently connected together, like the player and his chips, which currently live in two different variables. What would make more sense in this situation would be to somehow combine this into a single unity. And that is where so-called objects come into play. That is another data type which resembles arrays a little bit, but they are also different in some fundamental ways. But they are kind of also buckets where you store data. So in our case, we would perhaps want to create a player object in which we can store both the player's name and the chips. So I'm going to show you how to do this. You might feel a little bit confused as you see it, but over the next few casts, you're going to practice objects yourself. So what I'll do, I'll write let player equals open and closed curly brackets. You've seen these before. They're used often in JavaScript. But when you see them in a context like this, after the assignment operator, they mean that we are creating an object. And inside of here, what I essentially want to do is add this data right here. However, you can see that something is wrong here with all these red lines. And that's because the syntax for creating items inside of our object is different from how we define variables. First of all, we don't use the let keyword in front of the names. And secondly, we replace the assignment with a colon. And thirdly, just as we have in arrays, we separate the items with commas, but we don't do that on the last item. Finally, here it would make sense to omit the player, as we've already used that name as the name of the entire object. So we can just rather do name, and I'm not going to capitalize it, and chips, like that. Now we have taken our two variables and grouped them together in this little bucket, which we are calling player. And the way we now can refer to these values, pair and 145, is by using the object name, player, and then the given key. And that is the name, because this is called a key, and its value. So name is the key, and pair is the value. Also, chips is a key, and 145 is a value. So to replace player chips with a reference to the chips inside of the player object, we'll instead do player.chips. If I run this code, you can see we get the exact same result. You're probably a little bit confused now, so don't worry if you think this was hard. Over the next few casts, you are going to practice objects for yourself so that this becomes second nature to you. Let's move on. One way to think of objects is that they give you the ability to store data in depth. And with that in mind, we'll know that objects are so-called complex data types, or also called composite data types, because we use numbers, strings, booleans, even arrays in order to compose objects. So they often store quite a lot of data. And they can even store objects within objects. That kind of nested data structure is not something you're going to think about now. For now, just think of it as key value pairs. And let's look this through the lens of a real-world example. That's always easier. So here on Scrimba, we represent our courses as objects. Because here you can see the CSS Grid course, actually the very first course we launched back in the days, and it has a bunch of different data. For example, it has the title, the number of lessons, and the creator of the course, the length of the course, and the level of it. So let's actually translate this course into JavaScript, into how the data structure actually looks. So do let course equals open and closed curly brackets. Start with the title, like that, title, colon, learn CSS Grid for free. Now we have one key value pair. Title is the key, and the string here is the value. Then the lessons, that is natural to represent as a number, so it was 16 lessons. The creator, which again is a string, that. And then we have the length, which, while it says 1 hour here, that's actually not how we represent that data in our database and thus in this object. Break it down into minutes. So perhaps this course is actually 63 minutes, but as for the user interface, we don't go into detail that much. We round it to the closest hour. And finally, there's the level, and here it says intermediate. But that's also one of those cases where the data in the user interface differs slightly from the data in the database. So our levels are represented from 0 to 3, where 0 is for complete noobs and 3 are the advanced courses. So the intermediate course, you can see here, we type out intermediate here if this value is set to 2. Now, you don't have to worry about how our design and what we say to the user differs from the underlying data. It's just something I wanted to give you a little heads up about because it's very normal in real-world code bases. Now, it looks like we're kind of done here, but we're actually not, because there's a lot more data for a course actually than what's represented here. For example, whether or not it's free or paid, that's a boolean, so it's either true or false, like that. It's free, true, and this course is indeed free. And we also have tags for courses. And that's an array, because we want to have the ability to add multiple tags to one course. So we need a complex data type here as well as the value of this tags key. So for example, this CSS Grid course has the tags HTML and CSS. So this is a very real-world example of an object. Now, if we want to access any of these values here, for example, the length, we do that through something we call the dot notation. Course dot length, like that. Console log out this and run the code. You can see that we log out 63. So course dot length gives us back 63. And you've used this dot notation quite a lot actually, up until now. And even though you probably haven't been aware of it, you have been using objects all along. Like, what are we doing here? Console.log. What kind of data type do you think the console is? Well, it's an object. And just to give you one more example, let's say we want to log out this array here. Well, then we simply do course.tags on the code. And when we open the console, we can see that we are logging out an array, because this entire array is the value that we get back when we ask for the tags. Now, one thing I want to point out before we move on, that you can replace this dot with an open square bracket and then add a closing square bracket and then turn the key name into a string. This is called bracket notation. If we run the code, we get the exact same thing back. Now, there are reasons for why you sometimes want to use bracket notation, but we're not going to get into that right now, because in the foreseeable future, you are not going to end up in a situation where you have to do that. So I'm just going to tell you now to use the dot notation. It's simpler, it's shorter, less code to read, less code to write. It's very understandable, and it's actually what most developers prefer to use if they get to choose. So now I've been talking for far too long. I want you to write code, of course. This is Scrimba. That's what we're all about. So in the next cast, you are going to write your own object. I'll see you. One thing I like to do if I'm bored is to search for epic places to live on Airbnb. For example, castles, like this wish list I came across right here, which contains a bunch of more or less affordable castles to rent across Europe. So for example, this really neat looking castle right here only costs $190. I mean, that's what people pay for like 10 square meters in a hotel room in central London. So pretty cool that you can rent a castle for that same price. But anyway, the point being, that these listings here on Airbnb most likely take advantage of the object data structure in order to store all of the data that they need to present to the user. So this can also be a great exercise for you so that we can build up that object muscle memory of yours. So I want you to basically create an object that represents an Airbnb castle listing. It should contain at least one boolean, one string, one number, and one array. It can contain a bunch more if you want to go above and beyond. However, that's the minimum requirement. And at the end, I want you to log out at least 2 of the keys using the dot notation. So go ahead and do this right now. Okay, hopefully that went well. Let's do this together. I'll do let castle equals, open and close brackets. We can use the title. Live like a king in my castle, like that. As for the number, I think the price, it's very natural to use. Price, $190. And what about the boolean? Which components here naturally lend themselves well to be using a boolean data type under the hood? Well, I think the fact that 2 of these are superhosts and the third is not points to this being a suitable piece of data for the boolean data type. Because you're either a superhost or you're not. So is superhost, and this one happened to be true. And then finally there's the array. What kind of data here would it make sense to place inside of an array? Well, it could be that these kind of bullet points here are arrays that are pulled out of the underlying data and are kind of the featured selling points that Airbnb wants to list out. Or actually you can see that there's multiple images here if you see this carousel indicator. So the images is very natural to have inside of an array. And also the reviews, that's definitely a list of many items. So it doesn't matter what you choose, or if you choose something completely different. The point is just that I wanted you to write an array inside of an object. So I'm going to choose images like that, make that an array, and here we probably have URLs to the specific images. So it might be img/castle1.png, img/castle2.png, and so on and so on. And I won't bother writing anymore. Now let's log out 2 of these using the dot notation. Console log castle.price, console log castle.isSuperhost. We'll run this, and indeed we print out 190 and true to the console, meaning we have completed the great job solving this one. Let's move on. Okay, welcome back. Now it's your time to render out the player's name and his or her chips on the page. So it's a 4-part challenge. First, you are to create a paragraph with an ID of player L. Then you are to move over to the JavaScript and create the player object here at the very top. And you are to give it 2 keys, name and chips. Then you are to move down to where you are grabbing elements from the DOM, and then grab hold of the player L paragraph and store it in a variable called player L. Then you are to render the player's name and chips inside of player L. So, pretty big challenge, but you've seen me do it before and you've practiced how to work with objects, so I think you're going to nail this one. Give it your best shot and then I will show you how to do it as well afterwards. Okay, hopefully that went well. If not, no worries, let's do it together. First, we'll do a paragraph here, and we'll give it the ID of player-L, like that. Nothing happens because it's empty. Moving over to the JavaScript, we are to create the player object. Let player equals, open and close curly brackets. We are to define its name. In my case, pair. Use a comma to separate the items, and then chips. Let's say I have $200 in chips right now. 3, grab a hold of the player L paragraph and store it in a variable called player L. Okay, we know how to do that. Let player L equals document.getElement by ID, passing in the player-L, which is what we created right here. At this point, let's console log out player L. And indeed, we are fetching it from the DOM. Finally, we are to render the player's name and chips inside of player L. We know how to do that as well. Player L.textContent. equals, and here we have to concatenate the string and dig into the object to find the correct values. So we'll start with the player.name plus, we're going to have a colon and a space and then the $sign in front of the chips, and then do plus again, player.chips. Now, this is all set up. Let's run the project, and there we go. We have rendered a great job solving this challenge. Now that you've learned about objects, I want to tell you about a specific coding pattern that we've actually been using quite a lot here, but that we aren't going to implement from scratch ourselves in this module. But since we still are exposed to it, I want you to understand what's going on under the hood. And that pattern is to create functions inside of objects, something which we also call methods. Because let's say that, for example, we create another key here, which is, say, hello, and then a colon. And then as the value, we'll actually write a function like this. We won't give it a name. It'll just be an anonymous function. And inside, we'll console log JSON. That's howdy in Norwegian. And now if we want to invoke this function, we'll do player.sayHello and then open and close parentheses. If we run the code now, you can see that indeed we are logging JSON to the console. And now the reason I wanted to show this to you is because don't you think this syntax looks a little bit familiar? Like first a variable, then a dot, and then a function that you are calling with the parentheses at the end. Because actually, that's the exact same thing we're doing here when we're saying document dot get element by ID and the parentheses. And here we're also passing in a value, but it's essentially the same thing. And also here down at Math.random, also the same thing. Math is an object and random is a function on that object, also called a method. And even our good old friend console.log is the exact same thing. Object with a method. So this is not something we are going to implement ourselves in this module, but I just wanted you to be aware of that, so that when I speak about methods, you know that they are simply functions that are attached to objects. So with that, let's move on. So you have built your very first JavaScript game. Congrats with that. This is perhaps the first of many games you're going to build, perhaps the start of a career as a game developer. I don't know. Anyway, give yourself a pat on the back. You have learned a ton. And actually, let's do a little recap so that we remind yourself about all the awesome things you've learned throughout this section. One thing which was key to our app and is key to basically every web app out there is the arrays. We defined a card array, and also you reassigned the array down in the startGame function where you defined it with items. And then all the way down at the newCard button, you also pushed to the array. So you are starting to get some serious array skills. Also, we worked with objects. Up here, we created our player object, and the object, as you remember, contains key value pairs, and it's also a data type that is used in basically every single web app out there. The third data type you learned was booleans, namely the true and false for the hasBlackJack and isAlive variables. We flipped them around, so we set isAlive to true down here and hasBlackJack set to true down here, and thus creating kind of a state for our game. This brings us to the next important concept you learned, which is the if-else statements that wrapped these booleans and so many other things. This is key. You cannot build apps without these kinds of conditional statements. Both the if, the else if, and the else are absolutely key in any programming language. And in order to make these if-else statements work, we used comparison operators. That's these guys in here, less than or equal to or triple equal. They helped us define the conditions as to when we wanted to render the blocks of code in the if-else statement. Moving on, we also did logical operators. The AND operator, which checked that both this condition and this condition was true in order for us to run this code in the block of the if statement. And something we also learned was the for loops. It was here in the render game function where we used the for loop to loop through our cards array and render out each of the cards. Again, for loop is just one of those foundational things in programming, because so much of programming is evolved around looping through data and doing things based upon the data. Whether that's rendering it out, making calculations, sending it off from a server to a client, or just summing it together, for example, it doesn't matter. It's just something you'll do again and again, so I'm really happy that you've learned it as early as now. Another useful tool you've learned is the math object. That allowed us to create this getRandomCard function by using Math.random, which gives us a number between 0 and 1, and Math.floor, which basically floors the number to the nearest whole number moving downwards. And you built upon your further knowledge of functions and learned how to use return statements in functions, because in this getRandomCard we had to return values, and that's something you didn't know before this section. There's still more things to learn about functions, so we'll definitely continue on with functions in the Chrome extension we're going to build a bit later, but for now just be proud about the fact that you've at least come to the point where you can return values in functions. That's a big, important step. So, with all of these things learned, I completely understand if you feel that you're a little bit on shaky ground here and that all of these names basically just confuse you even more. I don't think you should worry about that. I would have never remembered the difference between comparison operators and logical operators when I learned JavaScript. What they are called doesn't really matter. The important thing is that you know how to compare two variables, for example, or that you know how to create a true or false variable. Whether that you call them booleans or true false isn't something you should be too worried about right now. So even though this might look scary, try to not let it scare you. Just focus on coding as much as you can, because over time these concepts will mature in your mind and become second nature. And actually, on that note, you are going to get some practice right away, because before we jump on to the final project, the Chrome extension, I'm going to throw a few challenges on you just so that we're sure that you really understand these concepts and that you build out that ever so important muscle memory. So let's go ahead and do that right now. Okay, in this challenge, you are going to practice objects and functions. So first, you are going to create a person object that contains 3 keys: name, age, and country. And the values of those keys should be set by using yourself as an example. So your name, your age, and your country. And then you are to create a function called logData that uses this person object. It just grabs it from the global scope to then create a string in the following format. Per is 35 years old and lives in Norway. Obviously, Per, 35, and Norway are pulled from the person object directly, whereas the rest is a string that is hard-coded inside of the function. Finally, call logData in order to verify that it works. So go ahead and do this right now, and then I will show you the solution as well when you return back. Okay, let's do this. We'll do let person equals, open and close curly brackets. Name should be Per, age 35, and country Norway, like that. And then the function log data, like that. Here we will console.log this string, and you can see the first value is actually pulled directly from person.name. So we'll do person.name plus, and then s, and then plus person.age, then plus again, years old, and lives in, plus person.country, like that. Now the final step is to call the function logData and run the code. And yes, we can see Per is 35 years old and lives in Norway. Great job. Okay, now you are going to practice conditional statements. So that is the if, else if, and else statements. And the problem you are going to solve is a very common one for train companies or a bus service, which is that the price of the ticket is based upon the passenger's age. For example, if the passenger is less than 6 years old, there's a free pass. 6 to 17 gives a child discount. 18 to 26 gives a student discount. 27 and up to 66, that's the age range that pays the full price. And the people over 66 get the senior citizen discount. So your job is then to create a conditional statement that accounts for all of these scenarios. And based upon the age variable up here, logs out which discount the passenger will get. So go ahead and give this a shot and return back to me when you want to see my solution. Okay, let's do this. I'll start with the if, and if age is less than 6, well then console log 3. Else if the next condition, that is that age is less than 18, because that will in practice mean from 6 to 17 here, because it's less than 18, yeah, that's 17 and below. However, we've already accounted for up until 5, so the code here will be triggered from 6 to 17. Console.log child discount. Okay, next one, else if. Here we'll do age is less than 27. Console log student discount, because this one kind of starts at 18, since this one stopped right before 18. And it should be up until including 26. That is, in other words, less than 27. Then we have the full price, which is for people now left in the group who are less than 67, or in other words, up to 66. Console log full price. And finally, then we have the else. We don't need to specify an if, because in all other cases, the passenger should get the senior citizen discount. Like that. Let's run the code. At 15, yes, we're getting the child discount. Correct. At 55, we're getting the full price. Very good. 75, we are getting the senior citizen discount. So it seems to be working for at least these 3 scenarios, and I hope it works for the rest. So let's move on. Okay, it's time to practice your for loop skills and your geography skills, because I've created this large countries array here, which contains the 5 largest countries in the world by population size. So it's China, India, USA, Indonesia, and Pakistan. And what you are to do is to use a for loop to log out the following to the world. First, a sentence, the 5 largest countries in the world, and then each of the countries on a new line with a dash and a space in front of the country name. So you are to use a for loop and loop through this array here. You can't simply hard code out all of the console logs. That wouldn't serve any purpose. So try to remember how to use a for loop. If you can't remember it, you can look back at previous casts, as we surely have gone through it. Or, of course, I will also show you the solution afterwards as well. Okay, let's do this. I'll start with the for loop, because that's the meat of this challenge. For let I equals 0, we'll start at 0, because as you remember, arrays are 0 indexed, and we want to use the index in order to fetch out each of the items. So starting there and stopping before I reaches large countries dot length. The length of this is 5, so before it reaches 5, that is 4, and indeed Pakistan is the 4th index, so that should be right. And we want to increment upwards, like that. Here, we'll do console log, and then first the dash and the space, like that. Concatenating this with large countries, passing in the square brackets the iterator variable I. And now let's run this code and bring up the console, and indeed, it looks to be working. Now, we only need to console log out the 5 largest countries in the world, like this, running the code, and yes, it works. Great job. Okay, now I need your help because I have messed up our large countries array. As you can see, in first place I have Tuvalu, and in 5th place I have Monaco. However, neither of those countries are large enough to deserve a spot in this large countries array. Actually, Tuvalu is a tiny island state far out in the Pacific Ocean with just over 10,000 inhabitants. And Monaco is a tiny state in Europe that's smaller than Central Park in New York. So surely it does not belong in this array. The 1st and 5th place belongs to China and Pakistan. So I need you to help me fix up this large countries array so that China and Pakistan are added back into their respective places. And to solve this, you are going to use the 4 following tools. First, push and pop, which you've learned earlier in this course, and then their counterparts, unshift and shift, which I haven't taught you about. But this is intentional because I want you to Google how to use unshift and shift. And what I will disclose to you is that they are kind of a mirror image of push and pop. Because whereas push and pop will work with the end of the array, unshift and shift works with the beginning of the array. So pop will remove an item at the end, like this, whereas push will push an item into the end, like that. And likewise, shift will remove an item from the beginning of the array, like this, and unshift will shove an item into the array at the start, like that. So with that short explanation and Google, you should be able to, I want you to try to solve this challenge. And of course, I will show you the solution when you return back to this screencast. Good luck. Okay, hopefully that went well. Let's do this. I'll start at the end. So I want to replace Monaco with Pakistan. Then I'll do large countries dot pop in order to pop away Monaco. And then large countries push, passing in Pakistan. Let's now console log large countries to see if this works. Running the code, and yes, there we go. Now, to remove this first item here, Tuvalu, I'm going to have to use shift. And here, I completely understand if you're confused as to why shift is named shift and unshift is named unshift. It's about the 2 most unintuitive method names in JavaScript, in my opinion. And one way to think of this is that unshift is a longer word than shift. So unshift makes the array longer. And that's just as push is a longer word than pop. So push makes the array longer. Anyway, let's just do this. Large countries dot shift. Let's see if we've removed Tuvalu by running the code now. Yes, Tuvalu is gone. That means I need to do large countries dot unshift and pass in China, like that. Running the code, yes, we have fixed up the large countries array. Great job. Now it's time for a scary challenge because you are going to check if it is Friday the 13th. And if so, you are going to log out this spooky face because, as you might know, Friday the 13th is kind of a scary date if you've seen the Friday the 13th horror movies. So you have 2 variables, day of month, which is meant to be from either 1 to 31, depending on which day of the month it is, and then a weekday variable, which is meant to be Friday or Tuesday or Wednesday or any of the days in the week. And if it is both Friday and the 13th, and only if both of those conditions are satisfied, you are to log out the spooky face. So just to remind you, you have to use the logical AND operator, which we learned is symbolized with these 2 ampersands. So go ahead and give this a shot right now. Okay, let's do this. We'll do if, open and close parentheses, and here we'll do day of month, triple equals 13, if it is the 13th day, and if it is the weekday of triple equals Friday. Then we are going to log out the spooky emoji like that. Running the code, nothing happens because it's Friday the 31st. Flipping this around, Friday the 13th. Yes, we are logging out the spooky face. And if we change this to Tuesday, nothing logs out because this time the first condition was satisfied. It evaluated to true, but the second one was not satisfied. So it evaluated to false. And the AND operator requires that both the first and the second evaluates to true in order to execute the code in the body of the if statement. So, great job. Okay, now you're going to practice returning random numbers. And the problem you are to solve is the rock, paper, scissors game. If you try that, it's a game where 2 people choose with their hands either a rock, a paper, or a scissor. And the way it works is that the rock will beat the scissor, but the paper will wrap itself around the rock so that the rock loses. And if the match is between the scissor and the scissor will cut the paper into pieces. So if those rules were a bit confusing, don't worry about it. That's not the point here. Your only job is actually to create a function that returns one of the random items in this array when it's called. So you need to work with Math.random in order to achieve this. Go back and watch previous casts if you've forgotten about that, or search for it on Google. That's even better. And finally, when you have coded up your solution and want to see mine, just revert back to this screencast and I will of course show you how to do it as well. Okay, let's do this. We'll call the function getHand. And inside of it, first need to generate a random index that we're going to use in order to fetch out rock, paper, or scissor. So we'll do let random index like that equals, first I'll just do math.random like that. And then actually I'm going to return random index and then debug along the way, just to be sure that I understand each step I'm taking. So here I'll console log the result of running the getHand function like that. So now if we run this, we're logging out 0.05 or 0.1 or 0.07 or 0.97. So a value between 0 and 1, not including 1. So 0.99999 is the top value. Okay, first then what we need to do is multiply this with 3. Now if we run it, you see that I'm getting a value between 0 and 2.99999. 0 to 2.999 is my current range. Now, the value I want is either a 0, 1, or a 2. So I'm not too far from this. And the way I can get that is by stripping away the decimals, by flooring it, in other words. Math.floor, like that. Here you can see 2, 0, 2, 1. Yes, now we are generating random numbers between 0 and 2. How can we use that to get back a random hand, either rock, paper, or scissor? Well, that is simply by doing hands and then using the random index as the index. Now, let's run this. We're getting scissor, we're getting paper, and we're getting rock. Brilliant. Great job. Now I have a fun little challenge for you, because you can see this fruits array here, which contains emoji fruits, basically 3 apples and 2 oranges mixed together. You are going to take these fruits and sort them onto the apple shelf or the orange shelf. The apple shelf is the one at the top here, and the orange shelf is the one at the bottom. They are just simply divs that I've given a little bit of styling. So you are to create a function that, when called, puts the apples onto the apple shelf and the oranges onto the orange shelf. And you should use a for loop, a conditional statement, and the text content property to achieve this. Now, one thing you might be wondering is, how do you work with emojis in JavaScript? And actually, you can treat these as normal strings. It's just as if it said orange here instead of having the emoji. So with that, I wish you good luck, and I'll see you later when I'll show you my solution. Okay, hopefully that went well. Let's do this. We'll do a function. I'm going to call it sort fruit, like that. And then inside of the function, we first need to loop through all of the fruits for let I equals 0, I equals less than fruit dot length, and I should be incremented upwards. Now inside of this, we need to check at every step in the iteration, are we dealing with an apple or are we dealing with an orange? So I'll do if fruit I, that's the current fruit, triple equals, and then I can just copy this apple here. If it's an apple, well, then we are going to do apple shelf dot text content. And here we're not going to do just equal the apple, we're going to plus equal, because we want to gather all of our apples here and not wipe them out every time we run this code. Then I'm going to do an else if fruit I triple equals, this time an orange. Well, then we are going to head over to the orange shelf and do text content plus equals the orange. Now, it would have worked perfectly fine if we just omitted this as well, like that, because in our array, if it isn't an apple, we know that it's an orange, but we might be getting other arrays which have bananas in them as well. And if so, we don't want to put any bananas in the orange shelf. We want to check explicitly that we are dealing with an orange before we put the fruit up on the shelf. So finally, we just need to sort fruit to run the code. Let's do that. And there we go. We got 3 apples and 2 oranges neatly sorted on both of the shelves. So great job. Hey, and welcome to this section where we are going to build a Chrome extension, which is just so freaking cool. Because Chrome extensions, if you haven't seen them, are programs that can enhance your browser experience in Chrome. This is an example called Honey. It's really brilliant because what it does is gather coupons from all over the web, and when you visit a page where you want to buy something, it gives you whatever coupons it can find online so that you can save money. And it was acquired by PayPal for $4 billion. So building Chrome extensions is huge because, everyone uses browsers, and surely what comes out of the box when you use Chrome surely hasn't thought of every single problem people might encounter when they are using browsers. And browser extensions is our way as developers to build solutions around these problems. Here's another one, Grammarly. I use it all the time here. So when I write for example, when I write tweets, it sits on top of Chrome and checks my spelling because it has access to what I do on the page and then suggests how I should improve my spelling and my writing in general. And this one right here is a lifesaver. It's motion, and it saves me hours every single day by stopping me right before I try to enter, for example, Facebook. And it does this with a ton of other distracting sites as well so that I can focus on what matters. Like, for example, creating courses on Scrimba or writing code or doing productive stuff. So cool. If you want to check out more extensions, you can head over to chrome.google.com/webstore. There you can search through all of them. And also, if you want to open your extensions in Chrome, just click this puzzle icon in the top right corner and you'll see all of your extensions. And here you can see Leads Tracker. What's that? Well, that is the one we are going to build in this section. It is based on an insight I had when I worked as a developer in a company called Zeneta, which is a provider of price information for people who are shipping containers. Because what I saw there was that the sales team at that company spent countless hours tracking down leads, or sourcing leads as they also call it. And that is looking for people online who might be interested in your product. So what they do is browse through a bunch of pages and look at people and no, this guy is probably not interested in our product. This one neither. Yes, here we have a potential customer. Let's save this one to our system. Moving on, this person does not look like a potential customer, but this one does. Yeah, and this one does as well. But this one does not look like a potential customer. So what they then had to do is take these 3 potential customers and store them somewhere so that they could reach out to them in the next phase. And this is something that basically every single sales representative does, because you need people to sell to, so you need to find them somewhere. So our leads tracker will be a tool for these kinds of people. The way it works is that you visit a website, for example, a profile on LinkedIn, and then you open up the extensions, click on the leads tracker, and there you can see you get the ability to save input. That is any URL that you pass into this input field, or hit Save Tab. If you hit Save Tab, our extension heads over to this tab, grabs the URL, and saves it in a list. And then you can move on to another page, for example, my LinkedIn page, and then hit Save Tab again, and boom, there we have the URL to my profile. And then moving on, this is Sindra, our CTO in Scrimba. Yet again, we click Save Tab, and his profile URL is saved. And this data is persisted, so you can close down the app or Chrome, turn off your computer, and when you come back, it's still there. So that you as a sales representative can then grab these leads and do something else with it. So this is actually a pretty useful tool for sales representatives. And it's actually deployed in the browser so that you can use it in the real world. And the point with this is to give you the powers to do this, to actually create a Chrome extension that has value, and also give you the skills you need to deploy it to someone's browser. So once you've learned this, I would really recommend you to look for opportunities, look for problems you see out in the world. Maybe there's a problem you have, or someone you study with, or someone you work with, or just a problem someone tells you about. When you come across problems people have, I want you to think, can I build a Chrome extension to help solve this problem? Because if you can do that, you truly have a superpower. That'll manifest itself in opportunities that you will get throughout your career if you're just willing to use that superpower, which JavaScript and web development is. So this was a long introduction. I hope you are as excited as me. Let's just move on and build your very first Chrome extension. Okay, in this challenge, you are going to create the basic markup we need in order to start building our app. So you are to create an input element, which is of type text and has the ID of input-L. And then you're going to create a save input button. That is one the user will click in order to save the input. And it should have the ID of input-btn. And here, save input should be the text inside the button. So go ahead and do this right now. Okay, let's do this. I'll start with the input and give it a type of text and ID of inputEl. And the input element is a so-called void or empty tag, meaning it only has an opening tag. So you're not supposed to create a closing tag because you're not meant to write anything in between input tags. It is the user that is meant to add the input. So this is how you create an input tag, which as mentioned, are often called void or empty tags, or you'll also hear them referred to as self-closing tags. Anyway, let's move on to the button. New button. That is not a void tag. It should have a closing tag and an opening tag. And in between, we are going to write save input. And the ID is set here as input.btn. If we now run this code, you can see, yes, indeed, we have an input field and a button. Great job. Okay, now you are going to style our app according to this design. So in the CSS file, which is where you're going to work, you'll see that I've already styled the body tag a little bit. Specifically, I've cleared out the margin since browsers often add a default margin to the body tag. I had to set that to 0 to neutralize that because I don't want any margin on the body. However, I've set the padding to 10 because I do want a little bit of padding. You can see here on the body element that there's some space between the edges and where our elements start. That is the padding that is provided. And here I've also set a font of Arial, and that is a web-safe font. So that one should work without, for example, using Google Fonts in our project as well. So just click on the slide here when you want to see the design, and click outside of the slide when you want to go back to the code. And I've also added a little helper text here, which is the hexadecimal code of the green color, which you can see on the button and on the borders of the input field. Now you can see on the bottom image here that I've added some text to the input field. The slightly bluish color in the background here is not something you are to configure. That's just default styling that is added by the browser, so you don't have to think about that. As far as you know, the background of the input element will be white. Now I'm going to get you started here with making the input element full width because that's a little bit unintuitive and I want to show it to you. Because as you can see here on the input element, when we enter text into it, we have a little gap between the text and the edge of it. However, in our app now, if I do like that, you will see that there is basically no gap. So we have to add a little bit of padding on the left side, let's say 10 pixels, and there you can see we got the gap. We want the same gap on the right-hand side as well, so I'll do padding right of 10 pixels as well. So now we have that, and you might wonder why I started there. It's a little bit weird, but let's say that we now want to provide the styling for making this input field be full width. Well, then I'll do width and then set it to 100%. That means take up all the available space I have inside of my container. And for the input field, the kind of container it lives inside of is the body tag. So that means that 100% should make the input field take up the entire body, and the body has a little bit of padding, as you know. So I would expect this to actually stop at the right 10 pixels before the end of our browser. But actually, it doesn't do that. It continues on and actually goes past our browser, which is a little bit weird. The reason is that the true width of this element now is 100% plus 10 pixels plus 10 pixels, because it includes the padding left and the padding right and adds that on top of this width. So that's a problem, and it results in our input field being wider than our body tag, and we don't want that. So the trick I'll use to avoid that is something called box sizing. And here I say, I want you to size the box along its borders. I'll write border box, and there you can see. Now, the full width includes the paddings as well. The 100% now takes into account the paddings and just makes sure that the entire thing spans across the entire body tag, but not overflowing it. I wanted to show you that because it's not entirely intuitive. Now you have what you need. Your job is to use only these two selectors, the input and the button selector, and make it look like the design you can see here on the slide. So go ahead and give that a shot right now. Okay, hopefully that went well. Now let's do this together. I'm going to continue with our input element, because here we'll see that it's very crammed above and below the text we have written in the input field. So what I can do is padding bottom, also of 10 pixels, and padding top, also of 10 pixels. Now we have something that looks much more like what we have here. Next up, we also need the color on the border. So we'll do border, 1 pixel, solid, and then use this green color here, like that. Starting to look good. Now we can actually continue with the button. The first thing is the background color, which is green. We'll do background and use this green color again, like that. Okay. Also, the text is white. Color white, like that. You can see there's also padding here as well, which we need to add. There's a little bit more padding on the left and right hand side. Let's try padding top of 10 pixels and padding bottom of 10 pixels. And then padding left of 20 pixels. Yeah, starting to look good. Padding right of 20 pixels. And now I actually want to clean up our code a little bit, because you can see we're using this very verbose way of writing paddings both here and here. Whereas in the body, as you have learned previously in this career path, you can use the shorthand. And if all of the top, bottom, left, right are of the same value, we can just use padding. So I can remove all of these and do padding 10 pixels. Here, it's a little bit more complex, but the top and bottom are identical and the left and right are identical. What we then can use is padding and then 10 pixels for the top and bottom, and then 20 pixels for the left and right. So the first value kind of becomes the y-axis, above and below, and the second value becomes the x-axis, to the left and to the right. If I remove this, you can now see that it looks identical as how we had it previously, but we've removed a ton of lines, which is good. Now, another thing on the button is that it has these default borders. We don't want that according to our design. So we'll do border none, like that. Now it's really starting to look similar, but there's two things. We want to bold the text, and we need a little gap between the input field and the button. So font weight, set it to bold, yes. And the gap between the button and the input can be added to either of the elements. I'm going to add it to the input field. You can use a margin, bottom, and set it to, for example, 4 pixels. There we go. Now we have something that looks pretty much like what we have, and it's also responsive, so we are ready to move on. Okay, now we are going to move from the CSS over to the JavaScript, because we have to make our input button work. And while you won't make it useful in this cast, you will at least have it log out button clicked when the user clicks it. So, you know how to do this. You're going to have to modify both some HTML and write a function in the JavaScript file. So go ahead and do it so that when I click the Save Input button, the console will log out button clicked. And once you are done, return back to this screencast and I will show you the solution as well. Good luck. Okay, hopefully you remembered that the way to do this is to create an onclick handler on the button. There you want to type the name of the function you want to trigger. Let's call this function saveLead, for example, open and close parentheses. Then we'll head over to the index.js file and create that function saveLead, like that. And inside of it, we'll do console log button clicked, like that. We'll run the code, click the button, and indeed we are logging out button clicked. Great job. So while this way of writing event listeners, where we define a function and trigger it via the onclick attribute in the HTML, works perfectly fine, out in the wild, you'll most likely see professional developers use a slightly different technique. So it's important that you learn that one as well. And the way we do that is by first grabbing a hold of the ID of the element we want to hook an event listener onto. So I'll do let inputBtn equals document dot get element by ID, passing in the input-btn. And then what I'll do is inputBtn dot addEventListener, like that. And inside of the addEventListener function or method, which it's also called, I'll first specify what kind of event I want to listen for. And here it is the click event. And then I'll write a comma and do something which might look a little bit weird, because now we are going to define what are we going to do when someone clicks on this input button. Well, we are going to invoke a function. And in order to invoke that function, we first have to write it. So I'll do function, open and close parentheses, and then the curly brackets, and break it onto a new line. And inside of this function, we can write whatever code we want to be executed when the user clicks on this input button. So here we'll do console.log button clicked from addEventListener, like that. And let's change this to button clicked from onclick attribute. Now, if we run this code, hit the button, you can see both this line and this line is executed. However, now we can actually remove this onclick event listener from our HTML. And some would say that this results in a cleaner separation of concerns, where the HTML doesn't worry about any event listeners, as that's all gathered in the JavaScript. So, of course, then we should also remove the saveLead function. And we're left with this. Running the code, clicking the button, and only this line triggers. So, in the next cast, you are going to get some practice writing this type of event listeners. So let's dive into it. So, in this challenge, you are going to practice writing event listeners using the technique you just learned. So it's a 3-part challenge where you first are to grab the box from the DOM and store it in a variable. Here you can see the box. It's just a rectangle that says open the box. You can imagine that this is some kind of Easter egg on a e-commerce website where if you open the box, you get a coupon or something like that. And as for HTML, it's just a very simple div with an ID of box. And of course, I've styled it a little bit in the CSS file, but we're not going to worry about that. So when you have grabbed the box from the DOM and stored it in a variable, you are to add a click event listener to it. And then finally log out, I want to open the box when the box is clicked. So if you struggle to remember how to add an event listener using JavaScript, you can go back and rewatch how I explained that, or even better, Google it out, and you should find the solution as well. With that, go ahead and solve this challenge right now. Okay, hopefully that went well. Let's do this. So we'll do let box equals document.getElement by ID, passing in box. And then to add the event listener, it's box.addEventListener, passing in first the event we want to listen for. That is the click. And then what do we want to trigger when the user clicks? Well, it's this function right here. And inside of it, we're going to console.log. I want to open the box, like that. Let's run the code, click the box, and yes, it works. Great job. Okay, we are back at our lead tracking app. Now, of course, you are going to do what I showed you before you learned about addEventListener, which is to refactor our app so that it uses the .addEventListener when you click on the Save Input button. Because this is Scrimba, I'm not supposed to write the code, so even though I've already done it, now it's your turn. So go ahead and do this right now. Okay, hopefully that went well. Now I will quickly do it as well. First, we need to grab a hold of the button. I'm going to grab the ID here and do let input btn equals document.getElement by ID, passing in the ID. Now that we have that, we can do input btn dot add event listener. We're going to listen for clicks, and the code we want to run when users click the button is inside of the body of this function right here. So I'm going to copy this console log, paste it in there. Now I can remove the save lead function, and I can also remove the onclick attribute in the HTML, like that. I'll rerun the code, click save input, and indeed it works. Great job. Let's move on. Now we need to set up the infrastructure for being able to actually save the leads that we enter into our input field. And for that, we need two variables. First, a myLeads variable, which should be assigned to an empty array. Secondly, the inputEl variable, which should be assigned to the text input field. With that, I mean the input field right here. So go ahead and create these two variables right now. Okay, the way to do this is let myLeads equals an empty array, like that. And for the inputEl, you probably did let inputEl equals document get element by ID, passing in the inputEl. However, what I'm going to do is to swap out this let with const. That's weird. Why am I doing that? You might wonder. And that is because in modern JavaScript, developers use both let and const to declare variables. And now I think it's about time that you learn both of these methods. So we're going to set the inputEl as a const and also the input btn. Now, the main difference between const and let is that const cannot be reassigned. And the name kind of hints to that. It says const, which is short for constant. So whatever you assign it to should be constant, meaning you can't reassign it. And if you don't remember what reassignment is, it's when you do inputEl, for example, equals hello. This won't work. If I run this code, you can actually see assignment to constant variable. I tried to assign the inputEl, however, it's a constant. So JavaScript is saying, not allowed. Now, you might ask, why do we need this? This seems to be something that just makes it more difficult for us to code because it gives us less freedom. Well, that is a very good question. So in the next cast, we'll dig into exactly that so that you properly understand why you want to use both let and const and actually get some practice using both of these variable types. Okay, let's say that we are back at our Blackjack game and we have two variables, player name and credits. The first one is a const, whereas the second one is a let. Now, immediately upon seeing these two variables, a developer will understand that player name is not to be reassigned. However, this developer wouldn't only think that credits can be reassigned, it would actually assume that credits are to be reassigned further down in the code. So the developer would expect something like credits equals credits minus 10, for example. And the reason for that is that developers often use the following to decide whether or not they should use const or let. So if possible, default to using const. If not, use let. If these two lines follow this methodology, it would mean that it simply wasn't possible to write credits as a const, because it is going to be reassigned later down in the code. And thus, we skipped the default of const and used let instead. And this is actually the biggest benefit with const. It gives us a way to quickly signalize to anyone who are reading the code what do we want to do with the variables? So in addition to expecting that something like this here would happen, the developer would also be very suspicious if she saw something like player name equals something else down here, because that would mean that the person writing this code mixed up their let and consts, or perhaps didn't even understand it. And as we know, this will give us an error. So with all of this knowledge and following this methodology, I want you to do a challenge. Which of the variables below should be changed from let to const? Here, the situation is an e-commerce shop where you have a base price, a discount, a shipping cost, and shipping time. At some point, though, the details of the shipping changes, and then you calculate the full price, and finally notify the customer. So go ahead and change some of these variables to const, and then I will show you the solution afterwards as well. Okay, let's do this. I'm going to start down here on where things are reassigned. It's easy to see that these are reassignments since we're starting a new line with just the variable name, not let, in front of it. So here we are reassigning shipping cost and shipping time, meaning these two can be let. And this is a new variable, so actually, here's the end of our code, and base price and discount, they haven't changed. So they could be consts. And it says here, if possible, use consts. So default to consts. So then I'll do const and const, like that. Run the code. Works perfectly fine. I haven't broken anything. Is there anything else we can do? Yep, actually it is. Here, at full price, we see that this variable is only assigned once. It's not reassigned further down, just used here in the console log, meaning that this one also should be a const. So hopefully you now understand why we want to use const and let. And if it's still a bit confusing, don't worry about it. We're going to continue using these variables throughout this course. So eventually it'll be completely natural for you to switch between these two variable types. With that, let's return back to our lead tracker app. Okay, we are back in our lead tracker app, and now we need to make sure that when the user hits the save input button, a lead is pushed to the myLeads array. For now, you're just going to use a hard-coded lead, so www.awesomelead.com, for example, and that value should be pushed to my array when the input button is clicked. So go ahead and give this a shot right now. Okay, hopefully what you did was to here inside of the body of this function, write myLeads.push. And then pass in www.awesomelead.com, like that. If we now also console log out the myLeads array, like that, we will actually verify that it works. I'll hit the save input button, and there you can see, we now have one lead in the myLeads array. If I hit it again, we have 2, and 3, and 4. However, it's pretty useless because we're just pushing the exact same thing to the array, so let's fix up that in the next cast. Okay, so now we are going to take whatever the user enters into the input field right here and push that value into the myLeads array when the save input button is clicked. So push the value from the inputEl into the myLeads array instead of the hard-coded www.awesomeleads.com value right here. However, I haven't taught you how to actually get the value from the inputEl. That is, for example, this www.example value right here. So you need to Google that. And that's great practice because Googling is, as you know, something professional developers do every single day. So here is what I recommend you to Google. Try to find, for example, a Stack Overflow question and see if you can figure it out on your own. If you don't, no worries, I will solve this for you when you return back to this cast. So go ahead and do this right now. Okay, hopefully this went well. Let's take a look at how we can find the answer to this by Googling. So we'll take the get value from input field JavaScript, which was my suggested string, and just paste it into Google. There you can see we are getting a ton of results. The first one is W3 schools. I want to go to stackoverflow.com, so I'll click here. go into Stack Overflow, and here we can see the question being asked. It seems super relevant for us, and it's been viewed 2.5 million times, so super relevant for a lot of other people as well. Let's scroll down a little bit to the answers, because that's where the juice is. Here we can see there are various methods to get an input text box value directly. And here, method 1, that's probably what we want. You can see document.getElementById, passing in an ID, and doing .value. Oh, that's pretty handy. So how do we go about doing that? Well, we already have the document getElementById, and we have stored that in the inputEl variable. So perhaps we simply can do inputEl.value then. Let's now refresh this and do www.sampleLead.com, save input, and yes, we can see in our console that we have pushed the value we entered into the input field. Lead2.com, save input, and that works as well. Great job, let's move on. Okay, now that we're able to take the input value and push it into the myLeads array so that we store our data, it's time to set the stage for going the other way around as well, meaning rendering out the leads. And as you might remember, when you want to render all of the items of an array out, you first need to loop through that array and grab each of the items. And that's exactly what you're going to do in this challenge. However, to begin with, you are going to work with some dummy data just to make it a little bit easier for you. So I've pasted in 3 dummy leads in the myLeads array here, so that down here, starting on line 12, you can simply write out a for loop that logs out the items in the myLeads array. Hopefully you remember how to do this, and if not, no worries, I will of course show you the solution afterwards as well. But go ahead and give this your best shot right now. Okay, hopefully this went well. Let's do this. We'll do for let I equal 0, because we want to start at the 0th index of the myLeads array. I should be less than the length of the array. So that's myLeads.length. And we want to increment I upwards with 1 for each step. Then the inside of the body of the for loop will simply console log out the myLeads using the I, our iterator, as the index. Now we run this code, you can see in the console, yes, we are indeed logging out all 3 of our dummy leads. Great job. Next up, we are going to transform this for loop from simply logging out the leads to actually rendering them out on the page. However, in order to do that, we have to actually create that unordered list where we are to render the leads out. So you are going to do that through a 2-part challenge. The first part is to create the unordered list element, the UL, with an ID of UL-L, that's for unordered list element. And then after you've done that, return back to the JavaScript and grab this unordered list and store it in a const variable that's called UL. A little bit of a weird name there, but of course also short for unordered list element with the camel case convention we're using in JavaScript. So once we've done that, we have set the stage for actually rendering the data out instead of just logging it, so that we can do that in the following lessons. So go ahead and solve this 2-part challenge right now. Okay, hopefully that went well. Let's do this together. Starting in the HTML, we need to create the unordered list, UL, and closing the tag, giving it an ID of UL-L. That, if we run the code, nothing happens in the browser because the element is empty. So let's just move on to the next part. Here we are to create a const, call it UL-L, and set it to document.getElementById, passing in UL-EL like that. Now, just to make sure that we've done everything correctly, let's console log out this element. Run the code, and there we can see it is being logged to the console. Good job solving this one. Let's move on. Now you are going to render the leads out in the unordered list we just created using the .text content property, which we've used in previous sections. So you are to replace the console log here with the rendering of each item into the unordered list. Now, what will happen here is that you'll simply render out plain text inside of an unordered list, for example, www.awesomelead.com. If we run this, this is how it'll look. And as you hopefully know, this is not how we write list items inside of an unordered list. The way to do it originally is to use li elements like that. You run the code so that we get this dot signaling that it's a list item. However, for now, you are simply going to render out plain text inside of the unordered list. So we're kind of doing it wrong first, and then we'll fix it up later. So just go ahead and render all the leads as plain text inside of the unordered list using .textContent, even though that's not the correct way to do it. But I wanted to do that first because the most important thing is to make it work, and then we make it better. That's the philosophy here. So I'm going to rerun this page so that we don't have any leftovers from when we looked at the HTML. Now we just have an empty unordered list. Go ahead and do this right now. Okay, hopefully this went well. To do it, you'd do ull, you'd grab a hold of the unordered list, do .textContent, and here you might have been tempted to say equal myLeads, and then the index. Let's see what happens if you try that. It only renders out greatLead, which is the final one. The reason for that is that at each step in the iteration of the for loop, you cleared out the entire text and assigned it to whatever lead you were looking at that step in the iteration. So for a split second, the value of the text content was awesome lead. For another split second, it was epic lead. And then finally, it was cleared out yet again and set to great lead. And that is what we are seeing in the browser now, since the for loop then stopped. It had looped through the entire loop, and it then broke out of the loop. So what we rather need to do is plus equals, something we also did in our poker game, if you remember that. That'll take the previous value and then concatenate it with the current lead we are looking at. So if we run this, you can see now we have all three leads rendered out, but it looks horrible. We want to add at least a space in between them. So if you remember that, you can do that with plus and then a space. Now it looks slightly better. If we shrink in the screen, they actually break out on separate lines. But if we enlarge in the screen, they are just rendered out in one line. So this is still the wrong way of doing it, since we've just added plain text inside of the unordered list. We want to add list items. Now we at least know how to take the data in myLeads and render it out on the page. And we also know how to take whatever the user inputs into the input field and push that value into the leads. So we kind of have a very simple implementation of each part of the app that we simply need to put together so that we at least have a working first version. So let's continue on. Okay, now we need to fix the fact that we are simply rendering out plain text strings like this inside of the unordered list. Because that's not what we want. We want to wrap them in list tags, of course, like this. So in order to do that, let's first just try to add, for example, an li opening tag before the lead and an li closing tag after the lead. To run this, you can see, we simply rendered out the HTML tags as plain strings. That's not what we want. We want our browser to parse this as HTML so that it can really turn them into list items. And the way to do that actually is simply replacing this text content property with something called innerHTML. If we do that and run the code, you can see there. Now we have them as proper list items with these bullets that are included on the default styling of list items. So this means that the browser actually looked at this string right here and understood, okay, this is actually the starting of a list element. I'm going to avoid rendering that out as a plain string and instead convert this entire thing to a list item. So this opens up a whole new world of manipulating the DOM. Suddenly, you can create HTML elements with JavaScript. So let's take a closer look at inner HTML and give you some practice on how to use it. So to help you learn inner HTML, I have a really silly example for you here. Because let's say that you are working on an e-commerce website. Somehow, your colleague, the HTML developer, has forgotten to add the buy button inside of the div container. That is a crisis because your customers now can't buy your products. So you, as the JavaScript developer, have to do that instead. So you're going to use the .innerHTML property to render out a buy button inside of the div container. You have to grab a hold of the div container first and then use the inner HTML. And the text inside of the button should be buy with an exclamation mark. So go ahead and give this your best shot right now. Okay, let's do this. So first I'll look at the HTML. The ID of the container is indeed container, so I'll use that. Const container equals document.getElementById, passing in container. Now that we have that, we can do container.innerHTML equals, and here we'll create the button by inside of the button, and then the button closing tag. If we run this, yes, we can see that we have a really neat button already styled because our CSS developer had indeed did their job, and so have you. So give yourself a pat on the back for doing this, and let's move on. Okay, let's continue on with our e-commerce website. Because let's say that you want to thank the user after she's made a purchase. That's a nice thing to do. So what we want to do is that when the user has clicked the button, we are to render a paragraph under the button, but still inside of the same container. So this container right here in which the button is rendered inside of. And the paragraph should say, thank you for buying. So I'm going to help you a little bit on the way here by creating an onclick event listener inside of the button that will try to invoke a function called buy when the button is clicked. So your job then is, of course, to create that buy function and have it render a paragraph inside of this container using .innerHTML so that the user is thanked. And one thing, we don't want to remove the button. When you render this paragraph, it should be under the button. So go ahead and give this your best shot right now. Okay, let's do this. We'll do function buy. And then inside of the body of the function, we need to target the container yet again, container, and its inner HTML. However, if we try now to just render out a paragraph like this, and run the code, click the buy button, then we lost our button, because here we just cleared out the inner HTML. And say, we want whatever's inside of the container right now, we don't care about it. We want to set it equal to this paragraph and this paragraph only. What we instead have to do is use our good old friend plus equals. So now, if we run this code again, hit buy, and there we go. Thank you for buying, neatly placed underneath the button. Great job. Okay, we are back at our Chrome extension app, and now your job is to do exactly what I did a few casts ago. I replaced the text content with the inner HTML so that we could render proper li tags instead of just plain text inside of our unordered list. That is this element right here. So go ahead and use your freshly acquired knowledge about inner HTML to solve this challenge. Okay, hopefully that went well. The way to do it would be to first add a opening tag before our leads is rendered out. We'll do that with a double quote and li, and then of course a plus. Now we already had this empty space previously. We don't need that anymore, but we do need a closing li tag. If we now run this, you can see, oh, it doesn't work. Well, that is because we're still using .text content. We have to change it to inner HTML, like that. Running the code, there we go. 3 list tags rendered out exactly how we want them. Let's move on. Now that you've finally managed to work with inner HTML, I'm going to be a little bit annoying and teach you an alternative way of solving this that doesn't use inner HTML. Because while I prefer to make a lot of the choices for you as to which technologies you should use to build apps, especially as a beginner, in this case, it makes sense that you learn it in two different ways, even though we're only going to proceed with one way in this app, and that is the .innerHTML. But you will see this other method being used both in Scrimba's front-end developer career path and out in the world. So I'm going to teach it to you. The way to understand it is to break this line of code into 3 steps, because let's have a look at what's actually happening here. So first, we are kind of creating the li element. So create element, and then we are setting the text content of that element. Finally, we are taking that expression and kind of appending it to the unordered list, because appending means to add something at the end of a document. So append to unordered list. So with this, we have the pseudocode for our solution. Let's now comment out the original way of doing it, and then write out the new way. So the first thing we need to do, create the element. That is done by document.createElement. It looks almost like these document.getElement by ID here. However, now we are creating something, not fetching. And what are we creating? Well, whatever we place inside of the parentheses. Naturally, in our case, this would be an li element. And this is how we specify it. We don't need to wrap it in these HTML tag symbols. Now we have created the list element, so we need to store it in a variable. I'm going to use const li. And next up, we got to set the text content. So we'll do li.textContent equals myLeads I. Okay, final step, appending it to the UL element. Well, then we'll do ULL.append. And what do you think will append? Well, the li, of course. So we'll take this and pass it in there. Now, if I run this code, you can see it works. However, in my opinion, this is easier to understand intuitively than these 3 lines. Because here we get to see at least the HTML element in a more humanly readable way. But you will come across this method as well. So now what I want you to do is basically do the same thing as I did. Try to make this work with the new method and with this line of code, comment it out. And if you need help, you can use this pseudocode to Google your way to the solution, or you can of course go back and watch how I did it. But after you've done it, I'm not going to go through it again because I've already done exactly that. This is just a little digression for you to get this practice of doing it another way. And then when you're done, we are going to return back to this .innerHTML method here from the next cast and work a little bit on the performance of our solution. So give this a shot right now, and then I'll see you in the next cast. Now it's time to improve the performance of our rendering by first creating a variable list items to hold all of the HTML, then concatenating the HTML elements onto that variable so that you, after the loop has finished, can render all of them in one go. So just to go through this is a 3-part challenge where you first create the empty variable, which you should call list items, and that should eventually hold all of the HTML for the list items. But to begin with, you are going to assign it to an empty string. Then inside of the for loop, instead of manipulating the DOM every single time the loop runs, in every iteration of the loop, you're going to rather add the item, this one right here, to the list items variable instead of using the inner HTML on the unordered list itself. And then finally, after the for loop has completed, then you can take the list items, which now contain all of the HTML you need, then render it inside the unordered list using inner HTML. So this way, we'll make our code more performant and faster. So go ahead and give this a shot right now. Okay, hopefully this went well. Now let's do this. First, I'll start with the list items. I'm going to have to use a let for that one, because it's going to be reassigned, as you know. And for that, we cannot use consts. So to begin with, it should be an empty string like that. Then here we are going to add the items, these guys, to the list items variable instead of setting the inner HTML directly. So this is simply replacing this here with list items. And now after this code has been running 3 times, 1 for each lead in our array, this list items variable should contain all of the HTML we need. So then we can render it out by doing ull.innerHTML equals list items, like that. Let's try this, run the code, and as you can see, we get the exact same result, meaning that it works. If you're still a little bit confused of what's going on here, I would recommend you to, for example, console log out the value of list items so that you get to see what the value of that string is in every iteration throughout the loop. And once you feel you have a good grasp of this, we'll move on to the next lesson. If you find yourself struggling to remember as to whether or not the performant way was to do .innerHTML inside of the loop or outside of the loop, you can remember this sentence. DOM manipulation comes with a cost. And with that, you can ask, well, if it comes with a cost, is it best to manipulate the DOM, namely using innerHTML, 3 times inside of the for loop? Or is it best to just do it 1 time outside of the for loop? Well, if it has a cost, you'd prefer to do it 1 time than 3 times. So just remember that DOM manipulation has a cost, and look at your code in the light of that. Now finally, if you are a bit confused of what's really going on under the hood with this string that we are constructing by running through our loop, what you can do is log out list items down here under line 16 just to inspect how it looks in every iteration of the loop. So feel free to jump in and do that right now, and when you are ready, I will see you in the next lesson. Okay, now that we have many of the pieces of our app working, let's stitch them together so that when a user enters a lead and hits the save input button, it'll actually be rendered out, as opposed to us having to actually add the dummy data from the get-go, hard coding it here on line 1. So I'm going to remove these lines, and your job is split into 2. First, you are to wrap the code below, that is from line 13 to 17, in a renderLeads function. And then you are to call renderLeads function inside of the event handler for the button clicks. And I'm going to remove this console log right here to make it a bit cleaner. So just to talk through the logic here, what will happen is that when the user adds something into the input field and hits the save input, this epic lead, as you know, will be pushed to the myLeads array. And then if we call the renderLeads and have this wrapped inside of that renderLeads function, it should, according to our plan, render out whatever items there are inside of the myLeads array, which would be much better than what we have now, where simply I can hit the save input as much as I want, but nothing happens. My lead just stays in the input field. Not good. So go ahead and try to knock this one out. Okay, hopefully that went well. Now let's do this. I'll write function render leads, and then the body of the function. Inside of that, I will copy this code and also tab it out so that it's easier to read, like this, looking good. And then we are to call the render leads function. We do that by doing render leads and adding the open and close parentheses. Now, if we run the code, www.epiclead.com, save input, yes, it works. I do www.awesomelead.com. Woohoo! It actually works. Really good job. Now we have stitched together the various pieces of our app, and we have what looks like a functional prototype. You should be really proud of yourself reaching this far. So give yourself a pat on the back, and when you are ready, let's move on. So while our app now works, it has a little bit of a usability issue, because if I now try to add a lead here, and hit save, you can see it is indeed saved, but it still persists in the input field as well. Most likely, we'd want to clear out this input field. So that is what I now want you to do here on line 8, clear out the input field, though I haven't told you how to do that. And that is intentional, because now I want you to Google it. And even better, I want you to try to figure out on your own what you want to write into Google to try to solve this issue. So I'm not going to give you the text you are to paste into Google this time. You just have to try and figure that out on your own and see if you can find the answer, because that's a critical skill as a developer. You'll come across problems out in the wild every single day, and you won't have me there to tell you what to Google. So you obviously have to learn how to think of a phrase to Google yourself. So go ahead and do that. Try to figure out how you can clear the input field. Write the code you think works, test it out, and then, of course, return back to this screencast when you want to see my solution. Okay, hopefully that went well. If not, no worries. Let's do this together. So I would, for example, Google clear input value with JavaScript. Here you can see we get a ton of results. I normally jump to the Stack Overflow question. So let's click into that one. You can see HTML how to clear input using JavaScript. So this user is using a slightly different technique than us with a function and something called a target. However, most of the time I hardly even read this. I just quickly scroll down to the first answer to see if there's some kind of hint there as to what we are to do. And here you can almost ignore all of it, except for the line in the middle here that says target.value equals an empty string. That's interesting. That looks like something we can use. So here, perhaps we can do inputEl.value and set that to an empty string. InputEl.value equals like that. Let's run the code. We'll do read3.com, save input, and indeed, it worked. So great job. Let's move on. Okay, now our job is to make our leads list clickable, because as you can see here on the li item over in the browser, this is just plain text, where we want it to be a link so that after a sales representative has gathered all of the leads, she can click and check them out again at a later stage if she wants to. So in order to do that, we need to wrap the lead in an anchor tag, that's the a tag, inside of the list item. So you need to change this expression here so that myLeads is also wrapped in an anchor tag. And then you need to use the href attribute to point to the specific URL, which is the same as the text you are rendering out. And I also want you to make the link open in a new tab. And if you don't remember how to do that, it's super easy to forget. You'll just have to Google it out and figure it out on your own. So go ahead and knock this one out and then return back when you want to see my solution. Okay, hopefully that went well. If not, no worries, let's do this together. So we want the anchor tag on the inside of the li tag. So I'm going to add in the same strings as we are creating the li elements, an anchor element as well. So like that. And I'm going to set the href now just to this hashtag symbol right here. And then I'm going to close the anchor tag on this side. If we run the code, to add awesome lead into the input and save it, there we indeed can see that we get the default link styling. So our link works. Now at this point you might wonder, well, why am I using single quotes for the value of the href? Why isn't it wrapped in double quotes as you might have seen people do other places when writing HTML? Well, that is because here we're using the double quotes to tell JavaScript that we're working with a string. And if we then use a double quote here as well, then we're actually ending the string here as opposed to ending it here. So this is a little bit complicated. When you start having strings that need quotes inside them, then you have to use either single quotes on the inside and double quotes on the outside, or the opposite. And now this actually becomes even more complex, because what we need to do is inside of here, replace this hashtag with the myLeads, because it's going to point to that URL as well. How do we do that? Well, now we actually need to close off the string before the hashtag, because we're going to add a JavaScript variable. So then we will add the double quote, a plus sign, and then a plus again, and then a double quote yet again to start this string right here. Of course, then this hashtag now serves no purpose. It's just an invalid character in JavaScript. We need to replace that with the myLeads. So we can remove this space right here. Now, if we actually console log out the list items, you run the code and try to save an input as well again, then you can see we are getting an expression which looks like valid HTML. One more thing we need to do is to make the link open in a new tab, and I told you to Google that, so let's just do that as well. And here I would just Google href open in new tab, and actually Google is smart enough to just give us the answer at the top here. You can see it's pulled it from this rapidtables.com article. And here you can see, in order to open a link in a new window or tab, add target equals underscore blank inside of the h tag. All right. Well, I'll do target equals. And what kind of quotes do we need to use now on the inside of the string? Well, we need to use single quotes, underscore blank. Otherwise, we would have escaped out of the string again and into JavaScript land. And we don't want to do that. This is just a string, and we don't need any JavaScript variables to express it. Now, one thing is that when you try to click these links in the Scrimba browser, even though you're using target blank, it won't work properly. It'll open up a new tab which just has a super weird URL. That's just a Scrimba quirk, so don't worry about that. If you run this code from your local computer, this anchor tag will indeed work. Anyway, now we have all of this, and it works. However, this string is really long and ugly in my opinion. It's a complicated expression, and I would like us to simplify it and avoid using these mix of single and double quotes and all of these plus signs. And maybe we also want to write this expression on multiple lines as you normally do in HTML. However, that won't work. As you can see, it breaks our entire code in syntax highlighting, seen by the fact that the syntax highlighting is completely off at this point. So in the next cast, I'm going to teach you about template strings, which will solve exactly that. So just stay tuned and I'll see you there. So in order to make this expression a lot simpler, we'll use what's called template strings. And to make it super clear for you, the benefit of template strings, I'm actually going to comment out this current string and then on a new line, create the template string so that you can compare the two. And the way you turn a normal string into a template string is by replacing the quotes that wrap the string with backticks instead. So let's do that and pay attention to what happens with the syntax highlighting of myLeads and the plus operators when we do that. I'm going to do that and that. As you can see, it all just became blue. So now this is no longer a JavaScript expression. It's just a string. But we are of course going to fix that after we've looked at the first huge benefit with template strings, which is that you can break it into multiple lines. Something we couldn't do with the normal double quote string up here. So this gives us the opportunity to write our HTML much like our HTML looks like in an HTML file, like this. This is a much easier expression for us humans to parse than this one up here. So now we have that. It's time to take these sections here, which previously rendered out the leads, but now just are plain strings, and simply delete them and replace them with a $sign, open and close curly brackets. Then passing in whatever JavaScript expression we want inside there. This is how you kind of escape out of the string and shove a JavaScript expression into the string. In my opinion, much easier than what we had here with the quote, the plus, then the expression, then another plus, then a quote. Simply replace all that with this. And now if you want to go even further, we can add the contents of the anchor tag in a new line so that we get this really nicely formatted expression. It looks just like we would write it in the HTML file. If we now run this code, save the input, it works just as it did previously. But now we have removed all of the ugly pluses, all of this wrestling we had to do between single quotes and double quotes and make sure that we used each of them in proper order. Here we can do whatever we want. We can even replace this here with a double quote and use single quotes there. Well, that's not a good practice. This just shows the power of the template string. But now I've been writing code for far too long. The point here is that you should write the code. That's what Scrimba is all about. So over the next few lessons, you are going to get your hands dirty with template strings. Now you are going to practice template strings, or template literals, as people also call it. I prefer template strings though, as that's just an easier expression. Your job is to take this string, which is a concatenation of two hard-coded strings and a variable, and turn it into a template string. I'm console logging it down here on line 8 so that you can see results. If we run it, you can see that it says, "Hey James, how's it going? Cheers, pair." So go ahead and change this from a standard double quote string into a template string. And then of course I will show you the solution when you are done. Okay, hopefully this went well. Let's do this. I'll start by simply replacing the first double quote with a backtick and the last double quote with a backtick. Then the entire thing is a string. So now if we run this, it'll say, "Hey, plus recipient, how's it going?" Obviously not what we want. We want James to be logged out as well. So we can remove all of this clutter, all of these plus and quotes, and do $sign, open and close curly brackets, and then type in recipient. Run this. Yes, it's now a template string. Great job. Let's make our email variable even more dynamic so that it also can take a sender value, which is the person sending the email. So you are to create a new variable and call it sender and set its value to your name. Then in the email template string, you are to use your center variable instead of pair. So you're going to replace this text with your variable. Then just run the code and you will verify that it works through the console log. Good luck. Okay, let's do this. We'll create a const, call it sender, and I'll actually set it to my entire name here, Harold, Oregon, so that we can see that it actually works when we log it out. Escaping out of the string and do sender like that, run this. Yes, now we are logging out my entire name at the end of the string. Great job. Big benefit with template strings is that you can break them into multiple lines, which is really handy. For example, in our email case here, you'd most likely want to write this on multiple lines, like have the hey in one line and have the text in one line and then the cheers in the final line. And this is possible, unlike with regular strings, like we're using here for my name. To prove that, let's actually try to break this into another line. What you see here is that we get these red underlines and the syntax highlighting has been completely broken. And if we try to run this, we'll see that we get a syntax error. So obviously not something we can do. We have to get it back on one line. But for our template strings, it will work. And that is the challenge as well. I want you to break the email string into multiple lines, however you think it makes sense to do that. And then you are to run the code to see that it works. However, there's a gotcha here, which is that in the Scrimba console, you will only see one line regardless of how many lines the string actually consists. Here is an example where I've created this random string, which is on 3 different lines. You can see that in the Scrimba console, we're logging it out on a single line. Whereas in the DevTools, which I've opened here, in the console that lives in the DevTools, it is indeed logged out over 3 lines. So this is a quirk with the Scrimba console. It's not as robust as the Chrome console, basically. So for this challenge, you'll have to open up the original browser console in order to verify that you've done it correctly. And if you don't know how to open the developer tools, I will show you now. When you're in the Scrim, move your cursor up to the header area of the Scrim, then right-click so that you open this menu, click on Inspect, and that'll open up the developer tools. Make sure you are on the Console tab. Now, of course, this is how it works in Chrome, and I'm on a Mac computer myself. So if you are on a different operating system and using a different browser, it might be slightly different ways of opening up the console, but that shouldn't be a problem. If so, you just need to Google it out, how to open the console on Windows using Firefox, for example. So go ahead now, break the email string into multiple lines, log it out, and then open the console to verify that you've done it correctly. Okay, hopefully that went well. The way to do this is super simple. You can just break this into a new line, this into a new line, and actually we can even do this. And sometimes I even like to format this as we're writing a function body or HTML so that I tab it out so that we see it like this. But you could do it like this if you wanted, or you could do it like this. I mean, the point here wasn't exactly formatted the way I would do it. The point was just to break it into new lines, run the code, see that in the Scrimba console, it is still just one line. Hopefully you saw that when you logged it out in the original console, it became multiple lines. Great job. Okay, we are back at our Chrome extension app, and now you are going to do the same thing I did before we went on our little tangent about template strings, which is to take this list items and turn the string here into a template string, so that you can get rid of all of these pluses, all of these double quotes, and also break it into multiple lines if you want. So go ahead and do that right now. Okay, hopefully this went well. Let's do it together. Start by replacing the outer quotes with backticks, and then I'll just go ahead and break it into multiple lines to get better readability, like that. Now I can easily see that it's a list item, which wraps an anchor tag. I'm going to put this on a new line. And here we still have these clunky plus signs. I'll remove all of those and wrap the JavaScript expression here in a $sign and the bracket like that. And then do the exact same thing here. Well, like that. Even break this into yet another line. So now it looks much better. And if we run this, it still works exactly how we want it to. So let's move on. Now, let's take a little break from JavaScript and head over to our index.css file, because I want you to style our list according to the provided design. And here is the provided design. You can see the links have the same color as the rest of our app. We don't have the bullet points, which you can see are here in the current example. So I want you to fix that. And the three selectors you are to use are the UL, LI, and the anchor tag. And I've set them up for you. So you just have to write a few CSS properties and values inside of these. And then once you're done, return back to the screencast, because then I also will show you my solution. Okay, let's do this. The first obvious thing is that our list in the design doesn't have these bullets. And the way to remove those are to do list, style, and then none. As you can see, they are gone. Now, it is the space on the left-hand side, namely the padding, which we have here, which you also want to eradicate. So we'll do padding left and set that to 0. All right. Next up, the most obvious thing is the color of the anchor tags. It should be the green one we have already in our app. So let's fix that. We'll do this one right here and select the anchor tag. Color should be that. Yes. Pretty good. Let's compare the two now. What I think is that we have some more spacing here. There's more spacing between the list items and also a little bit more spacing above the unordered list. So starting with the unordered list, I think we can give it a margin top of like 20 pixels, slightly down. And for the LI elements, I think we can give them also a margin top, maybe then 5 pixels. Yeah, now they have a little bit more space in between them. So I think this looks pretty good. So this challenge is done. But before we move on, there's one thing I want to point out. And that is that we are using very broad selectors for our CSS. We're basically selecting any unordered list or any list item or any anchor tag on the page. And this comes with the consequence that if we, for example, want to add other anchor tags in our app that are outside of this list of leads, for example, let's say we added an anchor tag in the very top of our app, kind of like a navigation. If we run this, you can see it says home and we add awesome lead. It's in the same styling as awesome lead. This might not be what we want. Oftentimes, anchor tags and links will look slightly different depending on the context they were shown in. What we could do to solve this problem would be to, down here, when we are flipping the color, specify that we only want to do that if the anchor tag lives inside of a list item. And we'd solve that by doing LI and then a space and then the A. Now you can see the home link has the standard styling, whereas the anchor tag in our list has our green styling. So this is a way of saying only target anchor tags that lives inside of list items. However, in this case, we can get away by just targeting our anchor tags, as we're not planning to add any other anchor tags across the page. So we can remove our home tag and then just target this list item in the easiest possible way, which is what we have here, as that's perfectly fine to do as long as we're understanding the future possible consequences of doing that. And now I think we do that. So let's just move on. So even though we haven't completed our app yet, there's still many features left to build. I want to go ahead and deploy it right away, because I just think it's so much fun to actually see your app out in the wild, and that gives me a ton of motivation to continue on, which is why I often like to deploy my projects as early as possible. So in this cast, we're going to prepare our first deployment so that we in the next cast actually can do the deployment and try our app out in the Chrome browser. As you can see on the left-hand side here, I've added a couple of new files, namely the icon.png. That's just a PNG image, which looks like this little icon right here. Pretty suitable for our app with this $sign as our sales representatives are to be reminded that this app will bring in more dollars for their commissions. Also, you'll see a manifest.json file at the bottom here. And you might wonder, well, what is JSON? I've never seen that before. And you're right, we haven't talked about that earlier, but don't worry, it's nothing dangerous. JSON is short for JavaScript object notation. And it's a way for us developers to store and send data. And it's often used when you, for example, want to send a piece of data from a server to a client, that is, to a browser. And in our case, we are using this manifest.json file to configure our app and to provide metadata about it. So Google Chrome will read through this and look at the name. Oh, it's called Leads Tracker. Well, then Google Chrome will give our app the name Leads Tracker. It'll also see that the version is 1.0, so that the next time we deploy and we change this to, for example, 1.1, it'll know that, oh, we have updated our version. And that's information that's definitely useful to know for Google Chrome. One thing you might wonder here is why these key value pairs, as you can see, which you hopefully recognize from JavaScript objects, have keys that are wrapped in quotes. Because if you remember from when we worked with JavaScript objects previously, we didn't use quotes around our keys, but that's something you have to do when writing JSON. So don't be tempted to think that this actually is a JavaScript object right now. It's not, it's just plain text, but it's using the JavaScript object notation. So it's mimicking a JavaScript object, and you later learn how to turn a JSON object into a JavaScript object. If this is a little bit confusing, don't worry about it. It'll sort itself out as we look more into this. Let's just move on and look at the two final key value pairs here. We have manifest version. That's just telling Chrome which version of this JSON file we are using. There used to be a version number 1 that people used, and then there was a version number 2, but now we have a version number 3. So that's version number 3. And finally, there's the action. And that's kind of the meat of our application. It configures what happens when the user clicks on our application from the Google Chrome extensions toolbar. Let me show you that. Here we have Twitter. And if I click on the extensions button up here in the top right corner, this little puzzle piece, you can see it opens up all of my extensions. And when I click at, for example, Grammarly for Chrome, it opens up the Grammarly extension. And as you can see, it uses a little icon here as well. So in the action, the default icon that you provide, this icon PNG here, which points to this image file we've provided, will pop up here besides this puzzle piece button. And also the default pop-up, the index.html that we provide inside of our action, well, it's our pop-up. And in our case, it'll simply be the HTML we have been building all along. Now, there's one thing we need to fix, which is that a Chrome extension will only be as wide as it needs to be. And strictly speaking, our app doesn't need to be any wider than this, because that's the width our button needs. So we need to set a min width on the index.css. And I'm just going to go ahead and do that. Min width of 400 pixels, for example. Now you can see if we go below 400 pixels, our input field is now outside of the app. So Google Chrome will understand that we don't want that. We want our app to be like this. This is the minimum size. So now we finally have everything in place. Your next step is to download this code. You do that by clicking on the settings icon in the bottom right corner and download as zip. That'll download a zipped folder. You can then open that zipped folder, for example, in your dev directory, and call it whatever you want. Here you can see all of the files that you recognize, along with a README file, which you can safely ignore or delete. That's up to you. And when you have that, we are ready to deploy our Chrome extension. So let's just move on to the next cast to do exactly that. Okay, it is time to deploy our application. And I'm so excited about this because I just love seeing products move out into the world and start solving problems for people. So let's just jump into this. The first thing you need to do is to head over to Chrome-//extensions. That'll bring up this UI you can see right here, which lists out all of your extensions. Now, this address here is a little bit funky, so you can just copy it from the file right here and paste it into your address bar if you want to do that. And once you're there, I want you to trigger the developer mode on. So just click up here in the top right corner, and then you'll see these three buttons appear: load unpacked, pack extension, and update. And you are going to load an unpacked extension. So click that button. That'll bring up the file chooser menu. There you are to navigate to the leads tracker folder that we downloaded from Scrimba in the previous cast. Choose that folder and hit select. And once you've done that, boom, your lead tracker is now in the extensions interface. And actually, that's it. Now, if we open up another tab, for example, I'll open up the LinkedIn profile of Frode, one of the co-founders of Scrimba, and then I can click on the puzzle icon here in the top right corner. That'll bring up all my extensions, and there we can see our lead tracker. That is just so cool. You can see the little icon here, and if we click it, it brings up the user interface for our app. So that is amazing. Now I can, for example, write in the URL we're at the moment and hit save input, and there it is saved. So actually now we have something that you can take with you on every website you visit and save information. But our app has a critical flaw. Because if I now close this app, if I click outside of our HTML file and it closes automatically, and then want to open it up again, actually our leads have been deleted. Because that's just as if we were saving something to the input here, and then seeing it in the list, and then refreshing the page, and boom, it's gone again. So every time we open up our Chrome extension, it's a full refresh. So we need to learn how we can store data across page refreshes. How do we do that? That's not something you've learned yet, but it's not that hard. So over the next few casts, I'm going to teach you exactly that so that our app becomes truly useful for salespeople who need to traverse the web and gather leads. So let's just move on and get that sorted out. So in order to fix our problem of storing leads across page refresh, let's actually open up a browser window and see if we can find a way to do this by playing around with the developer tools. So here I have wikipedia.org. I'm going to right click and then hit the inspect so that we open the developer tools. Here we're starting out at the elements, so we see the HTML elements of the page. But where our action happens is over in the application tab. So I'm going to click that, and there you can see we get a new list of fancy words here on the left-hand side. Service workers, storage, local storage, cookies. Some of these names you might have already heard before, and they're probably a bit scary. And to be honest, you don't need to know about any of them at this point. What we want to look at is this one right here called local storage. Because when we click that, we can see it says wikipedia.org here, and if we click into that item as well, it opens up this table here on the right hand side where we have keys and values. And that's something you probably recognize from JavaScript objects, for example, or even the JSON notation. Here you can see that Wikipedia has created 3 weird looking keys and given them some values. So it seems as if Wikipedia is trying to store some value about me, because these values here in local storage will only be available for me. They are local to me. When I visit this domain, this data isn't shared by default with all other users who visit Wikipedia at this point. For example, you can see portal session ID, some weird long string. That's probably totally unique to me. But without getting into too many details here, what's important is that this is kind of like a local database that we can use. So let's try to do that. If we hit on the console tab, and open up the console, which you've previously seen, and then type in, for example, local storage.clear, and open and close parentheses to call that function, and then navigate back to the application tab, you can see that we have cleared out all of the key value pairs in our local storage. So we were able to interact with these values using JavaScript. Going back to the console, we can yet again, for example, do local storage.setItem, and then pass in first myLeads as a string, and then comma, and then I'm going to pass in the string of the URL that we visited previously, that is Frode's LinkedIn profile, and then hit enter. If we now go back to application again, you can see that we have a key value pair in our local storage. The key is myLeads, and the value is the URL to Frode's LinkedIn profile. And what's so cool about this, if I now try to hit the refresh button, what you'll see is that yet again, Wikipedia adds back these 3 key value pairs, but the myLeads key and its value persists. And that is exactly the feature we're looking for. Persisting data across page refreshes. So with this in mind, let's move on and try to interact with the local storage from our index.js file in the next cast. So I'll see you there. So now we are going to use local storage in our app. And we do that in the exact same way as we did it using the console on wikipedia.org. However, we're writing it in our JavaScript file. That means that we can simply use the local storage variable. That is accessible in the so-called global scope. So when you're running JavaScript in a browser, you have access to this variable wherever you are. We'll then do set item, open and close parentheses, and then we'll first write the name of our item. We'll call it myLeads. Then we'll specify the value. Here I'll just do example lead.com. So this is the key and this is the value. If I now run this code, nothing seems to have happened, but if we actually delete this entire line and even rerun the browser again so that we know that the only way to get a hold of that data would be if it is persisted in local storage, and then try to do exactly that by doing local storage.getItem, passing in the name of our item, the key, and that was myLeads, and then we console log that out. Running the code, there we go. ExampleLead.com is logged to the console because our browser remembers that we previously saved a lead under this name, and now we can get it. That is pretty cool. It opens up so many possibilities. Now I want you to try this. You're going to solve a 3-part challenge. First, you are to save a key value pair in local storage in the exact same way as I did, and then you are to refresh the page, and then get the value and log it out to the console. Finally, I want you to clear out the local storage as well. And as a little hint, I have added the 3 methods you are to use down here. Local storage.setItem, passing in key and value. GetItem, passing in key. And clear, which clears out the entire local storage. So you need to use all of these 3. And one little gotcha before you take a stab at this. Both the key and the value that you pass in here and here need to be strings. That's a limitation with local storage, meaning you can only store strings. So it is a very primitive database, but it's what we got. So give this your best shot and then return back to the screencast if you want to see me do it yet again. Okay, let's do this. First, we do local storage.setItem. I'm going to call this one my name and set it to Per Harold Organ, like that. I'm going to run the code so that now, hopefully, this has been saved, meaning I can actually comment it out because we don't need it anymore. Now I can do local storage.getItem and then pass in my name like that. Actually, I'm going to store this in a variable called name, just as a little bonus here, and then console log out the name instead of just console logging out this expression. When we run this, you can see, yes, we are logging out my name. Good stuff. Let's move on to the final part of the challenge. I'm going to comment this out, and then I'm going to do local storage.clear. Now, if I run the code, apparently nothing has happened, but if we now comment these 2 lines again and run it, null. So my name no longer exists. Well, that's great, because that's exactly what we tried to do by clearing out local storage here on line 11. So as far as I can see, local storage really seems to do the job. Let's move on and learn how to use this properly with our myLeads array so that it's implemented into our app and gives us that ever so important persistence feature for our leads. Now, there is one issue with storing our leads in local storage as an array. And that's something we'd be aware about if we, for example, were to head over to Mozilla Developer Docs to read a little bit about local storage. Here you can see the window.localStorage page. The reason it says window here is because local storage actually exists on this window object. But you can also use the local storage variable directly. And when writing code in general, I would say that less is more. So that if I can write less code, I will do that. That's why I'm omitting the window dot syntax. Anyway, here we can read that the local storage read-only property of the window interface allows you to access a storage object for the document's origin. Oh my god, that's just really complicated in my view, especially for a beginner. So let's scroll a bit down and read about what it actually does down in the description. The keys and the values stored with local storage are always in the UTF-16 DOM string format. What the hell does that mean? I mean, UTF-16 DOM string? That is some hardcore stuff, but we are not going to worry about all that. The only thing that matters is string. We at least know what that is. And as you can see here, as with objects, integer keys are automatically converted to strings. Okay, so it seems like actually everything that is stored inside of local storage has to be strings. Well, that's a problem because we were expecting to store this array here. So how do we do this? Well, to get someone to explain this to us in an easier way, I would just Google out our problem, store array in local storage, and look for the first Stack Overflow question. How do I store an array in local storage? Okay, that's our problem as well. And instead of fine reading the question, I just jump to the answer immediately because I'm impatient. And there you can see a very straightforward explanation. Local storage only supports strings. Use json.stringify and json.parse. Okay, here we can see some code. And we recognize this local storage.setItem and then passing in the key. And then instead of just passing in the value, which here should be the names array, they are doing json.stringify and passing in the names array in that. So it seems as if this json.stringify takes the array and turns it into a string. And likewise, on the other side, when they are to fetch data from local storage, they use local storage.getItemNames, but then wrapping that entire expression into json.parse. So that seems to go the other way around, from string to array. Okay, so actually, let's just try this. Let's pretend that this is our array in local storage. We have one lead here. And as we read in local storage, everything is strings. So we have to turn this into a string, and we can use that with the backticks like that. Now this is a string. And the problem here would be that, let's say that we fetch this from local storage and we want to push another lead to the array. And we try to do that with myLeads.push epiclead.com. Run this. We get an error. myLeads.push is not a function. That is because the push method doesn't exist on strings. It only exists as a method you can use on arrays. So what we then have to do first, here we've gotten the data from local storage. Now we need to do what our friend over at Stack Overflow did, which was to parse the entire thing. So we can do myLeads equals json.parse and then pass in myLeads here. Now, after the push, log out myLeads, run it. Yes, now we can see, now it worked. How about if we wanted to go the other way around? This here, where we're actually stringifying the array so that we can save it in local storage. Well, this would be this situation here. We do myLeads equals json.stringify, and then passing in myLeads. We now run this code. In the console, it kind of looks like an array, so maybe not the best example. But what we can do here is we can do type of before myLeads. Then we'll ask JavaScript to tell us which type is this variable here. If we run this, you can see we get string. So by using the so-called JSON methods, that is the stringify and the parse, and passing in our data, we can flip back and forth between strings and arrays. And also, obviously, if we used a JSON object like this with the curly brackets, it would turn it into a JavaScript object and the other way around. And that's actually a more common use case. But in our case, we have an array to work with, and it does the job perfectly well for arrays as well. Okay, now it's your turn to practice. I'm going to turn this back into a string and give you a set of instructions. Okay, you are going to do these 4 steps. First, turn the myLeads string into an array, then push a new value to that array, then turn the array into a string again, and finally, console log the string using the typeof that you just learned to verify that it's actually a string. So go ahead and give this a shot right now. Okay, hopefully this went well. Let's do this. First, we'll do myLeads equals json parse, passing in myLeads. That should turn it into a proper array again. Now that we have it as an array, we can do myLeads.push e2.com. Okay, we have to turn it into a string again. We do myLeads, reassigning it to json.stringify myLeads. And finally, console log out type of myLeads. Run the code, and we get string in our console, just as we wanted. We have gone from string to array back to string again. Great job. Now you are going to implement the first part of our local storage feature, and that consists of saving the myLeads array to local storage. So that should happen here on line 11, right after you've pushed the new lead to the myLeads array and cleared out the input field. Then we are ready to actually save it to local storage. And you have to remember to use the json.stringify when saving it, even though the browser we're using might be kind to us and actually do this for us if it notices that we haven't done it. We want to be explicit about this so that we remind ourselves that we know the difference between working with just plain text or a proper JavaScript array. So remember to do that. And once you've written your solution, you should run the code by filling out the input field and hitting the save input button, because this line at the bottom of the function will also be run, and it heads into local storage and gets the item that is called myLeads. So if your implementation has worked, this console log should log out whatever you've saved to local storage as well, because myLeads is actually the key we want to use in order to save our array. So use this as the key. So go ahead and do this, and I will of course show you the solution when you return back to this cast. Okay, let's do this. First, we'll do local storage dot set item. And here we first need to specify what key we want to save our item under. And that is, as I said here, myLeads. So we'll do myLeads, and then a comma, and then what we actually want to save. Now, you might have been tempted to simply do myLeads like that, grabbing the variable called myLeads. But as I said, we need to use JSON stringify to turn this into a text string. So we'll do json.stringify and wrap the array inside of the parentheses of the stringify method. There we have it. Let's run the code. Try to add a lead, hit save input, and there we go. As you can see in the console, we are indeed logging out something that looks very much like an array with one item of awesome lead, which is exactly what we wanted. Great job, let's move on. So now we are able to set items in local storage, aka we are saving leads to local storage, so that we can, for example, do awesome lead and epic lead, and then see that yes, they are indeed logged out because we have fetched the item from local storage here. And actually, you can even open up the developer tools here on Scrimba and click down to cw0.scrimba.com, and there you will see myLeads as the key and the values as well. And the reason it's cw0.scrimba.com is because that's actually the domain for this mini browser under the hood. However, that's Scrimba magic. Don't worry about that right now. Just know that you can access it by choosing that domain. Now, there's one big problem here though, which is that if we now refresh this page again, boom, our leads are gone. Or actually, they're not gone. They still exist down in local storage. However, we haven't written the code for heading into local storage, fetching out the leads, and then displaying them when we are refreshing the entire page. We're actually not doing anything. We're just setting the myLeads array to an empty array, and we're not even triggering the render leads. So there's multiple things we need to fix up here. But we're going to start small as usual. You are going to basically just try to get the leads from local storage, and then store that in a variable, which I would call leads from local storage, and then log out this variable. So now I'm going to close the console. And before you go, I want to remind you about the json.parse method that you learned earlier, because you want to use that to parse the string you get from local storage so that you turn it back into an array. This might be a little bit difficult, but just give it your best shot, and then I will show you how to do it as well. Okay, hopefully that went well. Let's do this. We're going to do more or less the exact same thing we're doing here to begin with, which is basically local storage.get item, passing in myLeads. However, we need to parse this. So I'll do json.parse, and then parentheses around this inner expression right here, and then store this in a variable called leads from local storage, like that. Now we can console log out leads from local storage. If we run the code, and you can see there we are logging out the array with the leads that we know that we had here in our local storage. If I now do local storage.clear right above this line and run it, we get null. And now you're probably wondering, well, what the hell does null mean? And as you learn in the next lesson, null is a so-called falsy value that we developers use to signalize emptiness. And here, the developers behind local storage, that is, the people over at Google who have implemented local storage into Chrome, have made it so that it returns null when we ask for a key that doesn't exist. And actually, this is the case for all browsers because they have followed the same specification. However, this means that we'll end up in a situation where this variable, leads from local storage, is either null, which as I said is a falsy value, or it is an array, which is a so-called truthy value. So we're in a situation where we have to act upon a variable that is either truthy or falsy, which is not the same as true and false, meaning we have to dig deeper into what exactly truthy and falsy means, and we'll do that in the next lesson. Okay, so let's learn about truthy and falsy values. So let's say that we, for example, have a slot machine app. So we have const credit. That's how many credits you as a player have. And then we need to check if credit is more than 0. Well, then you're allowed to play the slot machine. So we'll log out let's play with a slot machine emoji. And then else, this means that your credit isn't over 0. So that means that you have to be at 0. Then we'll console log out. Sorry, you have no credits. Like that. Now, if we run this one time, you can see, sorry, you have no credits is logged out because credits was 0. This would evaluate to false. Credits is not more than 0, meaning JavaScript would jump to the else clause. However, if we change this to 12, then this expression, 12 greater than 0, would evaluate to true, and this block of code would be run. Now, JavaScript isn't really that strict about what you shove into the condition here. Actually, if we only shoved in credits like that and try to run this again, you can see that we are still logging out let's play. So even though this would be evaluated to 12, when it's shoved into a conditional statement as this, JavaScript will then again translate 12 to true. Likewise, if credits is 0 and we run the code, you can see, sorry, you have no credits is logged out because this would be translated to 0 first. And then JavaScript would say, oh, no, that's a falsy value. So I'm going to translate that to false. So where you before learned about true and false values, you now have to understand truthy and falsy values. Let's try another one. For example, YOLO, just a string. What do you think that will be? When I run this code, what will be logged out? Just take a guess. Okay, let's run it. We can see let's play is logged out. In other words, YOLO, or this string right here, is a truthy value because JavaScript turns this into true in the condition. And as well, if we pass in an array of random items, run the code, that is also a truthy value. Okay, let's try another one. Let's do an empty string. Run the code. Oh no, that's a falsy value because it got translated into false, meaning this block of code didn't run. JavaScript jumped to the next block, the else clause, and logged out, sorry, you have no credits. So let's go back to just adding credits here so that our if-else makes sense. And then at this point, you might feel that truthy and falsy values is really complex because how will you keep track of all of these truthy and falsy values? It seems like there's a ton of things to remember. Luckily though, it's not that hard. You essentially have to remember these 6 values. They are the falsy values in JavaScript. False, 0, an empty string, null, undefined, and this weird thing right here, nan, short for not a number. And out in the real world, inside of conditionals, in most cases, you'll work with either false, null, or undefined. So actually, this nan here is rarely ever used, which is why I'm not going to talk anymore about it. Null and undefined, though, deserves a little bit of time, because a lot of developers are confused about these two, and they mix them together. Now, let's look at the similarities first. They are both primitive data types, just like strings, numbers, and booleans. And they're also both ways to signalize emptiness. However, on a high level, the core difference is that null is how you as a developer signalize emptiness, whereas undefined is how JavaScript signalizes emptiness. So you will use null as a developer. It's a useful tool, whereas undefined is something you'll be exposed to because JavaScript will tell you from time to time that what you're looking for is undefined. Now, let's see this through the lens of an example, as that'll help us see the difference between the two. Like, you'll sometimes see developers declare variables and assign them as null. Let's say you are creating a live streaming app and you have current viewers, and that's set to null, meaning that no people are watching the live streams at the moment. However, a bit later, a few viewers might pop up and you might want to do current viewers equals, and then an array of Jane and Nick, like that. The reason this can be a useful way of describing the situation in terms of how many people who are watching the stream is because you might want to act upon whether or not there are people in the stream. So if current viewers, then you might want to do something. For example, notify the live streamers that people are watching. So go ahead and turn on your live stream. Console log, we have viewers, like that. Now, this block of code will only fire if current viewers has been set to an array. So now you can see it'll be logged out. And let's say you a bit later lose all the viewers and you set it to null. We run the code. Nothing happens, because null is a falsy value, meaning that this will be false, whereas the array here is a truthy value. So when current viewers equals that array, it's set to true, and this block of code is run. Now, here you can see that null is a useful way of signalizing emptiness, because an empty array wouldn't do the trick. If we run this code, you can see we are indeed logging this code because current viewers is an empty array, which then again evaluates to true. So it's better to use null here. That was how you as a developer can signalize emptiness and act upon whether or not a variable is empty. Let's now look at undefined and see how JavaScript uses that to signalize emptiness as well. And we can do that by simply removing everything except let current viewers. If we now try to console log current viewers, which has been declared but not assigned to a value, when we run this, we'll get undefined. So JavaScript tells us that this variable is undefined, or kind of like empty. Likewise, if this, for example, was an object and you try to log out a key that doesn't exist, random key using the dot syntax, you'd also get undefined. JavaScript tried to look for this, but it was completely empty. Here, if it is an array with one item, and you try to look for the item at index 5, run this, again, JavaScript says undefined. So this way, when you see either null or undefined in your codebase, it should provide you with a hint as to whether this is JavaScript trying to signalize emptiness, or if there's a developer who's written that code and has tried to signalize emptiness. So that was a long walkthrough of the differences between null and undefined. There's more to it also, but I don't think we need to dig deeper than this. Let's wrap up this cast, and in the next one, I'm going to teach you a neat little trick to check if a value is truthy or falsy, which you can use whenever you are in doubt. Then I'm going to stress test your truthy and falsy skills. So let's move on. If you ever wonder whether a value is truthy or falsy, you can check it through writing boolean, open and close parentheses, and then pass in whatever value you want to check inside of those parentheses. So here we'll do hello. Let's store this in a variable called true or false. Now console log true or false. From the code, you can see that we get true, meaning that hello evaluates to true. Removing the content of the string, running it again, we get false, because as you hopefully remember, an empty string is a falsy value. Now, with this in mind, you are going to do a set of challenges, which I said in the previous cast. Here they are. It's 6 console logs, and inside of them, we are checking a bunch of values for their Boolean value. So each of these lines will log out either true or false. And your job is to here, after these 2 slashes, write either true or false, depending on what you think will be logged out. So go ahead and give this a shot right now. Okay, let's do this. So an empty string, as we remember, that is a falsy value, so this will log false. Here, I'm trying to trick you because 0 is indeed a falsy value, but this is a string which contains 1 character. It's not 0, so this will be true. Here, 100, that's a truthy number. Null, hopefully you remember that that is a falsy value, so this will be false. And here, I'm also trying to trick you. 0 wrapped inside of an array, whilst 0 is a falsy value, an array is a truthy value. So this will be true. Here, minus 0, 0 is a falsy value, and whether it's minus or plus 0 doesn't change that, so this should be false. Let's run the code, and we get false, true, true, false, true, false. Correct. Now we'll return back to the Chrome extension, and you'll use these truthy and falsy skills in order to build a conditional for the leads we have stored or not stored in local storage. So let's move on. So now that we're able to check if we have any leads in our local storage, and if so, we parsed those leads so that we get them as a JavaScript array, we are ready to act upon whatever data we get here. And first, let's then look at what kind of data we can get, because there's essentially 2 situations we need to account for. One is this one right here, where the myArray in local storage gives us back some data, for example, this array right here. If so, we have something to work with, and we can render it out instantly. But then there's the other situation, which is the one right here, where actually there's no data in the myLeads key in local storage, and actually the key doesn't even exist. If so, we know that we get back null. So that is a falsy value, and this is a truthy value. So then the question is, what are we going to do in these 2 cases? Well, if the value is null, meaning that there's no leads stored in local storage, well, we're not going to do anything, because there's no point trying to render out any leads if there's no leads that are saved there initially. So then we're just going to ignore it, not do anything. But if we find a couple of leads, if we get an array back from this expression right here, then we need to first set myLeads to whatever leads we are returning back, and then call the renderLeads function, because the renderLeads function takes the leads in the myLeads array and renders them out. Because of course, that's what we want to do. We want to show the user whatever we found in local storage. So here is the challenge formulated. First, check if leads from local storage is truthy. That's this variable right here. If so, set the myLeads variable, this one up here, to its value. And by that, I mean the value of this variable right here, the leads we have fetched out from local storage. And then call renderLeads. So this might be a little bit of a difficult challenge, but give it your best shot, and then I will show you the solution as well when you return back to this screencast. Okay, hopefully this went well. Let's do this. We'll do if leads from local storage. That's actually everything we need to do, because this evaluates to either a truthy or a falsy expression. And if it's a truthy, this code will be run. If it's a falsy, then JavaScript will just jump over all of these lines and continue down here on line 16. So inside of here, we are first going to set myLeads to this newly value we've just fetched out. myLeads equals leads from local storage. And then we are going to render leads like that. If we run this now, you can see nothing happens. That's because at this point, local storage is most likely null. Let's just log it out to verify that. Yes, we're indeed logging out null. What we then can do instead is actually add awesome lead and epic lead to our list. And now both of these should be saved in local storage. We should be in this situation right now. So if I refresh, yes! Now we have persisted our leads across refresh. That is so cool. So give yourself a pat on the back. You should be so proud of yourself reaching this far. You're now working with a small database, basically. And that's a huge step towards becoming a professional developer. Now we need to fix the fact that we can't delete our leads, because obviously that's a feature we need. Let's say that I'm a sales development representative and I'm gathering leads like this. I have 4 leads at this point, and now I want to go ahead and contact these people, or maybe move this data over into a spreadsheet, for example, so that I again can go out to the World Wide Web and churn through leads on LinkedIn and save them to my Chrome extension. Well, then I obviously need to get rid of these existing leads, so that I get a clean slate to start with. But now that's not possible. I can refresh this as many times as I want. It'll just continue to store my leads. So we need a delete button. We need something that looks like this. And that is what you are going to do. In this challenge, you are going to style this delete button. And then later on, we're going to write the code for its functionality as well. But first, we have to create the button in the HTML. And I'm just going to do that for you. So like that. Delete all. And as you can see, if we render this out, you can see that it's actually looking pretty good already. It has the default button styling that we have added in our CSS here, but we want it to be kind of the inverse of the save input button so that you properly see that it's something different. And in order to target that button, we need to give it an ID of delete-btn, like that. Now, before you start writing your code inside of the delete btn selector right here, I am going to do one change on the button as a whole. Because actually, this button, which you can see in the slide, has slightly different styling than this one here. And that is that the border is actually not none. It's actually 1 pixel, solid, and then this green color, like here. Now you can see both buttons got 1 pixel added to its border. If I remove this, you'll see that the buttons become slightly smaller. They shrink in slightly, like that, with 0. And they become a bit larger if I do 1. And let's just try a different color here. Do red. There you'll clearly see it with 1 pixel and with 0 pixels. We want 1 pixels of the green color, because that's needed to get this green border around this delete all button. So now we are ready. You are to style the button according to the provided design, and you're only going to apply the styles inside of this delete btn ID selector. So go ahead and do this, and then of course I will show you the solution as well when you return back to this screencast. Okay, hopefully that went well. Let's start. The first obvious thing is the background. It should be white, not green. So I'll do background, white, like that. Okay, now we also seemingly lost the text, but that's not the case. It's just white, so it blends in with the background. So we need to change the color as well. And for that, we're going to use this green color up here and paste it in. And there we go. As easy as that. With that, let's move on. Now we are going to make our delete all button actually work. So you'll do that through a 3-part challenge, pretty big one actually. But first, I'm going to give you a little mini challenge. And that is this leads from local storage here. Should that be defined as a let, or do you think we should change it to a const? Just look at what we're doing with it down here on line 8 and line 9, where we are using it, and take your best guess as to whether we should change it or not. And the answer is that, yeah, actually we do want to change this to a const, because we're not reassigning it here. And if you remember from previously, it's a good practice to, if you can use const, then use const, because it enforces strictness throughout your code base. When another developer comes in here, or you in 2 months, and looks at this leads from local storage and see, oh, it's a const, then I know that this will not be reassigned further down in the code. So that was just a little digression so that we got to clean up this little variable inconsistency here. Now let's move on to the major challenge. As I said, it's 3-part. First, you are going to grab a hold of the delete button and store it in a delete btn variable. Then you are going to listen for double clicks on the delete button. And if you don't know how to listen for double clicks, you should just Google it. Finally, when the button has been clicked, that is double clicked, you should clear the local storage. You should clear out the myLeads variable, that is this one up here, and you should also clear out the DOM so that the user doesn't see any more leads on this unordered list. So, a pretty big one, but give this one a shot and return back to me when you want to see my solution. Okay, let's do this. I'll start up here. We'll define a const, delete btn like that. We'll do document dot get element by ID, passing in delete btn. So that is indeed what we had right here. Then let's move on. We are going to listen for double clicks on the delete button. And how do we do that? Well, let's Google it. I think it's a good idea to Google addEventListener and then just double click, because as you know, it's the addEventListener we are using. By doing this, we get the Mozilla developer docs as the first result. Clicking into that, and I always scroll as fast as I can to the example. I think it's a lot easier to learn from that rather from textual explanations. Here we can see card.addEventListener dbl click. Pretty nice. So simply delete btn, addEventListener, and dbl click, like that. Let's then also do the function. And now let's just console log, double clicked, like that. We'll run the code, double click on delete all, and yes, it worked. If I try a single click, nothing happens. But double click, yes. Okay, good. 3, when clicked, clear local storage, the myLeads variable, and the DOM. Okay, let's do this one by one. Local storage, if you remember, the way to clear that was local storage dot clear. Okay, myLeads, how do we clear that one? Well, we actually reassign it by doing myLeads and just setting it to an empty array. And then finally, clearing out the DOM. How do we do that? Well, actually, the trick is to simply render out the leads, which now are just an empty array. So we just trigger the render leads function. Render leads, like that. Let's rerun this, and now try to double click on the delete all. Yes! Now we removed everything in the DOM, and we have cleared the local storage. Our array is empty. We have a working delete button. We can delete this console log here. Great job doing this challenge. Let's move on. Now that we have an app that actually works pretty well, we're going to do something we haven't done a lot throughout this course, which is to refactor our code. And not only refactor it based upon a current need, we're going to refactor it based upon a hypothetical future use case. So for this, we're not going to use the mini browser, so I'm just going to minimize that one. And actually, I'm also going to take this function render leads and move it up here right below this conditional, because it is the render leads function we're mainly going to refactor. And the reason for that is the following. This function now currently has a very low degree of what we would call reusability, because here it is hard-coded that whenever it's called, it's always going to look at the myLeads variable, the one we've created up here, our global variable, and render out whatever exists in that array at that point in time. Now, let's say that we one time in the future also have another array. For example, let old leads, perhaps just a bunch of slightly unimportant leads that you've shoved into this array that you don't want to render out at any given time, but you want to perhaps have the opportunity to bring them up from time to time. If so, we would struggle to render them out. Because, as I said, in our render leads function, we only care about the myLeads array. So what we can do instead is to make this function a bit more dynamic and have it render out whatever array we tell it to render out. And the way we do that is to pass in a variable as a so-called argument when we call it. So we could take myLeads here and then pass it in like this in between the parentheses so that it would be possible for us to use it inside of the body of our function, but without referring to myLeads directly like this. Now, let's just pause here for a minute before we rewrite the body of the function, just in case this seems weird, because you might feel you're walking on thin ice here, but actually, you've been passing in arguments into functions when you have called them for quite a while now. Because that is exactly what you're doing up here, for example, the getElementById function, which you are calling and giving it the string of inputEl, so that this function, when it does its magic and walks through the HTML file in the search of its element, knows when it hits this point, here it is. This is the element I'm looking for, because Pierre told me so when he wrote this code. He told me that this is indeed the ID he wants. Hadn't we done that, well, the function would have been like blind to whatever it was looking for. Wouldn't be able to recognize this element. But we did, of course, give it that value. And that is also what we're doing here now. We're telling renderLeads that we want you to render out this data right here. And then to make this work, we also have to here write something like leads inside of the parentheses here as well. The way this works is that when this function is called with this data passed in, this data, this array, will become this variable here, which is accessible inside of the body of the function. So now we can replace myLeads with leads here, and we can replace it here and here. At this point, the body of this function has no idea and no relation to this myLeads global variable up here. It only cares about what you entered into the function when you called it. And now what actually makes sense is to skip the usage of the word leads in the name of the function, because actually the function at this point doesn't even know that it's rendering out leads. It could be rendering out a bunch of names of soccer teams or a list of fruits or whatever it is. It renders out whatever you pass into it. So actually what we want to do is remove this leads here and simply call it render. Now this of course requires us to do the same thing on the delete button. Here we'll use the new name render, and we have just cleared out the myLeads array, so it's an empty array. So what we'll do is simply pass in myLeads here as well. And finally, on the input button, when we add new leads, we have also modified the myLeads array. So we'll take that and paste it into the parentheses of the function invocation, and then of course use the updated name as well. So now we have a function called render, which can take any array you give it and then render it out. So potentially you could give it the old leads array as well, and it's a much more dynamic and reusable function. Let's try this. We'll rerun the code. Save awesome lead, epic lead, it works. And yes, the delete button also works. And just as a final notice, it doesn't matter what we call this parameter here. Could have called it YOLO if we wanted. However, that would require us to also change this to YOLO, this to YOLO, and this to YOLO. We rerun the code, in a lead, it works, and we can delete it. It works in the exact same way. However, we actually want to use semantically meaningful names, so let's use leads instead, like that. You're probably a little bit confused right now. That's totally okay. Let's take a closer look at how to use arguments in functions over the next few casts. Okay, let's return back to the example of greeting our users, which we've looked at earlier in the course. So on Scrimba, we have this welcome back Per Harold Borgen text, which is visible on the dashboard. And here I have the basic setup for such a feature using a function. Starting from the top of the file, you can see that we are heading into the DOM and fetching a welcome element. That is the HTML. You can see right here, this paragraph, which is completely empty at the moment. And here in the greet user function, we take that welcome element and we set its text content to welcome back Per Harold Borgen with an emoji at the end. If we run this, nothing happens, of course, because we also have to call the function greet user like that. Now, if we run it, we can see that it is rendered out on the page. And this is a very typical use case for a function, rendering out a specific thing. However, it's a really bad function because it can only render out this string right here. It can only render out my name, which is pretty silly. And it should actually rather be called something like greetPair, but that would just be stupid. We're going to use the greet username and rather modify the function so that it can greet whoever enters the app. And the way to do that is to add a so-called parameter to a function. And I can do that by writing a variable inside of the parentheses of the function declaration. So here, I'll for example write name like that. Now, it is expected that we are to use this name variable inside of the body of the function. And indeed, we are going to do that. We are going to replace this with name like that. So now we are constructing this string using the first string, then the name variable, and then the final string. Now, if we run this code, you'll see welcome back undefined. That is because name is now undefined. And can you take a guess at why? Well, it is because when we call the function, we haven't passed in any names, and our function expected us to do that. So here, in between the parentheses, we'll simply type a name. Let's type Pair, for example, run the code, and now you can say welcome back Pair. So here we are passing in a value into the function when we are invoking it. That value becomes the name variable inside of the body of the function, and this is then changed to Pair on the fly when it is called. So now I have a challenge for you. You are to give the function a parameter, which you are to call greeting, that replaces the welcome back. So it'll always greet me, but the greeting itself can be howdy or hello or nice to see you or basically whatever, because you will define it as a parameter in the function, and then you of course will call it with a value so that you verify for yourself that it actually works. Go ahead and give this a shot. Okay, hopefully that went well. The way to do this is by doing greeting here and then removing this, but rather writing greeting here and then a plus. And here, when we call it, we can do howdy and run the code. And there you can see howdy Pair Harold Borgen. Great job. Let's move on. Okay, so our function is now pretty dynamic since it can use whatever greeting value you want. So you can kind of set the tone however you want when calling the function. But we need to get back the same type of feature for the name as well. So the way we can do that is by adding a second parameter, because you can have as many parameters as you want. So actually here I can do name and then replace this with a name like that. Now, if we run this, you'll see howdy undefined again, because we have only given this function one argument when we called it, but actually it expects two, both the greeting and the name. So here we have to do comma and then James, for example. If we run the code now, you can see howdy James. So now we have a really dynamic function here. So it's a pretty good function in my opinion, but there's one issue which is not related to parameters, but related to the code quality of the function body. Because as you can see, while it made sense to use double quotes for strings when we started out, at this point, the expression has become a little bit clunky. We have 3 plus signs here, and we might even get more of them as we continue on improving this function. So at this point, it's time to refactor this expression into using template literals. So I want you to do that now, and then we are ready to add a third parameter to our function. So go ahead and change this into template literals right now. Okay, hopefully that went well. The way to do it would be to add a template literal to begin with, and then one to end the string. Then now we can remove all of these clunky plus signs and quotes. And here we have 2 variables, greeting and name, which we need to escape out from the string. So we'll do $, open curly bracket, closing curly bracket, $, open and close. Yes, this looks better, much more readable. If we run it again, you see we get the exact same result. Great job. And your job now is to add the ability to choose the emoji as well, meaning you should be able to run the function and pass in a third parameter which decides what kind of emoji that will be rendered to the page. So go ahead and try that right now. Okay, the way to do it would be the same as we've done up until now, by adding a third parameter here, emoji, and then replacing this hard-coded emoji with that variable escaped out from the string, of course, emoji like that. And here we'll need to also now add an emoji when we are calling the function. Let's try the fire one, run the code, and nice! We now have a super dynamic function that we can use to create greetings of all sorts, and it's so much better than what we started out with. Let's move on. Okay, up until now, we've only passed in strings as arguments in our functions. However, you can of course pass in whatever data type you want. For example, numbers. And I want you to practice that now. So I'm going to give you a challenge where you are to use numbers in a function that you have written from scratch. So here you have to combine what you've previously learned about functions and arguments and see if you can connect the dots together. So you are going to create a function called add that simply adds two numbers together and returns the sum. So down here on line 5 and 6, I'm calling this function and then logging it out. I'm doing that 2 times, and the first time the number 7 should be logged out, and the second time the number 111 should be logged out, because I've passed in 3 and 4 the first time around, and 9 and 102 the second time around. So these are basically your test cases. So go ahead and write this function here on line 3. It should have 2 parameters and should return the sum of those 2 parameters. And then afterwards, I will of course show you the solution as well. Okay, hopefully that went well. Let's do this. We'll do function, add, open and close parentheses, and then the square brackets. And inside of the parentheses, we need to define our 2 parameters. I would call the first one num1 and the second one num2. And here, I'm just going to return num1 plus num2, like that. If we now run this, we can see in our console we are logging out 7 and 111. Great job, let's move on. Okay, up until now, you've heard me say the words parameter when I've talked about defining variables in between the parentheses when we declare a function. And I've also said arguments when we pass in values into the function when we invoke the function. And this is probably a little bit confusing. Like, why am I using 2 different words? They're basically the same thing. And actually, to be honest, in my experience, most developers mix up the words parameter and arguments all the time. And that's totally okay. Even I, actually, up until this point, when I decided to actually explain the difference in this course, would mix the 2 up all the time. Meaning, mixing up these here values that you pass in when you call the function and these variables that you define when you write the original function. So the way it works is that these are parameters and these are arguments. And in order to remember the difference between these 2, I found a really cool comic on the web which pictures 2 people arguing in a bar and then a bouncer coming to say, "Hey, take your argument outside." And that gives us the hint. Arguments are created on the outside of the function, whereas parameters then naturally have to be on the inside of the function. So greeting and name, as you know, are only defined here on the inside of the function, but Howdy and James, they come from kind of the outside of the function, the outer scope. This would perhaps be even more clear if we had a variable here which was called hi, and we set it to howdy, like that, and then we pass in hi here. Surely this hi variable is on the outside of the function, because in this case that is this function, lines 2 to 4. This is on line 7 and line 8, so they are on the outside. Likewise here, num1 and num2 are the parameters, whereas 3 and 4 are the arguments. So with this, I want you to answer these 4 questions with either arguments or parameters. So the answer is one or the other, and you are to write that here after the question mark. So go ahead and do this right now. Okay, hopefully that went well. What are greeting and name? Greeting and name, well, that is on the inside of the function. That means that they are parameters. About Howdy and James? Well, as we've talked about, these live on the outside. When you're outside of the function, you are an argument. So they are arguments. How about num1 and num2? Okay, these are defined in the function declaration and live in the inside of the function, meaning they are parameters. 3 and 4 are on the outside of this function here, so they are arguments, like that. So from now on, whenever you wonder whether you should say parameter or argument, just think about this epic cartoon created by TypeAlias and actually consider clicking on this link so that you get to check out the blog post, which is really good. And then, to be honest, you will probably meet a lot of professional developers who can't even remember this difference, but you will. So far, we've only passed in numbers and strings into functions that we've practiced with in this little mini section on function parameters. However, you can pass whatever variable you want, actually, into a function as its parameter. So now I want you to create a function which is called getFirst, and it takes an array as its only parameter. That's why I'm writing it as ARR. And this function, when called, should return the first item in the array. So I want you to create this function and make it return the first item. And then I want you to call it, passing in an array as an argument so that you verify that it works. And you can do that by using, for example, console log to verify it. I'm not going to give you any starter code here. You got to write the entire thing because that helps you get the muscle memory. So go ahead and give this a shot right now. Okay, hopefully that went well. If not, no worries. Let's do this. We'll do get first like that, r, and then the body of the function. Then we need to take this r variable and return the first item. We do return r, open and close square brackets, and 0 inside of it. Now we can do get first, open parentheses, and pass in an array. Let's say this was a blackjack game, so we're passing in the values of my cards, like that. If we run this, nothing seemingly will happen since we've only returned this value. We haven't logged it out. Let's actually return it and store that value in a firstCard variable and then console log out firstCard. If we run this, firstCard is console logged as 10, and that is indeed correct. Great job. We are back at our Leads Tracker app, and now you are going to do what I did previously, which was to refactor the render leads function so that it takes a parameter, which I suggest you should call leads, that it uses instead of the global myLeads variable, this one right here. So hopefully you remember how I did this or are able to wing it on your own. Anyway, please also remember to update all of the function invocations across the file as well. It is a good idea to update the name as well, but it's not strictly needed, so I'll leave it up to you to decide whether or not you want to do that. Just go ahead and give this a shot right now. Okay, hopefully this went well. Let's do this. So we are going to create this function so that it rather takes in a parameter here, which we are calling leads, instead of referring to the global myLeads variable. So then we simply need to replace myLeads with what we've called our parameter, like this in these 3 places. And that's it. I also want to remove leads from the name and then go up here, change the name, and also pass in the myLeads variable. Do the same thing here. And we've cleared out the myLeads variable. Pass in myLeads, which now is just an empty array. And finally, down here, pass in myLeads like that. Let's run this to verify that it works. Save input, delete all. Yes, great job. Let's move on. In this challenge, we are going to set the stage for the Save Tab button. I'm going to write the HTML for you first, and then you are going to take over and do the JavaScript part of it. So we do a button like that. It should be called Save Tab. We run this. We can see that we get the Save Tab button, and let's give it an ID of tab-btn, like that. Now, you are first going to grab the Save Tab button and then store it in a tab-btn variable. And then you are going to hook up an event listener with this button so that you listen for clicks. And when it's clicked, you are to log out my LinkedIn URL to the console. And the way you grab a hold of that LinkedIn URL is through navigating into this tabs array that actually has an object as its only item. And that object has a key value pair of URL and the actual string value of the URL to my LinkedIn profile. So this might sound a little bit weird, like why am I forcing you to do all this complex stuff of navigating into this array and into this object and fetching out this value right here? Well, you'll understand this when we implement this with the Chrome API that actually gives us access to the current tab we're on at any given point, because then we actually have to do such a navigation. So I'm just prepping you for that. So you have to remember how to work with arrays and objects. That's great to get some practice on. If you struggle, I will of course show you the solution as well afterwards. So go ahead now and just give this your best shot. Okay, hopefully this went well. Let's do this. We'll create a const tab-btn and use document.getElementById, passing in tab-btn, as that is the ID. We gave it over in the HTML, yes. Down here, we need to listen for button clicks on the tab-btn. We'll do addEventListener. First argument is click. Second is a function that will be run when the button is clicked. And here, let's console log out just this entire expression. When you are to navigate into complex expressions like this, it's often a good idea to just take one step at a time and log out the results. Let's run this, hit the Save tab, and bring up the console. Okay, we can see now that we have our URL wrapped inside of both square brackets and curly brackets. One thing we at least need to do is navigate into the first item of this array right here. And how do we navigate into the first item, which also happens to be the only item? Well, we simply do square brackets 0 for the 0th index. Let's run this, hit Save tab, and there we can see in our console, we're now just logging out an object. So this is an object with a key, URL, and the value, which points to my LinkedIn profile. How do we get a hold of that value? Well, we use the dot notation, .url, like that. Run the code again, hit Save tab, and there we go. We have logged out my LinkedIn URL. Great job. Let's move on. Next step is to actually save the URL instead of just logging it out, because obviously this doesn't do the trick for our app. We need to save it to local storage. We need to add it to the myLeads array. And we also need to trigger a render so that the fictional lead here actually will be rendered on the page when the user hits the tab button. So to achieve this, you basically need to do more or less the same thing that you're doing inside of the input button. So hopefully you've got this. If not, no worries. I will of course show you the solution when you return back to this screencast. Okay, let's do this. So the first thing I want to do is push it to the myLeads array. So we'll do myLeads.push and then pass in this expression right here, like that. Let's comment out this one for now. Next up, we need to save the myLeads array to local storage. Luckily though, we know how to do this. That's the exact same line as we have down here. Local storage.setItem. The myLeads, which is the key, should be set to the stringified version of the myLeads array. So let's just remember how this looks and rewrite it up here. I want to rewrite it because it's a little bit of a complex expression, so it's good to get that practice. Local storage set item. Which item? Well, it's the myLeads key, which is what it's called. And here we are going to set it to the myLeads value. However, we need to stringify this value first. So we'll do JSON.stringify, open parentheses, close parentheses, and a lot of spaces here so that you understand what happens. This is the array, and this is the stringified version of that array. So the array turned into a string. We can do it like this, I think. Okay, looking pretty good. Now, final thing we need to do is actually trigger a re-render. Because we have pushed something to the myLeads array, now we want to render it out with the render function and pass in myLeads as the argument so that we actually get to see it on our page. I'll run this code, bring up the mini browser and hit the Save tab, and there you go. We got our URL rendered to the page. Let's combine it with a lead as well. Awesome lead. Yeah, there we go. And delete all. Ooh, nice. It works. Really good job. So we now have a working dummy version of our tab button. However, it's kind of useless because if I hit the Save tab here once, twice, 3 times, you can see we're just rendering out our hard-coded tab URL, which we have here. So what we of course rather want to do is the following. We want to be able to open up our Chrome extension on any URL, and then when we hit the Save tab button, the extension should head over to the address bar here, grab a hold of this URL, and then boom, save it in our list of leads. So my question for you here is, where in our code, that is on which line, should we go ahead and try to talk with the Chrome API to ask it for the current tab URL? Just take a guess at where in this file we need to do that. Well, the place we want to do it is right here. When the user has clicked on the tab button and this function has been triggered, here on line 20, we want to grab the URL of the current tab. Basically, what we are doing here, but we want to do it in the real world, not just using the made-up hard-coded array I've written up here on line 14. So then the question is, well, how do we ask the Chrome browser for this URL? And yet again, we will resort to Google. We'll simply write Chrome extension get current tab. That gives us a bunch of results. And on first place, you can see the developer.chrome.com, so the documentation. If we head into that, you will see chrome.tabs. Okay, description. Use the chrome.tabs API to interact with the browser's tab system. Sounds about right. If we scroll a bit down, we'll see manifest. So it turns out that we have to do some changes on our manifest file. Namely, we have to add this permissions and then fill in tabs. Okay, that's fine, but not really what we're looking for. We're looking for the JavaScript code in order to actually grab a hold of the tab URL itself. If we continue scrolling down, we get to this really discouraging list of a bunch of methods of this API. And this is so typical. When you're searching through documentation, it's very often difficult to find the answer as a beginner. So actually, what I would do is go back to the results we got on google.com, because there we can find a Stack Overflow question that looks much more humanly understandable. How can I get the current tab URL for a Chrome extension? Okay, let's click into that one. You can see there's a person that has a problem that looks like ours, and that person has even provided some code of how they're trying to solve this today. Chrome.tabs.getSelected. Let's scroll a bit down and find an answer, because that's normally where we find a piece of code we can use. So here you can see, just an FYI for your info for people from Google, the method the original poster uses is deprecated. Okay. To get the tab the user is viewing and only in the window they are viewing, use this, chrome.tabs.query. Okay, and then we pass it in an object with some data and we get this function with tabs and a lot of code. But actually, it looks very promising. So what I'll do then is what all developers do almost every single day, which is to copy code directly from Stack Overflow. So I'll copy this and just paste it in here, because this is where we want to talk with the Chrome API. I'm going to remove this comment. And now we suddenly have this hairy, strange-looking code, which we haven't written. That's not comfortable. And we can also see that it's not following our conventions for writing code. For example, it uses semicolons, which we don't like that. And it also uses the var keyword, which we don't use either. It's the old way of writing variables in JavaScript. We want to replace that with let or const. Now I'm just going to use let, as I'm not really sure what the point with these variables is at this point. I just want to clean it up. And storing them as let variables will definitely work. So let's just do that. However, now that we at least have the code according to our conventions, it's time to break this down and really understand it. And we'll do that in the next cast. Okay, now that we have this little snippet of code which we copied from Stack Overflow, it would be really tempting to actually try to run it and just console log out tabs at this point, for example, just to figure out what's going on here after this function is being triggered. But actually, if we try to do that, run this code, hit the save tab, we'll see that we get an error. Cannot read property query of undefined. That's because Chrome.tabs, that's a so-called API, application programming interface. Sounds really scary, I know, but don't worry about that now. All I wanted to say is that this is an API that is only available to us when we're running the code in the context of a Chrome extension, like this, which you can see here. Now we are running the code in the context of this Scrimba mini browser here, and we don't have access to the Chrome.tabs, meaning it's undefined, as our error message is saying, because it's trying to read the property query of something that is undefined. So we actually just have to try to make sense of this code and try to configure it how we think it should be, and then deploy it to see if it works out in the wild. So what I'm going to do, I'll delete this console log tabs, and actually I want to delete everything inside of this function, because we are going to figure out what we will do inside of this function on our own by looking back at Stack Overflow. And also, I actually want to comment out these lines of code, because while it's okay to copy to get it into the code base, I want to write it with you to break it down step by step so that you understand it properly. So with this in the background, let's rewrite it and see if we can make sense of it. So the first thing we write is Chrome, which is a variable that we'll have access to when we are running the Chrome extension. And that is an object, and that has a tabs key. And the tabs, that is an object as well. And that object has a query method like that. So here we're kind of saying, hey, Chrome, I want to grab a hold of your tabs. Or more specifically, I want to query you for some of the tabs. Well, then which tabs is the next question, and we'll specify that inside of the query using an object. To begin with, I'm going to say, well, I want the active tab. As I'm specifying, active has to be true. And which tab is that? Well, if we look back at our slide here, you can see that in this situation, we have one browser window that has 3 tabs, but it's the LinkedIn tab that is the active one. So it will give us this tab. However, here we can also say that we ought to specify current window to be true as well, which is a little bit weird. What does that mean? Well, imagine this case. If you actually had another browser window in the background, well, the Chrome API would know about this. So naturally, you'd have to specify, well, which one of the 2 windows are you looking for? And in this case, the active window is the one in the front right here. And that is where the LinkedIn tab is located, where we have our Chrome extension open. Also, we have to specify, well, current window. So we need that to be true as well. So here we are calling the query method and passing in an object that describes which of the tabs we want. And then, as we did up here, where we start with a specification and then write a function as the second argument, we'll do the exact same thing in the query function as well. We'll write function like that. And this function will be triggered when Chrome has found the tab we have told Chrome to look for. And when Chrome triggers this function, it'll give us a tabs variable like this. It's a parameter in this function. So now we would get access to the tabs. And this console log would work if we were running this in the context of a Chrome extension. Let's now bring down the console, break this up a little bit, because the question is here, what do we want to do inside of this function? Well, it's through this tabs keyword here that we will actually get a hold of the URL, the string in the address bar. So it's inside of here that we actually have to push to our myLeads array, save to local storage, and call the render function. So I'm actually going to copy this code and paste it in here, like that. And now the question is, well, what does this tabs variable include? How do we navigate to the URL value inside of this variable? Well, it just so happens to be that it's constructed in this exact way. And how did I know that? Well, because here on Stack Overflow on our question, we could see that on the question below that a person got it to work by doing var tab equals tabs 0, which is exactly what we're doing here. And then on the next line, it did tab.url, which essentially is our .url here. So it turns out that this is the way to get a hold of the URL. But at this point, there's a little problem. Since we have defined tabs here and also up here, these two variables will be in conflict with each other. And obviously, we don't need this hard-coded variable anymore. We want to use whatever value we get directly from Chrome. So we can keep this and just leave this how it is. Now, let's clean up this a little bit. And then finally, head over to manifest.json, because we saw in the Chrome extensions documentation that we had to add the following to our manifest file. So permissions, and then that is an array, and here we specify tabs. So now we are telling Chrome that we want to be able to work with the tabs in the Chrome extension. Otherwise, this chrome.tabs simply wouldn't work. So in the next cast, we'll go ahead and deploy this so that we finally get to try our entire application out in the wild. So let's deploy the final version of our app. First, you of course have to download the zip from this scrim, and you can do that by clicking on the settings icon in the bottom right corner and then download as zip, which we did the last time around as well. And then make sure that you take these files and update the lead tracker folder that we also created in a previous cast. Or if you have been working locally alongside me, you of course can skip this step. But what's important is that the same folder gets the new updated files. Because then we head over to the Chrome/extensions page. There we can see our lead tracker from previously. I'm going to hit details so that we open up the page for our extension. And there you can hit update. By doing that, Chrome will grab a hold of the new files and update your extension. Once that's done, we can open up a new tab, for example, and head over to a lead we want to track. Here I've opened up Scrimbus CTO's GitHub profile. That's Sindre. Let's say we want to track this URL as a lead. Then I'll hit the Chrome extension button. I'll choose my leads tracker. And here I can try Save Tab, and boom, our Chrome extension headed over to a tab, grabbed the URL, and displayed it for us. That's awesome. We can also try our input field by just passing in a random lead, hit the save input, and there we go. It was placed here below the URL to Syndra's GitHub profile. So far, so good. Let's open up a whole new tab now. For example, Leanne's LinkedIn profile. You probably recognize Leanne from the Scrimba community, as she is our community manager. Let's open up the Chrome extension again and try the Save Tab button. Yes, it worked. Really good. Now, the final button to try is the Delete All, and I'll hit that, and there you go. We have deleted all of our leads. This is so cool. We've now created a real-world product that can give value to sales development representatives, or basically any person collecting leads online, which is an activity that people in almost all companies do. So we have really created something of value that you can share with the world. So your JavaScript skills are starting to become dangerous. Congratulations, you have reached the end of this section and actually built your own browser extension. How cool is that? And you should be goddamn proud of yourself for achieving that. And just enjoy the fact that you've learned all of these awesome concepts that we now are going to recap. So, what did we learn? Well, we started out with the const variable. That is a critical part of JavaScript, and as you can see, once we learned it, we started using it much more than we used let. For all of these DOM elements that we stored in variables, we used const, as we were not going to reassign these. And speaking of DOM, we learned a lot of new things about the document object model. First and foremost, the addEventListener. Down here at line 14, we hooked up an event listener with the tab button, for example. This gave us the benefit of not having to write the event listeners in our HTML. We controlled everything in the JavaScript file. And then also we learned about inner HTML. Down here at line 33, we had to use this because the .text content property just didn't do the trick when we want to render out list items like this. And finally, we also learned input value, which is another part of working with the DOM. And that was down here when we fetched out the value which the user had entered into the input field. Another thing we did is take one more step into the world of functions, namely we learned about parameters, which is what we defined here. We defined a leads parameter in the render function, and that gave us the ability to use this variable inside the body of the function. And also it required us to pass in the argument of myLeads when we invoked this function. This is a crucial concept to understand if you are to make functions really reusable. So I'm really happy that we went through this. Next up, a super cool thing we also learned was template strings, because that gave us the ability to write strings on multiple lines, which looks much better. It's easier for humans to parse. And also we could use this $sign and square brackets in order to escape out of the string instead of having to use these plus signs, which quickly became unmaintainable and confusing to work with. And then a super cool thing we learned was local storage. Here we saved things in local storage so that we could work across page refresh. This is kind of your first exposure to a database. A very simple database, of course, but still very much the same concept. And that forced us also to learn about JSON, which is a very common way of storing data in web development. You were forced to deal with this since you had to turn our array into a JSON array using json.stringify, and also we had to use json.parse to go the other way around. When we fetched a string from local storage, and that string just happened to be a JSON array, and we could parse it and turn it into a JavaScript array using the json.parse. Don't worry if you are confused about JSON parse and JSON stringify. It's totally okay to search for which one does what every single time you do it. I've done it again and again and again. But JSON is core. And one testament of that is the fact that you were exposed to JSON also in another way, namely with the manifest.json file. Here we had to configure our app, and I'm actually glad that the Chrome extension required this because you will see JSON in many different scenarios as you work as a web developer. Finally, one of the last things we looked into was objects in arrays. Namely, this tabs array here, where you actually had an array where its first and only item was an object. So you had to first fetch out the 0th index and then do .url to fetch out the URL value of that object. And this is very common. Objects shoved inside of arrays. So it hopefully shouldn't scare you that much the next time you come across that. So look at this list. It is really comprehensive. And now let's do a little thought experiment, which might help you feel less overwhelmed of all the things you don't know anything about in web development and all these fancy words. Because let's say that you for 2 weeks ago asked a developer, like, how do you create a Chrome extension? And then the developer arrogantly replied to you, well, it's not hard. You just add an event listener to a button, then fetch out the input.value, take that value stored in an object and convert it to a JSON using json.stringify, shoving it into local storage, no big deal. You could just fetch it out later and use json.parse in order to get it back into a JavaScript array, and then render it out in the function, shove it in as a parameter, and just use a template string and inner HTML to display it on the screen. I mean, no big deal, right? I mean, imagine getting such a reply. You would probably feel that you would never ever learn all of this because there's so many concepts you didn't understand. But actually, that reply from the developer is actually the exact thing we have done. And you have gone through it. So even though in and of themselves these names sound scary, you know that if you follow the right course, you can learn them. And you don't have to be afraid of any of the concepts you have yet to learn. Because whilst they sound super fancy from the outside, like JSON, actually, they're not that complicated when you look into them. So try to just have that confidence in yourself that you know you can learn complicated 3-letter acronyms, that they're nothing to be afraid of, because that'll calm you down and serve you well as you progress on this journey into web development. With that, let's actually put your skills to the test now, because you need some more repetition on these things. You need tons of repetition. These things take a lot of time to really get into your muscle memory. And we'll start with that in the next section, where you will do some quick challenges back to back. Let's move on. In this challenge, we are going to do some let and const repetitions, because I've created this fictional game here, which has a player, an opponent, the name of the game, a points variable, and a has1 variable. After it's been set up, the game is played down here at line 9 and 10, the player gets some points, and the has1 variable is flipped, and then based upon this, we log out who the winner is in this conditional statement down here. Now, if you try to run this code, you'll see that it actually doesn't work because I've mixed up a little bit in terms of using let and const. So you need to fix that. You need to go through all variables and decide if they should be let or const. And then finally, I want you to change the console logs here from using double quotes to using template strings. So go ahead and do this right now. Okay, hopefully this went well. Let's go through this. Now, what I want to start with is actually by looking at which variables that are reassigned. And that is actually just the two ones down here, points and has1. There's no reassignment below and neither above. That's just the initial assignments. So that means that the points and has1 are the ones that must be let variables. Because remember, let variables can be reassigned, consts cannot. So we'll do let and let. And these two need to be so. That means that these three variables point to the same value throughout our entire program. It'll work perfectly fine with using let, and if you prefer that, that's also okay. But it is a good practice to use const when you can, to enforce a bit more strictness in the code and to hint to people who are potentially reading your code down the line that these variables won't be reassigned. So actually, I'm going to do that and use const for these three variables. Now we can run the code, and yeah, we can see that it actually works. Pierre got 100 points and won the Amazing Fighter game. That comes from this string right here, which we want to turn into a template string. And the way we got to do that is now wrap the entire expression in backticks. And here we're starting off with a JavaScript variable. So we'll escape out of the string like that. We'll remove all of these plus and quotes, yet again, $, curly brackets. And then we also need the escaping here as well. Let's run the code. Works just as it did previously, but now we have this much more neatly packed expression. Doing the same here, like that, and that. Like that. And that's it. Great job doing this challenge. Let's move on. In this challenge, you are going to create a function that takes a single parameter, that should be an array, and then it logs out all the items of the array to the console. And I've created this myCourses array here so that you can test your function. Go ahead and write this function starting here on line 7 and then return back to me when you want to see my solution. Okay, let's do this. We'll do function. I'll call it log items, like that. I'll name the parameter r. And then inside of the function, I need to write my for loop for let I equals 0. I is less than r dot length and I plus plus. And in the body of the for loop, we'll simply do console.log ri, like that. Let's try to run the code. Log items, passing in myCourses. And we get Learn CSS Animations, UI Design Fundamentals, and Intro to Clean Code logged to the console. And these are all courses that you can take in the future when your web development skills are a little bit further down the line and you're ready to truly level up your design skills and your software craftsmanship. But enough about that for now, let's just move on. Okay, now we are going to verify that you actually know how to use local storage. So you're going to do three things. First, save a value to local storage. It could be any value, a simple string, an array, that doesn't matter. Just choose whatever you want and give it whatever key you want as well. Then I want you to delete that code and refresh the page so that you start with a clean slate again, because this highlights the power of local storage, the fact that you can come back, fetch values from local storage in a context which is completely unrelated to the time when you saved to local storage. So your third step is to fetch the value from local storage and log it out. So go ahead and give this a shot right now. Okay, let's do this. First, we're going to do local storage dot set item, open and close parentheses, and let's do my credits. This could, for example, be in an e-commerce shop where you gifted credits to people who came to your website on a certain day and saved it in their local storage. And maybe you got 100 credits this time. I'll run the code. Seemingly, nothing happens, but let's hope it works, because now I'm going to delete this and also rerun the code again. I'm coming back on a later day, and now I want to do local storage dot get item my credits, like that. Let's store that in a variable, my credits equals local storage, and then console log out my credits as well. Running the code, and yes, we are logging out 100, meaning that our local storage implementation works. So give yourself a pat on the back and let's move on. In this challenge, we are going to repeat addEventListener and how to fetch out values from objects that live inside of arrays. So it's a three-part challenge. First, you are to fetch the button from the DOM and store it in a variable. The button I'm talking about is this one right here. You can see it says log Jane's score. It's defined here in the HTML, so maybe you have to modify that as well to give it an ID. I don't know. And then once you have that button stored in a variable, you are to use addEventListener to listen for button clicks. And when the button is clicked, you are to log out Jane's score. And you got to do it via the data array. So you got to head into data, find Jane's object, and log out the value of her score. So go ahead and give this your best shot right now. Okay, let's do this. So first we are to fetch the button, and as we saw, the button didn't have any IDs, so it'll be hard to grab it. So I'll give it an ID, call it Jane-btn, like that. And then I'll do const Jane-btn equals document.getElement by ID, passing in Jane-btn. Okay, so far so good. Now we need to use the Jane button to add an event listener onto it. What kind of events are we listening for? Well, it's click events. So that's the first argument. The second one is the function we want to trigger when the button is clicked. So let's verify that this works. Button clicked. I'll run the code, click the button, and yes, indeed it works. Now we have to head into data, and data is an array. So let's actually log it out first. Okay, so we got an array with two objects. How do we get the first object of those two? Well, we know that we can use the square bracket syntax and put in the index of the item we're looking for. So I'll put in 0, run the code, click the button. Yes, we're only logging out Jane's object. How do we get the value of 52? Well, we need to use the dot notation and use dot key or dot score in our case. We run the code, log, and boom, we are logging out Jane's score. So, great job getting this far. Let's move on. Okay, now I have a really cool challenge for you because you're going to create a sentence generator. So it's this function right here. It's called a generate sentence, and it takes two parameters, desc and r. What's that? Well, it is a description and an array. And it should return a string. Actually, it's a full sentence based upon the description you pass in and the array you pass in. And it's best understood through the lens of a couple of examples. If you pass in largest countries as the description and the array China, India, USA as the array, that is the second parameter, then the function should return the 3 largest countries are China, India, USA. Another example, if you pass in best fruits as the description and apples, bananas as the array, it should return the 2 best fruits are apples, bananas. So you actually have to construct the string, fetch out each of the items, and also the length of the array. So a little bit tricky, but give it your best shot. Use a for loop and also a template string to solve this. And if you're stuck or want to see my solution, just return back to the screencast and I will of course show you how to do it. Okay, then let's do this. I'm going to first start by creating this string right here. So let base string, that's what I'm going to call it. Use a template string and do the, and then here we can't hard code the number as it's dynamic based upon how big the array is, because we're going to do r.length. And then there's a space and then a new $sign and curly brackets. And here we are to fill in the description, and then r and a space. Now we have the base string. What remains is simply adding each of the items to the end of this. So we'll do for let I equals 0. I is less than r.length, incrementing upwards. And then we'll do base string plus equals r, then using our iterator value. So that'll fetch out the specific item, but also remembering to add a comma after each of the items. Now let's try this. Generate sentence. Let's do highest mountains and do Mount Everest and K2. We'll store the result of this in a sentence. And of course, then we also need to return the base string like that. And then finally console log out the sentence. Okay, not bad. We got the 2 highest mountains are Mount Everest, comma, K2, comma. Okay, 2 things to fix here. First, we need a space after the comma, like that. Good. Secondly, we don't want a comma after the final item in the array. How do we fix that? What we need to do is inside of the for loop, check if we are at the last item in the array. And what is the index of the last item in the array? Well, it is 1 less than r.length. So let's do outside of the for loop, const last index equals r.length minus 1. And here we'll do if I equals last index, then we are going to do like that. Or if else, we are going to do like that. So what are we doing here? In this situation where I am passing in highest mountains and these 2 mountains, the first time of the iteration, I equals 0 and last index equals 1. So going through this for loop, it checks is I equals last index, is 0 equals 1? No. So we're not doing this. We're instead jumping to this point where we are adding the comma. But then the next time around, both last index and I equals to 1. So JavaScript will run this piece of code instead. Let's try it to verify that it works. Yes, we've got it. So this was a challenging one and required you to think a little bit out of the box, but that's how it is as a developer. So I hope it didn't scare you too much. If it did, just watch it over again. Try it again now that you've seen the solution, and then I will see you in the next cast. In this challenge, you are going to imagine that you are working for about the hippest company I've ever seen. This one right here, the Brooklyn Agency, who currently consists of these super hip people right here. Your job for this agency is to make their code a little bit more dynamic, because now you can see that they have simply hard-coded out the 3 team images inside of this container, but that isn't a particularly good solution. because when they get a new employee, they would have to update the HTML. So it's actually much better to do this using JavaScript and create a function that renders out the 3 team images, because that sets the stage for easily connecting this data with a database so that you can just update the database in order to change the team if new people join or someone quits. So that is your challenge, creating a function that renders the 3 team images. And this function should be using a for loop, template strings, plus equals, and .innerHTML in order to solve the problem. Here I have provided you with an array that contains the paths to all of the images. You can see images / hip1.jpg and hip2 and hip3. And they are located over here in the images folder. And this is actually a very common situation where you get an array of paths which point to the data you need. So we could imagine that this, for example, had come from the database when you rendered the page or something like that. Right now, though, it's just hard-coded into our JavaScript file. There is a little bit of CSS here as well, but this challenge is not about CSS, it's about JavaScript, so we're just going to ignore that. Just make sure that the images use this class of team img, and you'll be just fine. So I'm going to comment out all of these images. Now we can see we cleared out the container. And I'll leave the table to you. Go ahead and solve this challenge. Okay, hopefully this went well. Now let's do it together. I'll start by grabbing the div with the ID of container, because we know we need that one. Const container equals document get element by ID container, like that. And then the function, I'll call it render images, like that. And here we need a for loop, since we are going to loop through this array. So I'll do for let I equals 0. I should be less than the length of the images array, like that. And we'll increment upwards. In here, we can use .innerHTML directly. Let's do that first and then refactor it a little bit after we've gotten it to work. So I'll do container.innerHTML plus equals. At each step in the iteration, we need to add to the current innerHTML, not just clear it out using equals. Here we'll do img class of, see what the class was, team-img. Okay, we'll do team-img. And the source should be each of these items right here. We'll use $ curly brackets to escape out of the string, and use imgs, passing in the current index, which starts at 0 and ends at 2, meaning 0, 1, 2, perfectly suitable to use in order to fetch out items from this array. Closing the tag. Now the final step is to make sure that we run the function, which we'll do by render images, like that. We'll run the code, and boom, there we go. We have rendered the images out. Brilliant. Now let's refactor this code a little bit, because there are 2 things I would fix up here. The first thing we're going to fix is the .innerHTML in the inside of the for loop, because here we are interacting with the DOM 3 times, 1 per each iteration of the loop, and that has a cost. Manipulating the DOM has a performance cost. It takes a little bit of time that we'd like to avoid if possible. Now, it doesn't really matter when we're only rendering out 3 items, so we as humans won't be able to notice the difference anyway. However, it's a good practice to do it the most performant way, just to know how it's done, because it comes a day when you need to render out tons of things and manipulate the DOM quite a lot. And then it actually might matter. So let's fix this. What we'll do is we'll simply create a variable up here, for example, images DOM, and set that to an empty string. Then instead of manipulating the DOM 3 times down here, we'll simply concatenate this string onto this string. So we'll replace this entire thing with imgs DOM plus equals this expression right here. And now after this for loop has completed, this variable contains all the 3 images, and it's time to do container.innerHTML and set that equal to imgs DOM, like that. If we'll run the code, we can see that it works in the exact same way, just as we expected. So no visible change for us as humans, but we know that the performance under the hood is better since we're not doing DOM manipulations again and again. We're only doing it once. Okay, the final thing we should add is an alt attribute, because that is important for accessibility purposes, so that people with, for example, screen readers can understand what the images contain. And here we can do employee in the company, like that. Now we have solved this challenge and we've made it even better than the previous solution, since we now also use an alt tag for accessibility purposes. So, great job. So, you have reached the end of this course. That's very well done. You should truly be proud of yourself now. Give yourself a pat on the back and just feel great about yourself, because not many people get to the finish line. They give up, but you're not a quitter. And even though this course is finished, you should by no means stop learning. So the real question is, what now? What should you learn next? And the most important thing is that you continue building more stuff. That's how you learn. If you just build enough stuff, everything else will fall in place. But of course, let's be a bit more specific. There's still a lot of basic JavaScript concepts that we haven't gone through, and it's a great idea to continue expanding upon your basic JavaScript skills. And then when you've done that, you can move more into ES6 and beyond, aka modern JavaScript. ES6 is short for ECMAScript 6. That was a legendary update to the JavaScript language in 2015, so it's actually already 5 years old. But many of the modern patterns in JavaScript come from this update. And actually, you've learned several of them already. I just didn't bother telling you that they were a part of the ES6 specification. So you are totally ready to continue learning more about modern JavaScript. Another thing you definitely should learn is APIs and asynchronous JavaScript, because that opens up the world to you. You'll be able to have your applications talk with external services, third-party APIs, bring in data from wherever you want. And then, of course, there is server-side JavaScript, so that you can build full-blown apps from start to finish. But this probably looks a little bit overwhelming, but don't worry, I have the solution for you. Here at Scrimba, we have something called the Front-End Developer Career Path. It's our flagship. It's the course we put the most effort into by far, and it'll take you to a hireable level as a front-end developer. So looking at the contents here, it goes all the way from learning basic HTML and CSS to getting hired. And actually, you can jump in here in Module 3, because the course you just took is a part of the career path as well. So if you like our style of teaching, with a lot of projects and challenges back to back, you can just jump into Module 3 and continue on in the same pace. So I hope I will see you there. And if not, best of luck with your continued JavaScript journey.